Hello, good afternoon, everyone. Welcome to day 3, FOSSASIA Summit 2021. I hope that you are all ready for the day. We will start shortly with the blockchain panel. I created a small poll in the chat. If you could let me know. So yesterday we had a lot of fun together with the participants. There was a lot of interaction between the speakers and everyone. A lot of people give us feedback. We received email in the evenings, and it was really fruitful session for everyone. So we were very happy and all ready for today. If you can see my screen, just a few reminders for the day. Please make sure to mute yourself when the session starts, and that including the moderator. Self-service, if you haven't noticed yet, if you see that the video is playing and you're not be able to hear the sound, please just hit play on your browser. You can also control how you want to see the presentation on the right-hand side, just below, like you see my screen, right? So on the top of the presentation, you see a small minor icon where you can actually zoom in and out the presentation. Use the public chat for normal conversation. For instance, I can say here, hello from Berlin. Yeah, so if you can let me know where you are. And then the channels, the channels for Q&A. So the first session will be the panel. If you have any question for the panel that you can already put in the answer. Discussion room. So the session will end and finish. We try to start and finish according to schedule. If you have more questions, you want to discuss more with the panelists, please feel free to type in the chat and invite them to this discussion room, where you can have more conversation. In the discussion room, everyone has the right to turn on your video, and we also have the chat room if you just want to chat. Yes, so we are getting started in a moment. Let me check if all the... Hello, Brian. Thank you very much for being here. What time is it where you are?
It's just 10 p.m. It's not that bad.
10 p.m. in the evening. Mm-hmm. So it's already after office hour. Really appreciate you take an effort to join us here today. So I just want to say that I've been involved in the community a lot, and I heard people say that they want to engage with the Asian community, but people hesitated to come to the summit and of different time zone. But you did make a lot of effort to join us here today, despite the time zone. Thank you very much. Raurang, I see that your name doesn't show up. Would you like to update the profile so people can see you, can see your name?
Yeah, I don't know. I'm trying to find out how to change the name. Yeah.
Okay, so it's very simple. So I will just show my screen that everyone can also see in case they want to change there. Okay, so you see my screen here, right? Yeah, if you go to the event website, on your name, on your profile name, you click into the account, and here you have the option to put in your name and also your public profile. And after that, only need to update the change and refresh the page. Raurang, do you use? Yeah, see that. Okay, perfect. Okay, good. So I see that Mario is also here.
Yes. So hello. Hello, Brian. Nice to see you. So I'm still wondering about the other panelists, because I think their name might not show up yet. But I see Goran already fixed it, so I'm not sure who are the other panelists yet. So if the other panelists could switch on their mic and their video, and to ensure they are here.
Yes, you are here, correct. We can see you, and we can also identify you with your name.
Let me quickly ping the other panelists to see if they're here. Okay. I'll ping them on WhatsApp.
Okay. I think Ed is in London, right? So it's still very early for him.
Looks like Eddie might have been confused about the time and thought it was in an hour, so he's joining now. Or hopefully soon.
Yeah, it's quite challenging. And you also had a time switch in the US?
Yeah, that's also
Yeah.
another thing.
Daylight savings time, an archaic, and it's only 60 years old, but it's completely archaic, and it was designed to try to make sure everyone woke up when the sun woke up, at all times of the year, something crazy like that. It actually costs us quite a bit in energy consumption to do it. So I think a lot of people would be very happy to do away with it, but then we'd have to change everything all over again.
Yeah. So, but like actually we also have it in Europe, and in Singapore, like it's there's not so much change as it is at the equator. So there's no change there, right?
Yeah, let's wait for a couple of minutes. Otherwise, we can start the panel. I think I'm messaging them. Yeah, Eddie is joining now.
Are there viewers beyond the 20 that we see in the user list here?
Yeah, so we are showing this on YouTube, and it's being streamed on different channels.
Excellent.
And yeah.
Hello, everyone. It's like being on stage.
Yeah, so the thing is, some events, they don't have this option that you can actually see some of the participants, and like communicate a bit. And our idea was this, that here we can see at least have some form of interaction, or feel like that there are some people, right? Like even if it's like on different channels streamed and like shared, at least here at the event, we have a room where we can interact, and also like people can join and ask the question. Yeah.
It's going to be hard for me to go back to face-to-face events where I can't back-channel chat with the other panelists or even people in the audience, because you can't sit on stage and type into a phone. It's a lot easier to do it in a virtual event, though, like this.
Yeah. Well, I can't believe it, because I saw so many events with a lot of people with you. So I think you won't have a problem, right?
So I'm sad that I can't actually travel to Singapore for this. I would love to have been there in person. Maybe next year.
Actually, I was at one event, and Gaurang, you were also there in Singapore with Brian. Do you remember? Yeah, but there were so many people, so everyone just jumped on you, Brian, and tried to catch you.
That was fun. I remember that.
Yeah, that was a long time ago.
Everything feels like ages now in this time.
Yeah, it's like pre-COVID and post-COVID.
Exactly, right.
Right.
VC and AD. Yeah, great. I think we should start. Eddie is trying to join. He should join in a couple of minutes.
Yeah, so
Mario,
I want to ensure if Eddie has a problem, I can definitely support him with login. I don't know. So Hongfok, what is the plan today? We have the blockchain track. So there will be also like talks, for example, from Thomas. Thomas, he is based in Singapore. And yeah, from Standard Chartered Bank. Anything else, Hongfok? What's going on today? Then we have workshops with the building blocks community, and that will be on-site in Singapore. So actually on-site in Singapore is currently possible. Up to 50 people even can gather. And these workshops will also be shared online. So if you're interested what's going on, you can join in the Lifelong Learning Institute room here on the platform. And we'll have talks about hardware from Raphael Lee from Shenzhen, from Juan, he will be joining us actually from the US, and from Masafumi Ota from the Raspberry Foundation. He's based in Japan. And also we'll have a workshop about data science then towards the end of the day. And our old friend, Mitch Altman, who's very well known in the hardware community. His passion is like, he just wants everyone to solder. So he will have an online soldering workshop and then show us one of his projects, the Ardu Touch, where you can build your own music synthesizer kit and make music sound and noise. So that will be very nice. Okay, cool. I think we're still getting started.
Yes, and the most important talk of the day, Mario, you did not mention.
Because I wanted to put the most important thing for the end. Yeah. So of course Brian is here. You already see him, and Brian will give his keynote on the state of Hyperledger and enterprise blockchain. So as we know, there's a lot of activity. There's a lot happening, and we're looking forward to the talk of Brian. So definitely. The keynote.
So Brian has promised us not to give away too many things on the panel before the keynote. Great. So should we start? I think Eddie and Ansel both are joining now. So I think,
okay, sure. So thank you everyone for joining. And we are starting our session here on blockchain. There have been a lot of questions, always like how blockchain is like doing in the tech community, and a lot of people are often surprised when they hear that blockchain is actually using mostly open source software. It's coming from many people who have been involved in the open source software, and the question is really like how open source has helped proliferate blockchain. So we have different panelists here, and at the beginning I would like to ask Gaurang to introduce like a bit the subject, and also like Brian, and the panelists then will be joining us after the introduction. So Gaurang and Brian, I leave the stage for you, and we will join then with the others afterwards. Thank you very much. Please go ahead.
Great. Thank you, Mario. So welcome, Brian. So today we're going to talk about how open source has helped proliferate blockchain technology, right? Technology is built on open source. So the ecosystem, the supporting apps, is what we call decentralized apps. The whole blockchain has,
Gaurang, your audio is very choppy. I don't know if there's anything you can do on your side to restart.
Yeah. Is it okay now?
Now we can hear you, yeah.
Yeah, that's fine. One other thing, are you intending to show slides? Oh, okay.
Yeah, so I was saying what open source community brings to the blockchain ecosystem are mainly two things. One is very important, which is the community aspects of open source. And second is the security aspects associated with open source. Because see, usually when open source software, it's open by nature, right? People can see the code. And hence, a lot of people try to keep attacking on the blockchain systems. And hence, inherently, blockchain systems, I would say, are more secure than any closed source systems. Because for any closed source software, the companies or the foundations, they have to spend a lot of money on securing the software. But open source, I think, is inherently more secure. So yeah, with that, let's go to the panelists. I would ask both Anson and Brian to introduce themselves. So Brian, maybe if you can introduce yourself first.
Thank you, Gaurang, and thank you everyone watching. I'm Brian Bellendorf. I work for the Linux Foundation, where I'm general manager for blockchain, healthcare, and digital identity initiatives. At the Linux Foundation, I've been leading the Hyperledger project since shortly after it started in 2015, and now also lead the Linux Foundation Public Health Initiative, which has been active in using open source software to fight against this pandemic and future public health crises. Let me stop there and hand the mic on.
Anson, you want to introduce yourself?
Hi, everyone. Sorry for that. Hi, my name is Anson Zeal, and I'm the chair of the quite a number of nonprofits, but the main one I'm working on is the IDEXA, which is the International Digital Asset Exchange Association, as well as the chair of the Singapore Cryptocurrency Association called Access. I've been in this space since 2013. Also know Eddie and Gaurang as well for a long time, and thank you for the invite for this. And yes, I'm going to enjoy talking about why blockchain being open source is very important.
Eddie.
Yes, hi. Thank you, Gaurang, for the invitation. Yeah, I'm Eddie Trapp. I'm CEO and co-founder of Coincilium. We have been investing in blockchain companies since 2013, started an incubator in Asia, and then 2015, Coincilium got listed in London on an exchange called Acquis, and now it's also listed in the US on an exchange called OTC Market. And I'm also the regional director through a joint venture we have in Singapore of IOV Labs. IOV Labs runs the RSK smart contract sidechain. It's called the RSK blockchain. It's a smart contract enabled sidechain on Bitcoin, and is actually as well a member of the Hyperledger Foundation. So I'm also very happy to see Brian here.
Great, thank you all of you. And I'm Gaurang. I'm the moderator for this panel. I've been a smart contracts developer since 2016, and I've been writing smart contracts on the Ethereum blockchain using Solidity for a while now. So great, it's a great pleasure to have all of you on the panel today. So let's start with the questions, right? So the first question is for Eddie. Eddie, can you talk a little bit about how you've seen various Bitcoin and blockchain protocols evolve over time?
Sure. So, you know, I as I was saying, I started quite early in this space, 2013, and I think open source has been really a drive for a lot of innovation. I mean, in this space, I think it has always been quite an important aspect of blockchain companies, Bitcoin companies out there who wanted to build on top of what has been done. I mean, we know today that composability is very important. We see today with new trends like DeFi and so forth that everybody's building on previous tools that exist. So I think open source is really important for that, obviously. And as well, of course, RSK is an open source smart contract platform for Bitcoin as well. So it's also very important in that sense. So in my feeling, you know, today for a lot of people in the audience, it may seem like a no-brainer that you should have been involved in crypto 7-8 years ago, right? But actually, now that Bitcoin is very high and everybody's talking about DeFi and NFTs, but I think people like Anson and Gaurang, and I'm sure pretty much Brian as well, we know that it was not the easiest thing to do back then. There was a lot of headwinds, a lot of people looking at us with strange looks when we start talking about Bitcoin, a lot of debates about where is the value, where is this thing going on, a lot of doors closed. We had to educate the whole broker network in London. I remember it was a lot of work. So I think the entrepreneurs of this space, like many startups, but I would say the entrepreneurs of this space have been extremely strong. Unfortunately, many have given up. I mean, not everyone has continued in this space. But I think the ones that are here today, and especially the ones that started a long time ago, know that it's an incredible experience, and it's not as obvious as anyone could think today.
No, I completely agree with you, Eddie. So I remember the old days when I started writing smart contracts. Actually, it took me 1 month to deploy my first smart contract because there was a documentation community. A lot of people didn't know how to actually deploy smart contracts. Like, that's on the technical side. And Anson, you must remember when we used to have these Bitcoin meetups, we used to give away like 0.1 Bitcoin to the audience, remember? Just for them to play around with it.
Yes.
I lost a lot of money there.
Correct. Yeah. Back then we were talking in terms of 1 Bitcoin, not even 0.00 something. So funny story. I had a friend that 5 years ago, 2015, got married, and when we Chinese, when there's wedding banquets, we give them red packets. In the red packet in 2015, I gave 0.168 Bitcoin. Chinese tradition, 168 basically means you will be very, the prosperous. And he showed me a photo the other day and saying that, Anson, I still have not opened it. I said, this is good for you for 5 years.
Oh, wow. Exactly. Yeah. Exactly.
So it's inherently important that for the blockchain community to meet up, even online, to discuss new things. Now going on Reddit, and just like on what Eddie said, it wasn't an easy journey, especially for my role to educate the regulators. And back then, if I wore Bitcoin shirts on the street, especially in the CBD, for example, just for fun, and if bankers do recognize me, they will go on. They will give me the look, right? But now with Singapore becoming more accepting of cryptocurrencies and virtual currencies, especially now banks are opening accounts for these exchanges now with the new license coming up. I went back to CBD and then wearing my Bitcoin shirts again these days. No one really gives me a look now. It's a very different world.
That's definitely true. So Brian, coming to you, can you tell the audience about the growth of Hyperledger over the last few years?
Well, and playing a little bit off the theme from some of the other speakers as well, I actually want to go back to 1994. In 1994, I was working at Wired Magazine, which had just put up its first. I just put its first website up, and we were trying to figure out a monetization model, and had been connected to David Chaum, the famous cryptographer, who had a company that he was launching called DigiCash, which, if anyone remembers, no, I'm sorry, was it Cybercash or DigiCash? Oh, I can't believe I forget. I think it was Cybercash now that I think about it. It was one of the two. Anyways, it was like this beautiful cryptographic system for being able to send money as if you were sending email. And the problem was that it was a closed loop system. It was proprietary. It was, asked him about this because all the software I was installing and using, we didn't even have the word open source at the time. That didn't come along as a term until 1998. But I was like, well, isn't this based on an open protocol? Like that's how the internet was built, and like with open source implementations of it. And he's like, no, the investors really want us to keep this locked down and help us, build a business out of this. So we can't just give it away, right? So we actually did a successful experiment, but then decided to launch Hotwired as an ad-supported company rather than as a pay-for, articles in small amounts kind of thing, which you can imagine maybe the internet architecture would have been different had that one decision gone a different way. And then in 2004, the founders of PayPal, said, I think it was 4, it might have been 3, launched because a small set of them, Peter Thiel and Elon Musk and others, said, we want to be able to make sending money from our, you remember the Palm Pilot kind of tablet? We want to make sending money from our Palm Pilots to each other as easy as sending email. Completely forgetting email was based on open standards and open source software. And sure, you have Gmail and these other services, but you didn't have these open source protocols and open systems with PayPal. And if you had invested in PayPal early on then, or even at their IPO or at some other things, it might have been an interesting outcome for you financially. But it ended up not really building the future of digital finance online the way that if they'd actually implemented sending money like email could have. And I've told stories about how when the Satoshi paper came out, I saw it and was fascinated, but had some concerns, and then a few years later found those concerns shared by a lot of other enterprises who then got together and said, let's launch something focused on enterprise applications for the underlying technology, for blockchain technology, and that's where Hyperledger came from. And over the last 5 years, we have seen the concept go from being something where we were kind of one of the sole organizations making the case for it to something that's now become a pretty accepted part of the financial markets, a pretty accepted part of the way that supply chain traceability is being talked about out there and implemented, and a pretty routine part of the way people are talking about reinventing how digital identity can work on the internet now. I'm sure all of you have heard about the Food Trust Network, which is Walmart and IBM and a bunch of companies tracing all sorts of food supplies around the world, even in well into China, well into other parts. There's the JP Morgan financial networks, JPM Coin and IAN, that are now installed by hundreds of banks worldwide, especially and quite a bit there in Asia as well, distributed quite broadly. I'll talk about a few other examples of where the technology is being deployed today in surprising places in countries like Sierra Leone and Cambodia and others. But really, it's become it's a technology that I think has found its place in some very key parts of the way the digital world works. But for some people, it hasn't taken off the way that, say, cloud computing took off, the way that a certain approach to databases might, or Nginx or something like that, right? Or big data. Most people think of blockchains as a big data tool, but they're actually, it's a small batch artisanal data tool. It's about transactional data that sits at the heart of how companies conduct transactions with each other. And you don't need lots and lots of servers to do this kind of thing. These supply chain systems, you typically have a small cluster of servers per node, and you actually don't even have to write a lot of smart contract code to get to traceability, to get to interesting kinds of financial instruments on top. So the deployments out there that we've seen number in the hundreds of production networks, number in the thousands and thousands of pilots and demos and projects, but each one of those projects represents a consortium, represents a collection of organizations saying, we want to do supply chain traceability in the diamond industry, or in rice, or digital identity for this side of the world, right? And so even though those seem like small numbers, those actually represent major markets and major, collections, I'd say, of getting these organizations together. And at this point, I'd say the major barrier to adoption of these technologies, the things we see, come from a lack of governance models around making these blockchain networks work. How do the 5 of us or the 10 of us align our incentives and interests enough to be able to say it's worth us pooling our nodes into a shared system of record, and then changing our business processes to adapt to that and treat that as the gold standard for how we're conducting business, rather than as an afterthought or as an echo of some other business process elsewhere. So that's I'd say the main barrier now, and we've got some things going at the Linux Foundation around governance networks that I think will help make a major dent in this. But I'll save that for a later point in the conversation.
Great, yeah, definitely. Blockchain technology has come a long way indeed. the whole blockchain ecosystem has come along indeed also. So, Anson, can you comment upon how regulations have, kept pace with all these advancements, technological, amazing advancements?
Yes, even regulation has come a long way, but I'm now putting out a new term that I think we have runaway innovation against regulation right now. Just to give you context, our financial regulator here called MAS, Monetary Authority of Singapore, 2017 said that it is normal for innovation to front-run regulation. So how I interpret that should be 1 or 2 steps behind innovation. And then once things stabilize, then regulation starts coming in. So that worked very well for centralized exchanges, trying to understand them, their best practices. Because of them wanting to connect with the banking system, there are certain rules that they need to follow. And once they follow those rules, then it's easy for the regulators to come in. However, now with DeFi, I am seeing runaway innovation where regulators are really panicking right now. Because I talked to the top of the food chain, so to speak, the Financial Action Task Force. You can consider this as the big brother of anti-money laundering and counter-terrorist financing governmental organization. So once they set rules, the members, including the US, China as well, Russia, Singapore, South Korea, and many of the 39 top members will need to follow. So most of the rules that you see in the payment services license basically comes direct from the FATF, Financial Action Task Force, right? And when we talk to them about how centralized exchanges are now adopting the regulations, they're very happy because the G20 asked them to do up the guidelines and make sure they follow, right? But in the last 2 years, I've been giving them warnings that this model may not be working because it's centralized exchanges. And centralized exchanges is only a big means to an end of what the whole ecosystem wants to be, decentralized. So now with DeFi growing so fast, with private wallets being the main holders of these cryptocurrencies, and we've seen many charts where Coinbase's wallets have dropped in custody value for Bitcoins, right? People are keeping in cold storage. This is a big problem for regulators. Like even the top guys are basically saying, we need help from the industry because our main practice for the past 30 years has been regulating intermediaries. But in DeFi, there are no intermediaries, right? This is a big problem for them. So we are starting from scratch now. I am trying to push this where we need to rethink the whole strategy. Because intermediary, in their definition, is that there are 2 counterparties. So for example, Binance is an intermediary that works with another Coinbase, another intermediary, where they will have 2 clients. But right now, DeFi, you don't need 2 service providers. You have 1, and liquidity providers. This is only one of the use cases, okay? But there are no major centralized counterparties. And this defeats the definition of intermediary because there isn't any. They're just a facilitator, not an intermediary. They don't hold cash. They then basically said to us that we need to work together more, but they are taking their time. Okay, they are really taking their time because G20 is looking at them to say that how are we doing with the regulations, and then basically they want to just achieve that, whereas this is only a small tip of the iceberg compared to what our whole blockchain system is going towards, which is decentralization. So yeah, it has come a long way. Things have moved quite well, like centralized exchanges and have now gotten licenses and are opening bank accounts. It took 3 or 4 years to actually get to this stage. Many of these companies have their bank accounts closed. Even my personal account was closed in 2015 when I was just trading Bitcoin with another exchange, and they say it's irregular activity. This was 2015, but now they've reopened my. They know who I am. They reopened my account, know what I'm doing. Then they're quite they're fine with it now, right? So yeah, we reached a stage now where the next step, and it's like doing step 1 all over again. and a lot of new challenges. But yes, it has been moving on quite well. Is Garang there?
Hello. Yeah. Yes. I'm there. I'm here. So yeah, thanks, Anson. So Brian, just following on to what Anson was saying, in the blockchain ecosystem, we all hate the words like centralization or consolidation, right? But what are your thoughts on human governance? I think you're quite passionate about that, right? And what are your thoughts on a perspective that human governance is not always a bad thing? Sometimes it's required and sometimes it's good.
Yeah, well, and to follow up on Anson's comments about the regulators in Singapore themselves. I mean, everyone might be familiar with Project Ubin, who lives there in Singapore or otherwise is in the space. But for those coming from the FOSS part of the world who might not be aware, the Monetary Authority of Singapore has been running a multi-year project called Project Ubin, UBIN, which has actually very proactively engaged technology companies and the open source communities in answering some key questions about whether these technologies can be adopted for central bank purposes, for clearing and real-time gross settlement and those sorts of things. And it's been incredibly productive. And they published the results of the submissions from these different companies and against certain challenges that they've posed as open source software. So actually very forward-thinking and leaning as a set of regulators. And in a way, I think they led the market. They front ran many of the vendors out there rather than the other way around. So I think that was pretty good. And it does. So I've talked a bit about how kind of the traditional anti-institutional view of Bitcoin and kind of and Satoshi, et cetera. Certainly it aligns with many of the things that people were frustrated about in 2008 during the financial crisis. There, it felt like the world's institutions had failed us to save us from rampant financial speculation that led to crashes all over the world. Certainly, there have been lots of times since 2008 where any sane person would look at what's happened in the world and gone, some or even all of our institutions have failed us in some key ways, whether that's about climate or social stability or others. And so Bitcoin did come from this world that said, if we used math to drive the governance of the network and converge on not just the next transaction in the ledger, but on how the system should work, rather than leaving it up to potentially corruptible bureaucrats to take people's money away, to change transactions and change history. All of that is very remarkable and admirable in its intent. And I remember some folks talking about we don't want to bank the unbanked, right? From a cryptocurrency point of view, we want to unbank the banked. We want to bring down some of these institutions that might have outlived their usefulness if we can transact, so not only send money directly, but build complex financial products directly with just one intermediary, or potentially at some point zero intermediaries. All of that is admirable and remarkable. But there is a role for folks to say, just because the market can work a certain way mechanically doesn't mean that it should. Doesn't mean that there isn't collateral damage. Companies are very good at privatizing gains and socializing losses. Declaring bankruptcy is a way of hanging the failures on the shoulders of public institutions and taxpayers to have to bear. And so we have to find a way for these systems to meet up with the obligations that governments have to their citizens and that markets have to the people who engage in them, to not only operate fairly but and mechanically correctly, but also operate ethically. And so I've been with some of these other sides of the blockchain space that deal with permissioned blockchain systems. The permissioning doesn't come in the form of a central body keeping the ledger and centrally approving what can go into it and being able to go and change history. Instead, with permissioning, what you're doing is saying, here are the organizations and institutions standing up nodes in this network. We're not anonymous to each other. We look a lot like any standard consortium might look, where the participants are not anonymous to each other, but they agree to a set of technical standards and governance standards. And if you do that, then the mechanics are allowed to play themselves out. And if somebody found a bug and was able to exploit that to steal somebody else's assets, as has happened a couple of times in the public blockchain space. Here is a governance mechanism to be able to unwind from that, right? Here's a way to collectively as a community make that call. And we've been lucky in certain times when that's been able to be successful in the Ethereum space, when they've had a couple of hacks that have led to some money being lost, and then they were able to recover and fix the bug and move the network forward, not without certain side effects like the Ethereum Classic fork and that sort of thing. And in some ways, those processes, when they did happen because of human governance, did happen because of people like Vitalik and Joe Lubin at Consensus and others, saying let's move the industry in the right direction, or let's fix what's broken systematically, even if it's beyond what the mechanics of the blockchain network immediately allow us to do. And so I've been trying to push the concept of kind of minimum viable governance rather than a no governance kind of picture. What's the least amount that we can do to build a network that coordinates in a way that recovers from bugs, that advances the platform, that decides how to interface with regulators and can productively interface with regulators, but still provides all the freedoms that we need and expect from the blockchain space. And that's, I think, something that I'm eager to see the dialectic around this evolve. And bringing this back to open source software, open source communities have human governance at their core. Healthy open source projects depend upon leaders who are able to pull all these volunteers together and move in common directions and fix bugs, add features, be humble, all that kind of stuff. And I think the right kinds of blockchain networks will be those, whether permissioned or public, that recognize the role for that same kind of leadership.
That's a great concept, right? Minimum viable governance. I think these are the words to live by for permission blockchain also, at least. That's great. So now let's come back to Eddie. Eddie, let's touch upon the topic of CBDCs, which is central bank digital currency, and how do you see the role of Bitcoin to all of this? Because Bitcoin is like the DeFi right now, at least for the medium of exchange on blockchains, right? So how do you see that happening?
Well, again, I think and it was interesting that Brian mentioned, the pre-Bitcoin digital cash kind of experiments, right? And we know that in the white paper, Satoshi mentioned, Hashcash, for example, which was actually in the email space and trying to prevent, spam emails and things like that. And then we, of course, most probably knew about a lot of the digital cash experiments, and that's probably what could have led him to go into that direction. So we still can see that Bitcoin, let's say, we can still call it kind of the genesis of the whole blockchain movement, obviously, having created in the first place. And in some way, CBDCs can be a distant cousin of some kind. Although, of course, we know that the banks have a tendency to say, what they used to say anyway, blockchain, not Bitcoin, and obviously many banks may still do that today, although they're opening crypto trading desk at the same time. So we have a kind of a strange relationship, I would say, but at the same time, I think CBDCs can be good in terms of overall adoption and overall integration, let's say, in the society of cryptocurrencies. I mean, some digital currencies, obviously, some central bank digital currencies, obviously, may not have technically much to do with Bitcoin. Although, it's solutions like RSK are out there and can still be used for, and can be used for this kind of projects. But some of the banks may choose, their own type of digital currency, and therefore one could think that there's not much. But I would say in people's mind and in people's perception, the fact that the central banks are experimenting and trying to move in that direction makes a big difference. I mean, a lot of like Brian was saying, actually, in terms of the regulatory side, there are a lot of projects all over the world trying to find solutions to the regulatory issues around Bitcoin and cryptocurrencies in general, let's say. Unfortunately, some of the regulators sometimes have very negative views on cryptocurrencies, which in my opinion is not entirely true, and it's not entirely reasonable, because the it has not been proven that there is so much illicit transactions on these networks at all. But of course, in a central bank digital currency, we still have the word central. So obviously, there is still central banks want to keep a high degree of control over what's going on. I think the important part, in my opinion, and one that banks may not see straight away, is the fact that central banks can end up competing with retail banks and the banks in their own countries, and by offering services directly to their citizens, right? So not kind of circumventing some of the retail banks' usual walled gardens in terms of markets that they usually have. So I think that's a very interesting part. And again, that's somewhere where CBDCs will compete overall in the cryptocurrency arena, not just with Bitcoin, but all of the cryptocurrencies out there, and as well, I think with banks, because at the end of the day, what everybody wants maybe to have a direct relationship, or at least for some of the central banks may want to have a direct relationship with the users of the currency, which is not the case in most countries today. I mean, even in China, where you have great adoption of the WePay and all the solutions that are very convenient to use on a daily basis, while the bank, the People's Bank of China, have enrolled this DCEP, this digital currency project, and it's working quite well. And I think it's going to be competing with a lot of these massive Alipay, WePay, and Tenpay kind of solutions out there. So that's quite interesting. Although in countries like China, Bitcoin is not allowed to be used by any banks out there. So I think interesting relationship, but overall positive in my view.
Oh, that's a great perspective, Eddie. Thank you. And on the point of reasonable regulation, Brian, can you talk about the impending? Again, there are a lot of speculations that countries like India might completely ban cryptocurrencies and issue their own CBDC. So, what are your thoughts on this? This might happen, this might not happen, because there's a lot of reports that they might not do it. Yeah, what are your thoughts on this? On this itself? Yeah, Brian.
Oh, okay. I don't pretend to be an expert on India's financial regulatory landscape. My understanding is that there are some negative sentiments towards that, and then I saw Nirav tweeting earlier today about being good friends with the finance minister of India, and they're committed to making it happen. So I suspect it'll go back and forth. What worries me from a regulatory point of view, and this is perhaps more of a global issue or not, is some things that we've seen suggested by the U.S. regulators regarding whether they'll allow people to have non-custodial wallets, wallets that have your keys locally, and thus would allow you to transact with people outside of whatever KYC AML regulations might exist. Because if you're using wallets that are tied to a custodial services, that's not unlike just using wallets that tie to bank accounts at a bank or something like that, right? Which is what the Chinese central bank digital currency is. That's what many of these other CBDC projects are really just your accounts, but at other banks. Not quite like Ethereum or Bitcoin, where you have local keys to your assets, or other blockchain systems. And if they don't allow for that non-custodial wallets for your ability to hold your keys, that will be tantamount to preventing people from being able to exercise mathematics, right? From being able to perform operations without any sort of other regulatory tie that verge on limits on speech, that verge on limits of, you should be able to do whatever you want with your computer, really, to a large degree. It reminds me very much of when cryptography was banned for export from the United States or for some other countries. They treated that as a weapon, as a munition, encryption software, right? And so hopefully we will see the regulators back away from that. But that's the place where I'd say in India, I'd be as concerned about that as elsewhere. I'll end back with India, though. India is actually one of the leading countries in figuring out how to use blockchain technology in a government context. They mandated a couple of years ago that the National Anti-Spam Network that they implemented a set of regulations that required the telco companies to implement a distributed database to track user preferences so that they wouldn't be hit on their cell phones with spam messages that they did not want. Essentially like a do not spam kind of database or do not call kind of database, if folks are familiar with that. And the regulation actually mandated the use of blockchain technology to implement the distributed database. And all the major telco companies in India got together and figured out how to do it. They built it on Hyperledger Fabric, but it's in production use today and tracking hundreds of millions of preferences out there amongst cell phone users in the Indian subcontinent. So I think they're going to be very knowledgeable about the technology. Whether they're very comfortable with unrestrained digital assets is going to be something we'll have to see.
Great, thanks for that. And Anson, any final thoughts on this? So after your comment, we'll go to the Q&A from audience.
Yes, so I can see most of these. So in not just in Singapore's context, even in the other regulators that I work with through IDEXA, main thing when banks start, so there are two main factors. When banks close accounts on their own, at their own discretion, they are worried because this is actually de-risking. So de-risking means that once you close down an entity's bank account, they can't see where the transactions are. But at the same time, from a bank's perspective, when they de-risk, then they have less compliance costs in a way. All right, so they're telling their own regulator that I think this is a risky account, so I'm going to close it. So in a way that they reduce their costs. The other problem is, for example, in FATF, the top members, which includes in India and China, when the guidelines came out, the draft guidelines as well, when they came out, they need to tell FATF if they are going to work on the new virtual asset guidelines, the cryptocurrency guidelines. And if you are not, you have to prove to Financial Action Task Force, FATF, that you are actually going to ban it. Because every couple to 2 to 3 years, the FATF would come to that country and do an evaluation report. So once they do an evaluation report on your financial system, and if you do get a very low rating, there will be other consequences. But for this particular talk, I won't say what the other consequences are because I have been the people have criticized it. So I'm just going to say there will be consequences when it is low. So they don't want a low score. Okay, so some decided to work with FATF and increase their scores, try to work and saying that they really are trying to do it. Some decided to ban it and have to do everything to ban it. Okay. But the main problem with this is, as we have seen recently in Nigeria, the central bank said that it's illegal to for banks to deal with any cryptocurrency transactions. The peer-to-peer transactions have increased significantly, right? So the whole point, we're going back in time in 2014 again, when the different countries start banning it, they are doing it without thinking on the consequences. Because once you ban it, but the country wants it, these countries just, the transactions just become underground. It doesn't stop it at all. So Nigeria is doing a 2014 thing that for sure later on they will need to change their regulation. But for India, yes, it's a very interesting one. I think if you look at the Twitterverse, the big names, everyone's scratching their heads why India is so worried on it, when I think it's only one of the industries in the world that wants to be regulated, especially the centralized exchanges. They are trying very hard to work with the government, right? The local governments and also the federal government. So by banning it is not a good way. When the demand is there, it's much better to find a way to embrace or slowly improve on your regulations. Because if you look in even Singapore's case and even in Hong Kong, it's very important to keep your regulations constant. Constant meaning that it's slowly improving, but not all the time changing your positions. Because once you change your position or stance on something, it gives uncertainty to the markets, investors, and all the entrepreneurs may just drain away. Right. So yes, India, I think will find a way. I'm very confident of the entrepreneurs there. There are a lot of big ones that I know of. But yes, might take time, but I'm sure it will solve out itself very soon.
Great. Thanks for that answer. Now let's go to the audience question and answers. So if you go to the shared notes on your left-hand side of the screen, Anson and Brian, there's a question for both of you.
Anson, do you want to go first?
I'm familiar with this platform. Can I know where the questions are?
If you click on shared notes in the upper left under
notes.
public chat. Yeah.
Okay, so it's the first, it's loading right now. Okay, oh, can you give an example of regulatory objectives that regulators will struggle with as intermediaries lose relevance? Not just mechanism controls that societies need or expect. Would you like to ask? Okay, so for regulators, the main objective, two main objectives. One is to protect the consumers, which is the main one that most countries would try to abide by, or use that as the main narrative when trying to regulate the cryptocurrency space. But second is that they are trying not to have so many money laundering cases within the ecosystem. Because once that happens, the intergovernmental regulators come on them, there will be a lot of consequences. As I said, there was, including when the time when Pakistan had a gray rating from FATF, they were basically panicking. So these are the two main objectives that they don't want to lose control of. And as for intermediaries, I don't think they will lose relevance. There is still a need for intermediaries, especially when a lot of these companies are still working directly with the regulators, because it's only in the blockchain space where the decentralization, or not only, at least in the fintech space, but as far as the blockchain is concerned, decentralization is very heavy in this space. Right. So in our space, yes, decentralization and intermediaries will be more or less disintermediated, but many other industries, you still need a lot of them. All right. So regulation is not just for finance. There's transport and all of them, and many still use intermediaries. They will not just go away with it. Okay. So. So it's just mostly in our space that they must work with the private sector to understand. Otherwise, it will, when this whole DeFi space grows bigger, the private wallet use grows bigger, they will really lose the grip on what things are. And especially now when we're dealing with the travel rule. Travel rule means that the service providers need to share information with their customers. Or about their customers to the service providers. If they don't get this done properly, bad actors will come in. So this is what we're trying to prevent. Hey, Brian, sorry about that for such a long reply.
That's great. So there's a question for me, which was, can I discuss some of the topics which have led to blockchain and DLT adoptions to take a stumble even when the use case seems to be a good fit? And it's hard to get metrics around this because, I mean, certainly you have these two worlds. You have the public cryptocurrency world where it's possible to measure the floating value of tokens on different exchanges to 10 decimal points, though perhaps hard to figure out the connection between that and economic output, right? Or economic impact. And on the enterprise blockchain applications, there's really not public deployments of this stuff, right? There really isn't a way easily to go and talk about this because supply chains that are core in business, because all the deployments of these kinds of technologies manifest themselves in ways that tend to be amongst closed circles, right? And I think that's kind of unfortunate. I think there should be ways to make these deployed in ways ways that can be more open and transparent. But it's been hard to be able to point to like the Food Trust Network and say, look how big that is, when really it's the back office kind of function between different organizations. I don't think it's the technology that has limited these deployments. The technology, it works when you pull together a set of nodes, and no matter where they are online, when you find use cases that go into the hundreds or thousands of transactions that don't have to get to the tens of thousands or anything crazy. When you're talking about the features available through different smart contract systems, they're all there. What I think happens is, you see these pilots happen, you see people go out and say, we think this is a good idea, and then you recognize not everyone has the same inherent interest in seeing a convergence on a common system of record. I think it's partly because there is so much corruption endemic in so many markets that eliminating corruption, finding ways to automate business processes where the lack of automation provides opportunity for people to realize perhaps more economic value than they should, to put it diplomatically. Not everyone is incentivized to see that kind of transformation take place. It also reminds me a fair bit of the early days of open source software, where making the case for why companies and developers should work together on a common piece of code, because it isn't differentiating at this layer, at the layer of an operating system or a web server or a database, and instead they should be reducing their R&D spend by sharing the R&D effort at that layer, even with their competitors, so that they can spend more money at the layers above. Even that, back in 2000 was a challenging message to get across, because if you built this perfect low-level piece of plumbing, you assumed that was a differentiator, right? And you assumed that everyone should come to you for that, rather than that be the thing you commoditize first before somebody else commoditizes you out of it, right? And so that same thinking that now I think is like a more of a standard reflex now for people in the tech industry about where do they invest their R&D money in differentiating value versus in things that are table stakes and they should work together on, and that should be open source. The same kind of thing now will have to happen around transactions and marketplaces and those kinds of things, where that lower layer of let's just converge on a common system of record, let's automate these low-level processes so that we can build the interesting value on top. That's a phase change, and I think it's more the business crowd that has lagged behind in that adoption of that concept rather than the developer crowd. And then third, it's kind of not easy to get people excited about, back-end office transaction systems, about weaving these very boring processes together. Everyone wants to look like a hero. Everyone wants to be, the person who comes out with the answer for everybody else. It's really hard to form consortia, really hard to form a network of cooperative people. Venture capitalists don't like investing in that kind of thing, I can tell you that. And so that's when it's hard to get some of these projects to go from very promising proof of concept that does generate a demonstrable value in terms of cost savings or risk mitigation or other things, to turn that into something that launches into production. Those are all the kind of barriers that we've seen.
I think we're running out of time now. So thank you, everyone. Okay. Thanks for joining this panel. And now let's go to the keynote by Brian, right?
Thanks, Gautam. And Gaurang, should I stay here in this same window? And if so, can I present from my desktop here?
I think Mario can answer that question.
Thank you.
Thank you very much.
Thanks, Eddie. Thanks, Anson. Nice to meet you.
Bye, Brian. Bye-bye.
Nice to see you again.
Hello, Mario. Huang, you're on mute.
Thank you very much for this session. Thank you, Gaurang. That was interesting, and I see there are still a few other questions. And we will have the keynote of Brian in a moment. So I'm very curious to see what other questions will be answered from the audience. And Brian, we can test the upload here in a moment for your slides. So before we start, there is let me give you presenter rights. Okay, you already have presenter rights. Yeah, and you should see button. Okay, so you're Big Blue Button Pro. Excellent. So thank you very much. And then we still have 2 minutes time. before we start the session. And yeah, Hongfuk would like to share maybe some notes like for the participants and some information. Hongfuk, please go ahead.
Yes, so I jumped in a little bit late. I was hoping to get Eddie, and also I want to say hello to our viewers from India. And from Thailand, we actually have 9 hubs going on at the moment where the viewers get together in our local spaces in India, Pakistan, and also in Thailand. Because I heard like India was referenced in the panel, so I hope, I wonder if Brian can just say hello to the people there. We have the connection with the hub in the next coming day where they will show us what they are doing over that side. Yeah, so hello people. Yeah, so I hope that you learned something from the panel and we're ready with the keynote shortly. Yeah.
Yeah, so if you want to find out more about the hubs, on the side panel there is a link exhibition, and in the exhibition there is like a space with I think like 40 different exhibitors, hubs in different communities around Asia, and many of them already also have a video link, so you can click on that link and check out if anyone's there. So there is often like a time information when they will be available, but of course you can always try and see if somebody's there and yeah, chat with people here across Asia. Of course it's challenging. Usually we had this event in Singapore, but yeah, now traveling is more difficult, so we're really happy to make these local connections. So thank you very much then everyone for joining, and we're now coming to the keynote of Brian Behlendorf. Brian, by the way, I always wanted to ask you, do you have like a German roots, because it's a German name?
Not any more recent than something like 6 generations back. I have been to the town of Behlendorf. It's just outside of Hamburg. And then there's a little lake there called the Behlendorfer Sea, which I always laugh at. But yeah, nothing directly there. I'm very much mixed.
Okay, nice. So that's, yeah, but like, it always feels like connected when somebody has like a name like from, you know, another region or something. So yeah, really nice to have you here. So let me introduce you, Brian. Brian Behlendorf is the General Manager for Blockchain, Healthcare and Identity at the Linux Foundation. In his capacity, Brian leads both the Hyperledger Open Source Enterprise Blockchain Software Initiative, as well as Linux Public Health, which builds software and services that assist public health authorities in the fight against the pandemic. Brian has a long history with open source software, going back to co-founding the Apache web server project in 1995. And from that point forward, founding or working for a series of companies like Wired Magazine, Organic, CollabNet, non-profits like the World Economic Forum, and governments. For example, the Office of Science and Tech Policy 2009, where he was an advisor. Brian currently also serves on the board of directors of the Mozilla Foundation and the Electronic Frontier Foundation. So that's very strong track record in free and open source. And yeah, we are very interested in your presentation now, in your keynote, Hyperledger and the current state of enterprise blockchain. Brian, thank you very much for joining us, and I hand over to you. Thank you.
Thank you, Mario, and thank you to everyone watching now. I'm really, really happy to see not only the FOSSASIA event continuing on in a virtual setting here. I regret that I could not make it to Singapore and be there, that we all could be together in person. I can't wait for face-to-face events to start to happen again, hopefully this year. But I'm also really happy that the conference is using open source software itself for the video platform, for Big Blue Button. I think some other parts of it use Jitsi. It's just a testament to the fact that open source software not only can be about operating systems and databases and these low-level pieces, but also about the newer software, the stuff that is more, I would say, cutting edge, but even more urgent in the world that has only gotten way more connected in the last year. I'm going to talk a bit about Hyperledger, and some of you might know about who we are, where we came from. I thought I would actually start for this audience with a bit of a story for why I believe this field of enterprise blockchain technology and kind of the difference between it and the cryptocurrency kind of angle on blockchain is actually the third chapter of what I would say started with open standards, even before open source software, in like the mid 60s, the mid 70s, where you had people realize if we're going to get more connected, we better agree on the protocols for how we get connected, to open source software and its rise in the 90s, really, as a way to say, if we're going to get better connected, we should be writing software to each other to make it easy to adapt and adopt those technologies and make connecting as low cost as possible, and be able to evolve it, to really now looking at open networks and the way to try to get away from the same kind of closed thinking that caused all of us as Linux users in the 90s to kind of point a target on Microsoft and say, well, at least we don't want to be like them. Now Microsoft is one of the biggest open source companies, of course, but now there's other companies who've kind of positioned themselves in this very central kind of role. And blockchain technology really represents a chance to reinterrogate that. Do we really need to live in a world where all the interesting, useful stuff happens in these big central services, or can we do something different? And that's what motivates me. So, just to get a start here, in 1964, Paul Barron was one of the, you consider one of the, kind of ancestors of the internet, published a series of papers articulating what a properly decentralized architecture for networking would look like. One that, and he tried to draw the distinction, even in this paper from over, almost 60 years ago, between centralized networks with, a hub at the center, very much kind of like how most command and control networks at the time worked, to decentralized but still rooted in a couple of key places, which is how perhaps the phone networks really worked at the time. Allowed for breaks in the network, but depending on how it was broken, you could get cut off from everyone else, to something that was much more distributed, something that was really about every node being diversely connected to other nodes, and through that being able to withstand quite a bit of network failure and breaks between those nodes, right? And inherently kind of operating at a level where we're peers. And we mostly got what we wanted out of that original design for the internet. There still are some places where there is an inevitable amount of centralization that was required. I'd point to the domain name system, point to IANA, which is the organization that assigns IP addresses. I'd point to a few other organizations that were still voluntary but kind of centralized, like the Internet Engineering Task Force. But those were authorities we could pick. And the interesting thing about all those authorities is they had to earn their right to be authorities in this distributed network. If there was an organization that could do the domain name system better than I can, they had every chance to kind of rise up and be an alternative. Or better than the Internet Engineering Task Force, they absolutely could be. So we mostly got what we want at the level of TCP/IP, DNS, SMTP for email, and HTTP. Any one of you can set up your own email server today. There's actually a great thing called Mail in a Box that allows you to do that at your home or on a Droplet at DigitalOcean or anywhere else that you want to host that. You could also, of course, run your own mail server. But where we've ended up now, really when you talk about the core ways that people use email or social networking or file sharing or frankly, even today, building enterprise applications, there's a very small number of organizations that sit at the heart of most of these. And they, in some cases, they compete on equal grounds. Google and Amazon and Microsoft and others compete for cloud services. You can move your Kubernetes containers from one to another. But there really is no other alternative to Twitter. Twitter is kind of a closed system. And I love Twitter. I use it every day. I doom scroll every night like the rest of you. But Twitter is a very centralized service, even something that Jack Dorsey recognizes and has started to fund explorations of an alternative to. But most of the way that we build these social networks today, and you could even look at what's happened to email with Gmail. Gmail is the majority of email traffic on the internet today. There's a disturbing amount of centralization. Even though the underpinnings have been decentralized and distributed, there's been a re-centralization up above. And I'm talking here about the easy consumer examples that we can point to so everyone can relate. But there's a real risk that these architectures that we've built lead to the same kind of centralization in things like supply chains or financial markets or other systems of the world and that are typically regulated, that are typically about different companies kind of trying to compete on a fair and level playing field. So there's a risk that if we don't try to answer this challenge of building up from these layers. How do we make it easy to build decentralized and distributed architectures? We may end up with, in every category, one dominant company, dominating things like equities markets or the supply chains in key products, right? And if that were to happen, it would be a much different world. We'd end up with companies that were stronger than countries, and that. I'm not sure that's what we want. So to get back to this kind of decentralized internet, thinking broadly about what the internet is, what we really need are databases and information systems, because that's what it gets to the heart of. Those companies that are at the center, they're there because the data is there, and they have our relationships that are centralized there. We need to think about ways to make these cooperative systems that are multi-master. What I mean by multi-master is that you can have a whole bunch of different organizations that are all peers to each other at the core of that. They're verifiable. So the data that you store in one, you know that it can't change without your noticing, right? Very much like GitHub. If somebody were to try to silently change the repository on GitHub, you'd know, because GitHub operates off of hashes, and the pull requests are based and commit IDs are based on hashes that can be verified, right? It would be append only in these databases, right? Because once something is written and published, you can certainly update it. You can certainly publish something new. But you can't, if you were to try to prevent that, you didn't say something or something went unsaid, that would get complicated really quick. You want there to be programmable rules for how these updates get made as well. If you want to make sure that if somebody says, I own a thing, I have a possession of a digital asset, that asset can't then be transferred to multiple people at the same time, right? This is called prevention of double spend in Bitcoin and other systems, but the idea that there are these sequences that as a network we need to enforce the proper behavior around the way that things change on that network. Think of it like the equivalent of stored procedures in databases, right? You can't actually change a thing without going through the process. That's a very important concept to bake into these decentralized systems. Such a network also needs to be resilient to hostile actors. It can't be too easy to corrupt what's going on. As a participant in that network, you can't. For it to actually work, it has to be able to stand up to attacks, even attacks from a large number of determined attackers. It needs to be resilient to network issues. If something happens to a cable across an ocean and suddenly whole continents aren't able to talk to each other, there needs to be a way to reconcile and come back to a consensus on what that database says going forward. And finally, just like free and open source software, the thing that keeps power in check, the thing that keeps us from becoming dominated and tyrannized, is the right to fork. And this is something all of you know is inherent in every open source license, is the right to take that code and go in a different direction than the original developers want you to. Obviously, we all want to work together. If you come up with a bug fix, I'd love to have a copy of it. We want to be as good at an upstream as we can be. But the right to fork, the ability for software to split, is inherent in controlling power. And keeping power at bay. And likewise on these decentralized systems, there's always the risk that one party gets too much network power, and the only way to combat accelerating returns from network effect is to make such networks forkable. So we really need a cooperative network between nodes, like on any given kind of business use case, let's just think about that for the second, that comprise lots of different kinds of organizations, right? In this kind of humming benzene ring, if anyone remembers chemistry and remembers that a benzene ring is kind of a magical unit that has like 1.5 bonds between every carbon atom, right? If I got that right, hopefully I did. And you almost have to treat it as a unified thing rather than as something that can be teased apart. So we need this cooperative network that forged from nodes running free and open source software, because that's the way that you know that it's running the way that it should. If every bit of software running on this was owned by a certain company and it was proprietary software, you'd never quite know if all of these were working together and whether your interests were being defended. And it needs to be based on technical standards and an open governance model. And we talked a little bit in the last session about what human governance looks like in there. I'd still argue that it's pretty important to have in these network systems. So what I'm talking here, it's just like the blockchains underneath cryptocurrencies, right? But maybe not. there's plenty of concerns out there regarding energy consumption derived from the proof of work consensus mechanism. Apologies. There's plenty of regulatory issues like those that we dove into in the past regarding, how there's a lot of concern about the role that financial speculation plays in driving clashing motivations between the people who want to see that network deliver utility and the people who want to be rewarded for mining on those networks and the people who want the token value to increase. Those interests are not always aligned. Sometimes those interests diverge, and that's something that I think I see a lot of folks struggle with when it comes to even using Bitcoin today at the prices they're at. Trying to get transactions cleared at a reasonable price and quickly is a big challenge, right? That gets into performance, of course, but really this question of data privacy exists as well. Regulations like the GDPR and the California Privacy Act and others say even if we use all the perfect cryptography in the world to implement zero-knowledge proofs across networks like this, if a mistake is made, how do we recover? And that's where you need a governance model, and that really underpins everything else, that can come back and say, okay, we collectively as a community need to have a mechanism to have hard conversations and make decisions and do things beyond what was anticipated originally by the designers of the system and the smart contracts that run on them. So one solution to all this is distributed ledger technology. I'm not going to say it's the only one. In fact, there are many cases for why it is an inferior one. But tends to be, in fact, I would say there is no use case for which a distributed ledger and blockchain technology is going to be the fastest, is going to be the cheapest to deploy, is going to be the most flexible. You're always going to, by any classical technical measure, be a better way to solve any of these kinds of problems with a centralized database. But there's reasons we don't want to do that, right? As I just went into, we don't want to empower an 800-pound gorilla at the center of these networks. So how do we do this in a cooperative way? So DLT technology is a way to get to that network of participating organizations without requiring proof of work consensus mechanisms, which means you don't have the energy consumption issues that Bitcoin and Ethereum have. Now, some cryptocurrencies do use proof of stake and proof of authority and some other approaches, so it's worth keeping in mind. But the enterprise distributed ledger systems operate without needing to use that. They use what's called Paxos, Byzantine fault tolerant, other types of algorithms that are actually just much more efficient. They are also able to operate this using, they still are able to have tokens and digital assets on a system, but there isn't a mining, and nor is there like an ICO, nor is there necessarily one token at the center of that network. You're able to, but you are able to support, say, central bank digital currencies or frequent flyer miles or any type of kind of currency that people have and expect out there. These kinds of networks can use the same smart contract technology that the public cryptocurrency networks use. The Ethereum Solidity smart contract language is very well supported on under Quorum and Hyperledger Besu. We can talk some more about that in a bit. And the way that these networks tend to be operated is with all these different nodes run by parties who are permissioned and using certificate authorities. So there is an important question: what is that governance model? What is who runs the certificate authority and issues these certificates to participate on the network? And this is very much like the CA problem we have today. If you have too many of these certificate authorities and the standards that they have are very low, you can end up with security issues and operational issues. So that is an appropriate place to ask, what is the right granularity, what's the right size, that sort of thing. And again, it's very much like open source projects, where you join an open source project based partly on what it does, but also based partly on the leadership behind that software coming together. These types of networks can always interoperate with public blockchains or other payment networks. They can always say, I'll transfer title to this car on this permission ledger, and I'll correlate that to an Ethereum transaction that happened here in which you bought the car, right? And then finally, we should be able to map these technologies to existing consortia and governance systems. This is really important because as much as everyone wants to bring down the banks or bring down the way that regulations and the systems of the world work today, because it's not working for an awful lot of people, finding ways to meet up with the people who designed and run those systems for good reason, right? And say, maybe there's a way to map how these consortia work or how these rules work into the underlying blockchain and distributed ledger platform. That's going to be a lot more impactful and probably lead to, through automation and through routinization of processes that are right now very human-based, hopefully eliminate a lot of corruption and take things that used to take weeks or months and have them take days or hours. I think that's the goal for a lot of this. So this is what we've been building at Hyperledger, is a set of distributed ledger platforms that can meet the kinds of needs described in that last slide, that can meet the need for software that can run on a node, if you're a bank, to set up a banking network where you're conducting, settlement of payments, where you're sharing information about account holders, where you are, or if you're on a supply chain, if you are a supplier or a distributor or a retailer, and you want to track product as it moves from one place to another, or as actually a new approach to digital identity through by using such sharing networks as a way to essentially record public keys for individuals or for issuers, that sort of thing. So as a fresh approach to PKI, these are all ways in which these platforms are being used today. In the interest of time, I won't go into too much depth, but I'll just kind of highlight that across the board, we've got 6 different technologies, and people might say that's kind of crazy. Why would you want 6 different ways to build a blockchain ledger? And it might be a few more than you actually need. I'm not going to say anything about that. I love all my children, of course, but there are a couple of platforms that are really category leading, and in a way, it's kind of like databases. No one says out there, well, there should only be Postgres, there should only be MySQL, and that they should just merge, right? And users of one should just move to the other. There's always going to be a bit of rivalry, or somebody like MongoDB, who is very much a NoSQL kind of angle on things, right? And likewise, these platforms do differ in meaningful ways. Fabric comes more from a transaction, online OLTP, kind of big iron kind of transaction processing background, whereas Hyperledger Besu, for example, comes from the Ethereum community. It comes from a company called Consensus, who has been building Ethereum network clients for a long time, and Besu actually runs both on enterprise permission blockchain networks and on the public cryptocurrency networks. But some of the other ones have an interesting backstory as well. Hyperledger Indy is very focused on digital identity, and Hyperledger Roja is actually one of my first examples. It's been deployed in for very, very focused distributed digital asset environments, and I'll talk about an example very soon. In fact, that's my next slide. So you might be wondering, how are these technologies used out there in the real world, and where are they solving some problems? And again, I kind of alluded in the last panel, a lot of this stuff is behind the scenes. A lot of this stuff is hard to track with the granularity of a price on CoinMarketCap, right? But as one example, the National Bank of Cambodia has launched into production now, into apps being used by their citizens, something called the Bakong project, which is essentially a central bank digital currency issued by the National Bank of Cambodia, and harmonizing accounts across all of the major financial institutions in Cambodia. It was built by a company called Soramitsu using Hyperledger Roja, which they are the primary contributor to, and the network actually manifests by nodes running at all these different member banks, as well as at the Central Bank of Cambodia. The end user has one app, and the end user from that app can move their balances from one bank to another, and know that that is a real-time view of the assets that they have, and that represents the system of record for where their assets are across these different banks. It was intended as a way to try to make the currency system for Cambodia much more pervasive. Sometimes the US dollar is used in Cambodia in circumstances where really the Cambodian would prefer that you use their currency. And so bringing that down to a mobile app that can run on very low-end hardware was a key focus for them. And they didn't want every bank to have its own mobile app. They thought that would be confusing. So this was a way to bring that together still in a decentralized way, still in a way that allows all these different banks to have confidence in the balances and in the assets that they are responsible for, rather than simply what, say, the Bank of Cambodia tells them is in their account. So happy to share more with that. It's on the Hyperledger website as a case study with the Director General of the National Bank of Cambodia herself, Madam Chia Sere, actually playing a very front-end role in understanding how the tech works and being an advocate for it out there in the world. It's really amazing. As another example, there's a I want to say company, but they're really more of a social impact company, kind of almost a nonprofit called Kiva, based in the United States, but they've been active in the microfinance and micro lending space for years and years, for over a decade, I believe. And they've been key to enabling microloans in all sorts of different countries and front-ending small microfinance institutions in those countries, like in the Philippines or in India or in other places. But in certain countries where there is no national credit bureau system, their rates of lending are very high because the rates of default are high. Because without a credit bureau, knowing what your credit history is impossible. And so if I lend to you and the odds are 30% that you're going to default, I have to charge a 30% interest rate just to break even, right? Modulo certain things. And so Kiva had an opportunity to work with the government of Sierra Leone to implement a digital identity system and a credit bureau system. And they chose to do this in a way that wouldn't create a gigantic centralized repository of this, but instead to push it to not only to the perimeter, but push it to the individuals themselves in a way that implemented something called self-sovereign identity or user-centric identity, and kept the credit bureau records in a form that was privacy preserving. And that has now been issued. There's something like 7 million citizens now in Sierra Leone with a self-sovereign identity using a mobile wallet given to them by Kiva. They're not spending money that's tracked by the blockchain. This isn't a cryptocurrency or any kind of currency network. This is about identity and about proving when you take out a loan and you pay it back that you've been able to pay it back and you're therefore a good credit risk for the next loan that you'd like to get. This is implemented now on top of a combination of Hyperledger technologies and is really just a lot of fun to know that it's out there and know that we're having a positive impact in a country like Sierra Leone. You can read more about it on the Hyperledger website. The third example I'll give, again, these might sound like kind of boring back office kinds of things, and this one is perhaps the most in that vein, but I think it's one of the more fascinating ones, which is in the United States, in the insurance industry, often there is a need, especially around the kinds of companies that offer insurance in, like home insurance and fire insurance, flood insurance, those sorts of things. They have to share information with regulators on a regular basis that talks about where they've had to spend money. There was a flood or an earthquake or a big fire or like the gigantic freeze that happened in Texas a few weeks ago. They need to share information in ways that can be confidential, that can be verified, that can't be taken back, and that get processed by certain parties. And one of those is an organization called AAIS, the American Association of Investment Services, Insurance Services. They've been using Hyperledger Fabric to deploy a network where there's peers on that network from the insurance companies as well as the regulators, as well as those who perform analytics on that data. The data gets published there not in clear text, but in simply as hashes that then reference larger data files that are shared off-chain between the different parties. But the record of them there satisfies a regulatory need to make sure that reporting is happening on a regular basis. And then through the analytics as well, they're able to show that there's high integrity in the results of that analytics processing. Basically, it's a way for the insurance industry to get smarter about where risk is, to be able to respond more quickly and try to keep rates as low as they can. And it was a system that was pretty burdensome until AIS came up with a way to do it in a decentralized way using blockchain technology. And again, you can read more about that on the Hyperledger website. There's a ton more examples out there. There's an article that Forbes put out on the Blockchain 50 called the Blockchain 50, which talked about 50 different companies, all of them north of $1 billion in revenue, that deploy blockchain technology, enterprise DLT technology, and 26 of those, 30 of them actually this year, technically 30 of them are using Hyperledger Fabric-based technologies. There are a couple of those where it wasn't mentioned in the article that we know that they're using Hyperledger behind the scenes. But a lot of them are these are in production today across these different organizations, and that's where it's hard to say, well, what's the what are the downloads, where's the activity? It's in this kind of dark matter inside these organizations. But we know because we see people from these companies joining the developer community, asking questions, engaged, and service providers to those as well. So in those 5 years since we've launched, we showed you the greenhouse with 16 different projects, shown you the different production releases that have hit. we've also felt it was important to build a supportive community around of companies around the different technologies, as well as training and certification of those as well. In fact, I'll show you a little bit what we provide all those different projects at Hyperledger, and this is really because of our pedigree at the Linux Foundation and how we run these projects, is a set of available tools from obviously GitHub and Wiki and Chat, all the ones that developers are used to, but organized in a very familiar way. A common IP framework using something called the Developer Certificate of Origin to make sure that enterprises are comfortable where all the code is coming from, and that it's under the Apache license, so that they know they can use it. Their legal teams don't have to give them grief over that sort of thing. There's also standardized processes for reporting security holes, and we do bug scans and all that kind of stuff. But really drives it is the volunteer developer culture at the heart of these projects, and trying to make those standardized across all the Hyperledger projects so that you can move quickly from one project, say Fabric, to another like Aries, and know that the same tooling and the same requirements apply. And then on the Linux Foundation side, we try to do all the things that aren't about writing software, that are about helping the developers feel like they're able to be productive. It's about helping explain to the world what they're doing. It's about helping make sure that the stuff is being built in a secure way, and then go out and talk to the world about it and build that sustainable commercial ecosystem on top. We also have across all of our projects a number of working groups that focus on things like architecture and identity, on performance and scalability, on how the code gets documented, on a very important topic, diversity, to help make sure that the community is as welcoming and taking really advantage of all the different people out there who are not only using this technology, but have an interest in trying to advance it. And that's how we try to weave these technologies together. We also have a series of special interest groups, which are all about trying to help explain how this technology works to people in the healthcare industry, in telecom, in trade finance, in climate action. Here's how you'd use these technologies. And often it's people from those industries coming in and saying, here's a project that we're doing, could you give us advice about how to do it better? Here's some results that we're seeing. Here's the way we thought about using the tech. So we felt it was really important to match the developers up with the people trying to use these technologies for some really, really interesting and different kinds of use cases. I mentioned we have a really global community at Bay. I don't want to dwell too much on it, but we've been using the Meetup platform quite a bit to be able to enable all these different communities there in Singapore. I spoke at a Singapore meetup a few years ago. Communities all over India, where we've opened a chapter in India, connecting our meetup communities there for like an India-wide kind of chapter that's been really great, but also all over Latin America and other places. We also make extensive use of YouTube, where we've published both the recordings from the virtual events that have been happening, as well as tons of other kind of presentations and things, just to get the word out about what we're doing. As I mentioned, it's also really, really important, we believe, to build a commercial ecosystem on top of this code, so that people who are using this and improving it are feeding those improvements back into upstream. I mean, our goal is to be the best upstream we can be, but we know we also need to see other companies making money using these technologies and getting that loop going. So we have 20 of those. We also have over 10 different organizations who have built what we call low or no code commercial options around the deployment of Hyperledger Fabric out there, and making that really move quickly as well. I won't go too much because I know we're getting low on time here about some of the differences between the core platforms. I mentioned Fabric, and it's really, I'd say, the most widely used of the different Hyperledger platforms today. It's something where there's a really regular cadence of new releases coming out, of bugs being fixed, and it's really been used in some high demand kinds of environments. So really recommend that be one of the starting points you consider if you're diving into this. The other starting point I'd go into now, if I were starting now, is with Hyperledger Besu. There are so many people out there now familiar with the Ethereum stack of technologies who might not realize you can use this in permission blockchain settings. And then, in fact, this is used in production in quite a few, in a couple of banking networks, in a couple of supply chain networks. This is real code, and it's moving quickly, and it's tracking where the Ethereum ecosystem is taking its own evolution as they move to proof of stake and Ethereum 2 and those sorts of things. So some really exciting things happening there. if I had more time, I'd tell you all about all sorts of different other projects we've got going on inside of Hyperledger. One of these that is getting really the most attention is Hyperledger Aries, which is a collection of wallet libraries for building digital identity wallets on top of the concept of self-sovereign identity and using Hyperledger Indy as the underlying ledger for that. Although there's a lot of talk now about adapting and porting Aries to other ledger underpinnings. This is being picked up today in a lot of use cases in government, in, I mentioned Kiva, but right now there's a lot of interest and focus on this for the deployment of digital vaccination records, digital vaccination passports, if you want to call them that. Basically a way to prove you've been vaccinated when you're crossing a border. Lots of deep and important issues there, technically as well as ethically, that if I had more time, I would go into, but it is a huge part of my focus right now is thinking about, as those platforms do get rolled out, how do we make sure they preserve privacy and they deliver agency to the individuals using those kinds of credentials, and avoid creating the same kind of privacy or tracking problems that we've had online with cookies, right? Which is certainly where we do not want to head. And then across the libraries and tools, things that we think developers are really going to be interested in using to manage their Hyperledger deployments. And one of the ones that I think is really interesting is Hyperledger Avalon, which is focused on using secure enclave technology to implement zero-knowledge proofs across any type of ledger environment. So as a standardized way to use, whether it's the embedded TE functionality and things like Intel's chips, or it's through advanced cryptography to try to get that across general purpose hardware. This is where there's some really interesting stuff going on, and stuff that lines up with the Confidential Computing Consortium, which is another project at the Linux Foundation. I also want to mention Hyperledger Labs, which is like a foundry for some new ideas, for things that might even be special use case focus. One of the ones I really like is the Blockchain Carbon Accounting Project, which is focused on, if we're going to implement things like the Paris Accords or other carbon marketplaces or emissions marketplaces out there, using smart contracts and using things that could span multiple countries, how might we do that? And there's a lot of interest there from folks who are building some of the prototyping for how folks plan to get this implemented for the upcoming Paris commitments and the like. So really fun to see that deployed there. We also have been spending a lot on trying to help internationalize our Hyperledger projects, in particular, starting with at least Hyperledger Fabric. We have a really active translations community that has started working on, and in many cases made substantial progress on translating Hyperledger Fabric to English, to Chinese, to Portuguese, Japanese, Malayalam, I'm pronouncing that wrong, Spanish, Russian, Tamil, and French. All of those are languages that collectively would open up about 1 billion new users to the platform, and so we're really eager to see those that continue to grow. And we think, in general, translations are a great way to engage and build new contributors to open source projects, and so it's front of mind for us. We do a newsletter focused on developers. Would really love all of you to join that. That comes out each week, that tells you what's going on in the community. Really important for us, as I mentioned before, is highlighting civility and diversity at the core of Hyperledger. There is a recording. These slides are now posted online, so those links should be clickable. There was a presentation given at our last face-to-face event just about a year ago, talking about the Hyperledger approach to diversity and why that's important and how that's important to us. We do have an upcoming virtual event. I'll just flash it here. Let us know if you're interested in attending. It's taking place in June, and it is online. One thing I just want to end with is how we're running Hyperledger as an open source project is very much how the Linux Foundation runs open source projects, or facilitates, I really should say, communities around open source code. We don't ourselves fund that work. We do employ Linus Torvalds and Greg Crow-Hartman and Shua Khan and a few other people on the core Linux kernel, but of all the hundreds of open source projects we host, and at this point it's over 400 different distinct projects from and involving membership from 2,000 different organizations and 41 different companies, 41 different countries, involving contributions from almost 250,000 developers, and different ways of measuring the impact. But one study came up with 54 billion in value created by the open source communities we've hosted. And last year we were adding a new project every week. The real focus has been on how do you make these projects sustainable? How do you really get a circle going between open source products that get used by companies to go out and build things, and they generate profits from that then come back into the projects that build those products, right? Not in any direct revenue kind of way, not in a, hey, IBM, can you fund this one small thing, for $20,000 kind of way, but instead builds this kind of ecosystem where the stakeholders who are making money from this realize that paying it forward and being engaged and actively funding not only their membership at the Linux Foundation, but also having full-time devs working on code and improving it is a faster way to get where they want to go than buying proprietary software or trying to write everything themselves and keeping it to themselves. So that's what we really focus on at the Linux Foundation. All sorts of different kinds of projects that range from single code-based kinds of projects to umbrella organizations like Hyperledger, that range from things that are way down in the plumbing, like the Cloud Native Compute Foundation and obviously the Linux kernel, to things that are kind of up at the end user level, things like this software project we do with the film studios called the Academy of Sciences Software Foundation, which is all about Pixar and ILM and Disney and other animation firms sharing code to do digital filmmaking, right? Just kind of amazing, like you can go in that direction, to automotive software, to all these other things. Linux Foundation's really become a home for this really wide variety of different projects. And with that, I think I'll pause and take a look at the questions that have been answered. But that's the big picture on where things are at and how things are going now with Hyperledger and with enterprise blockchain. And it still feels like the same point it felt like in 1998 when, actually 96, when we were 5 years into the World Wide Web. Remember, Tim Berners-Lee's first web browser, first web server was 1991. And by 96, we were still just getting off the ground. I'd say we are a lot further along in those 5 years than the web was in its first 5 years. And there's so much more that we can go in. So with that, let me pause and take a look at the shared notes and see if there have been questions. I think I'm going to look there rather than in the chat, because I know that was the structure that the folks wanted to use. Is that fine, or should I look in the chat?
Yeah, you can look in the shared notes. Brian, I'm just so impressed because we don't have to engage anything. You just work out everything yourself. It's such a pleasure to work with somebody who is really into open source and knows how to handle the system. So thank you very much for the flowers here that you also mentioned earlier. And we have two questions already, and the audience, please feel free to add more questions or direct them to us through the other channels. So the first question is this, and I don't know who was asking this question. If there's additional questions, you can also switch on your microphone. We're happy if you would like to have an interaction directly, but I'll read it out for you. In the Cambodian example, do the end users participate upstream in the Hyperledger project, or are they basically consumers?
Yeah. So the company that implemented this for the Cambodian government is called Soramitsu, and they have been incredibly active as a contributor. In fact, they lead the implementation of Hyperledger Iroha. They're not the only ones who work on Iroha. There are plenty of others as well, but they've built a business out of serving the needs. Not just, that's just one of their many different customers. I'm not aware if there's been any developers on the Cambodian side who have also participated or contributed anything upstream. They certainly could have, but there have been, as I mentioned, other contributors to Iroha, the upstream code. And I certainly expect that many of the other kinds of companies who do these blockchain services, those end user organizations will start to get engaged. One example of this is Walmart. Walmart started very much as a buyer of this kind of concept from companies like IBM, and now have a very active internal team of owning kind of this picture of, how should they use enterprise blockchain technology to go and do all the things that they want to do. And I think we'll see many more end user organizations doing that kind of thing. Should I jump into the second question?
I'm just like, waiting. Like, okay. Sometimes people need a moment to add a question. So, okay, so we can go on the second question, and I would like to ask Roland to address the question directly.
G'day, Brian. Actually, can you hear me?
Yes.
Yes, excellent. So this was sort of a shooting a bit high on eliminating dependence upon existing centralized infrastructure, and particularly DNS. I would need the technologies you're working with replacing DNS even for specialized use cases. And I'm aware of the ETH thing. I'm wondering if there's people are working on anything else that has any plausible uses.
So I would actually cite the domain name system as an example of minimum viable governance. The organization ICANN is certainly an organization that is easy to criticize. They've made certain questionable decisions historically, but one thing that can't be criticized is for being too big. They rightfully so have pushed all of the hard work and all the value capture of registering and serving domain names out to the domain name registrars, right? And there's a very healthy and active competitive ecosystem out there between over 200 of these domain name registrars, right? And the registrars are required to make it so that if you register a domain name with one, you can take it to a different registrar and have a consistent process for doing that. They also require have a uniform way to resolve disputes around, if I register RolandTurnerSucks.com, you have a way to appeal that domain name and say that's not a good thing. I mean, more like McDonald's sucks or something like that, right? Some brand name sucks, and that's an important thing to have in any such system. So ICANN can always be improved, but think of how they push everything to the edge, or as much to the edge as they can. What I haven't yet seen is a blockchain, is a way in which what they do could be improved using blockchain technology necessarily. I do see several projects that have emerged out there on the cryptocurrency side to be a blockchain DNS alternative, and they typically land on things like first come first serve to your domain name, where it's like an asset, very much like an NFT, very much like a non-fungible token that then gets locked into the system. And I disagree with that, because I think there are reasonable governance reasons why that shouldn't just be first come first serve, right? It also doesn't seem to me, it seems like you want to be able to have a price point for registering of domain names that it doesn't matter how big or small your website is, or your domain is, or how much in demand that name is. I've seen some sites implement auction systems, or some proposals be, well, you should compete in an auction for the value of the domain name. Well, that would be very regressive, it means somebody's name, could be subject to somebody else trying to just bid it up and then steal their traffic or something like that. So I don't think that's a system that would be improved at this point by moving to a blockchain system. But that's only because ICANN has done a very good job doing something incredibly hard, which is keeping the global domain name system consistent and relevant. I'd sooner look for the digital identity landscape to go that way, because I don't think we're ever going to see an ICANN-style organization emerge when it comes to distributed digital identity. I think what we'll see is a collection of organizations like Sovereign, the Sovereign network that you've probably heard about, other types of layer one utility networks that are defined by something called the Trust Over IP Foundation. Actually has a nice stack that defines what these different kinds of layers of governance can be. But optionality, I think, is going to be really important there. But when it comes to routing packets on the internet like IANA and where do domain names resolve, I think there's an unavoidable degree of centralization required to provide that consistency. Let's just make sure ICANN is as accountable as they can be to the network. And if someday they do need to be replaced, I'd imagine a DLT-driven replacement would be preferable to what they have now. I don't know what we're at on timing in terms of when you want to.
Thank you.
Sure.
Okay. Thank you very much, Roland, for this question. And I have another question here. As open source is playing such a big role, I guess, in blockchain technology, does this also change the views and approach to FOSS in the industry? So FOSS for free and open source software. What is your observation?
I hadn't thought about whether it actually changes the approach to free and open source software. I think today in the open source community we do have an unfortunate degree of centralization. We all think without batting an eyelash about having repos on GitHub. Now, some people go ahead and host their own, and there's GitLab, for instance, that makes hosting your own repositories very nice. But we don't have a nice way of getting the same social network effects that you have by being able to point to like your GitHub history, for example, right? Or stars on GitHub as a measure of how relevant your projects are and that sort of thing, right? And so it'd be really nice to see if we can get to better decentralizing tools for the software development process itself. Not just can you move a repo and host it at a GitHub hosted instance, but what would it actually mean to have a GitHub repo hosted virtually, or for somebody's developer history and developer identity to transcend all these different sites without it just being about login with your GitHub ID, right? I should be able to log in with an identity attached to brian@bellendorf.com or something like that, right? So that's where I think we might be too centralized in the FOSS community. And one reason I'm so happy to see you all using Big Blue Button and Jitsi and things like that is we need more of that culture of the principle of we should use these technologies not because they're cheaper or faster to use or even technically better, but because there's an inherent freedom to how they're using that sets a principle that sets us in the right direction. So
decentralization has been a topic for many years, and I remember how we deployed mesh networks here in Berlin. I even went to Afghanistan and deployed the OLPC and mesh networks there, right? So these decentralization topics, they have been there long ago, and we have this search project here. We cooperate with the Yassi community, right? The distributed search and so on. The challenge was always how to make this commercially viable. The challenge was how to make it for example, as fast as Google search, right? Or to make the connections as stable. If you, for example, had a lot of hops in a mesh network, it was a challenge. And but today we see that these mesh technologies, for example, are used by companies more and more. So we see here in blockchain, it's decentralized, yeah. But we also see more decentralized projects and work in other domains like Wi-Fi, yeah, and so on. So was it that it was all too early, maybe, because I think this decentralized view is in the heart of many people that we want that, right? And what are your thoughts? Are we going generally more into the direction of decentralization, and will that be just an extension of centralized frameworks? So for example, you have the mesh network, but it's at the end still the internet companies, they still are centralized, but you are just an extension. What are your thoughts? I think you're in a perfect position at the Linux Foundation to think about these things.
Yeah. So I think one thing that's important for us at the Linux Foundation is to not get too far ahead of where the communities are. Hyperledger wasn't started because I or my boss felt that it was urgent to do it. It started because there were a set of companies who had already started talking before they called us, who said, maybe we should figure out how to use the technology underneath Bitcoin in a way that avoids some of the issues that we all have with Bitcoin, right? And again, lots of respect to Bitcoin, but it doesn't have to be the only answer to how you converge on, a distributed ledger. And so they approached the Linux Foundation because they knew that the LF had run other projects like this. And then my boss got excited. Again, this happened before I got involved. Then my boss got excited and said, okay, this could be a big thing. Here's a whole bunch of other companies to call. Let's go ahead and do this. But likewise on the Linux Foundation Public Health Initiative, when the pandemic hit in March, there were a bunch of us who said, well, is there some way that we could use technology in the fight against this pandemic? And I didn't talk much about that during this talk here, but the first domain in exposure notification, right? The contact tracing apps that tell you you've been close to somebody who's tested positive. What became clear for some of us who were looking at that domain was that there was a need. People were calling out for an organization that could serve as a home for figuring out how to do this in a privacy preserving way. And that wasn't Apple or Google, right? That wasn't, or even Microsoft, right? There was somebody who could be neutral, somebody who could be, focused on the community, the people who show up, right? But also ethical enough to not push something that was inappropriate or would make the world worse off. And so when I think about other opportunities to go into other segments, and what the Linux Foundation does, it goes and builds these projects. We always have to be kind of delicate, because even if I think that there really ought to be an open source project that solves this problem, if I can't find a critical mass of people already thinking along the same lines, it's not going to work very well. I can't sell that to people if they don't want it. So it's been frustrating sitting there and watching certain things like Facebook go from a college message board in 2006 to becoming something that brings down democracies. Maybe not. I should roll back on that. And yet there still isn't like this massive outcry for figuring out how to do decentralized social networking. There's a little bit more now than before, though, and at a certain time, maybe there'll be enough incentive for companies to say, okay, this is the right thing to organize on. It's so hard to predict where the market timing is on these things. My sense, though, is that this need to figure out cooperative models for implementing all the kinds of things that, if they got centralized, would be really bad, is felt pretty strongly right now. It's just hard to put in the form of like a pitch to a venture capitalist, or for to raise money on, or as a single company to find a sustainability model around. But if you can tie this to some sort of regulatory process, like people who want to make sure they're not buying the products of slave labor when they're buying, a diamond or a tennis shoe, right? Wherever that conversation is happening around how that industry can get to better traceability, you'll find a set of startup companies, small companies that have said, we can help with this industry through that transition. We've got ideas, we can use this open source software, we can marry that to our technical skills and get something like that done. And so I don't know that we'll see the next big Amazon or the next big Google come out of blockchain technology, but I think it'll help make the world a better place if we all use it to the extent that we can.
Thank you very much. It sounds like another session should be done on this topic, but we're coming to the end, and there's still one question here. You are now also the GM for healthcare and identity. How is that connected to Hyperledger? I think you already addressed this a little bit, but maybe you want to mention.
Yeah, just a little bit. On the identity front, the Linux Foundation, within Hyperledger, one of the big use cases early on has been around digital identity, and especially Hyperledger Indy and Hyperledger Aries have now become kind of foundational technologies for implementing self-sovereign identity platforms, user-centric kind of identity. The Linux Foundation's recently added 2 new projects, something called Trust Over IP and the Decentralized Identity Foundation. They kind of started life kind of on the periphery and then came into the core. And they're both more like standards efforts, but a little bit of software. And then and harmonizing that effort with Hyperledger is becoming important to do. And then thirdly, this Linux Foundation Public Health project, it started in exposure notification, but right now is very squarely in this vaccination credential space. And it's expected that would use self-sovereign identity as part of the underpinning for how those platforms would work. So trying to harmonize all these efforts and show that blockchain had relevancy, particularly in these 2 domains. It'll have relevancy in a lot of others, but I felt like it was important to bring those efforts together at the Linux Foundation so that we were all working in the same direction. My boss agreed. Jim Zemlin.
Excellent. So who's your boss?
Jim Zemlin, who's the overall executive director for the Linux Foundation.
Of course. Yeah, Jim Zemlin, of course. It's great. So I was just wondering, and Brian, we're at the end of this session, but I quickly want to also share with you, because actually the chat system is kind of decentralized in a way that there are a lot of like different chats here and there. I wish it was somehow on a technology where you can, for example, take a Telegram chat into Signal and a Signal chat into Rocket Chat and so on, right? I think whoever can solve this problem, maybe that will be the big Amazon, because I'm on tons of different channels now, but I want to share what I'm getting here. So feedback to your session is, I like Brian. Okay, so people like what you do. Brian, he mentioned open source. Yay. Yeah, so they really like this industry, and like then mentioned open source, and he's a FOSS person. So so people really appreciate your background, and that you're connecting these different worlds and really bringing this openness, like, you know, everywhere, right? Like, so that's really
well,
nice.
It's great to work at the Linux Foundation, where I work with over 200 other people who are also very passionate and mission-oriented about what they're doing, and we're very active in Asia, as you all know as well. So we're really, I really appreciate the opportunity to speak at this event, and really hope that the audience was able to take a few things away that might be new for them, and hopefully we can all meet face to face next year.
Cool. So thank you very much for joining us. It has been an absolute pleasure. We appreciate your joining, and I saw it's like already very late, right? You like got up, and we tried to find a suitable time, so somehow it worked out. And yeah, I really appreciate, and a lot of people appreciate your work, and that you connect with us here online. Thank you very much.
Thank you, Mario. Thank you, everybody involved, for making this happen.
Have a good night, and thank you. Bye-bye. Okay, so, and we are preparing for the next talk, and I'm handing to our next. I'm handing over to Mishari to continue the sessions here. Thank you.
Hi everyone. I'm for those who don't know me, I'm Mishari Mukul. I'm based in Bangkok, Thailand. See for the
Mishari, I think we
chief.
Lost you there a moment.
You lost
the connection, but it was always good. But now something is like we can't hear you well. It's like chopped off here.
Well, that's the joys of going live, right? Are we good now? Right.
Yeah, I think it sounds. Yeah, it seems good. So yeah, just continue.
Okay, thank you. Introducing Thorsten Neumann, the Chief Technical Officer and Venture Lead as SC Ventures by Standard Chartered, who will be giving a talk titled Diem, which is previously known as Libra, which is an open source financial network, an open source project to build a trusted and innovative financial network. Thorsten, could you please switch on to your webcam?
Hello, Mishari. You hear me?
Hello, I can hear you fine. Yes, I just need to see you. Fantastic. Screen sharing?
Okay. Let me turn on screen sharing. Thanks for the intro.
Sure.
Mishari. Let me just bring this up. Okay. Can you see that?
Fantastic. Working.
Okay. Great. So dialing in from Singapore, Mishari. We're not too far apart, actually. Are you ready to go?
You're ready.
Okay. I hope the rest of the audience can hear me clearly.
Thorsten, we can hear you fine. What I might do, given that Mishari is having some difficulty, is perform the intro for the benefit of those who haven't read the program. So Thorsten is a long list of titles. CTO at SC Ventures, CTO Ventures Lead, also at SC Ventures, and extensive experience in ICT domain. Okay. Not mentioned, you're also part of our organising team most years. I don't recall whether you've joined us this year.
Yes.
So your topic today is an open source project to build a trusted and innovative financial network. Perhaps I won't read the entire thing, but I'll ask you to go ahead.
Good. Thank you, Roland. And indeed, very glad to be amongst my FOSSASIA peers. This year, I've had some other priorities which had less involvement on the day-to-day. I just want to share my screen sharing cut out. So I'm not sure how to activate that. Let me just get that set up again. So great to be working with you, Roland, Mishari, Hong Fook, Mario, and the team. Thought I'd take the opportunity this year just to spend about maybe 20 minutes on sharing what's been happening in the open source space around Diem, as it's called, and give you a bit of a taster for that. Really personal curiosity, kind of looking at the tech, looking at some of the media announcements of where this has been going. So I'm going to give you a bit of background and then get into some of the practical playing around and applications with a demo and a bit of a deep dive. But great, and thank you for joining, because it is, of course, somewhat even contradictory to be calling it an open source network when when historically this concept of Libra, as it was called, was backed by Facebook, and that came out somewhere around 2019 already. So it's already been 2 years where there's been talk about a network and Facebook itself as the social media company being involved in this payment infrastructure. And of course, we saw a lot of regulatory pushback. There was a lot of challenge around crypto custody, custodies as a whole, lack of regulation, and definitely lack of approvals. And so that kind of piqued my interest, and I've been following the story for a while, purely because it's very difficult to marry the two, right, between the unregulated space and then having access to a large audience and being able to bring them the convenience of everything that is crypto related, without all the headaches of key management, wallets, without all the blockchain complexity behind it. And of course, as soon as a company stands up and says we're going to do something in the space, it attracts a lot of attention. So with that background, I thought I'd look at this open source financial network, as they call it. And Libra more recently then rebranded into a new project name, which is called Diem. And that's quite recent. That was just in December. So Diem Association is effectively a neutral body that's overseeing this project, this network, and these currencies. What's also been quite telling is that some large names have gotten behind this initiative, and the most recent one is our own Singapore Temasek Holdings, which is to join the association. It's quite an unusual move because it brings quite a bit of credibility to the network, at least the project. Maybe the most telling is that, unlike a lot of other projects, it was redesigned to be a permissioned blockchain network. So as opposed to open nodes run by anybody everywhere, the network has been interestingly designed to be more centralized, but still give the transparency and the access to really anybody on the fringes. If we look at the network, it kind of has a validator full node network in the middle, which is this purple block, where kind of authorized permission nodes join the network and share information amongst themselves and replicate state, so it's Byzantine fault tolerant. But then beneath that, we've got public nodes that can subscribe to the network and effectively synchronize the state. And that's interesting because it means that there's transparency in the data coming out, but the actual core of it is kind of controlled and restricted. And then the core provides these APIs that anybody can talk to, such as, for instance, clients who then perform transactions on the network, which then again get replicated through the blockchain infrastructure. So this is all public information. That everything I'm going to be talking about is in the open. And so it's out of that curiosity that you can get some access to it. I'm not saying it's at the fully ready state yet for easy adoption by every retail or every engineer. It takes a bit of digging, but it's certainly improving. What's interesting about the network is it's got kind of different types of addresses, and they've done this for very valid reasons, is to say, we're really going to create a wallet for an account address that is 16 bytes in length, and that is your primary identifier. Now, on top of that, you can have sub-addresses that can be for one-time use, or that can be assigned to single wallets. So effectively, you can have a main address that can be that can allow for sub-addressing just for separation of functions. But most unique about this is an account identifier, which is effectively a BEC32 kind of hashed, or call it translated network address. And these addresses effectively consolidate the main account address and the sub address into a wallet address, which can be used universally for things like merchant payments or other type of transactions. And so they even come up with a bit of a naming convention. I thought I'd share this because it's relevant in how we then use the network. And then, of course, these account identifiers can be put into these URIs, which then can be passed along in mobile apps or in linking or other type of web applications to interact with that counterparty. So if you're doing a peer-to-peer transfer or you're doing a merchant payment, it will be through this intent identifier. So a little bit interesting in the sense that they've separated these addresses, also allowing you to change your private and public key, effectively your private key on the account that you're managing without changing the account address on the network. So there's almost a separation between what is your encryption keys that you can rotate versus the address that you're using on the network, which remains the same. And so unlike Bitcoin or Ethereum, where those the two are the same, the private public key is your identifier. Here you've effectively got a proxy account address that you can repurpose, and then a separate set of keys that can be rotated. And again, that means that you keep your identity while keeping control over your keys. If we look at network, published some JSON RPC methods, which are just a basic set of those for public access, and those are the ones we're going to be playing with a bit. You can submit instructions, you can look at transaction histories, you can query an account, you can get the account transaction history of an account identifier, and various metadata of the network. So again, it kind of shows that yes, there's a robustness and a richness in the data that's coming out of the network, even if it is somewhat centrally run, perhaps comparable to Binance Smart Chain, for example, which is a permissioned parity Ethereum network. First off, I think what we can do is just spend some time running a local node. And so what we've done is we've pulled the source code from GitHub. It is in Rust, and we're just going to run this node. And so there's two parts. That there's obviously the node and then localhost, kind of the client side connecting to the localhost. That can either be through a CLI or it can be through an HTTP call through Postman or to the JSON RPC. What I'll just do is I'll just switch to my Ubuntu instance and just show you what that looks like. So just giving that a moment to load up. And so first off, what we'll do is just simply, this has already been pulled. So if I just have a look at, just kind of bring this from testnet. That's my latest pull from the GitHub Diem project, and just into the branch testnet. And quite simple after the initial build, right? It's just to actually run the Diem node, and with this parameter test, which kind of spins up the test node. So this is the simplest kind of exercise, just to run a local instance. What we'll do later on in this kind of walkthrough is see how we then connect that up to the testnet, and you'll see the amount of data that then starts kind of publishing through. But in the local node, what we'll see is just obviously basic logging information, configuration that's being used, that's got certain keys in it. We can look at that. Some root keys that are just generated locally for the instance. And then this waypoint is an identifier on the network in terms of the state. And so in terms of here, it just spits it out. In the public network, that's actually published centrally, and we will download that in order to synchronize our local node with the validator network. As you can see, the JSON RPC is up. Then it's just exposing a TCP/IP port for access, and then chain is testing. So quite straightforward. What we've got to do is we've got to now put this in order to connect to the node. We're going to pick up another instance, another console here, where we're going to pick up the CLI, and we're just putting in some commands here. So I'm going to run this client node on the testing network. I've got to connect to the instance of the mint, effectively the instance that we're connecting to in terms of the mint key. So I'm just going to copy that from here, which is my mint key over here, and just taking that into my local configuration. Next, I've got to specify what the JSON endpoint that I'm going to connect to. So that will be my RPC API. And lastly, I've got to synchronize my waypoint. And this is, again, just for the documentation out there of me connecting into this local node network. So actually just client server between the two. And what you see here is, let me just make that a little bit larger for you. is effectively a local client running where I've got a number of commands that are listed out on the left-hand side. So that's quite neat. And now I can do different things. I can I can just obviously ask for the help, which is my menu here. I can look at for information on the blockchain network. So it tells me that this is a test network and a validator running. And so it is in the testing chain. What I can do is I can, for instance, go here into the accounts submenu. I can, for instance, I can list accounts or recover my seeds, or I can write to a seed file just for testing purposes. So quite simply, I can, for instance, go account and create a new account. What you see here is that created an internal account, and that's just an identifier. And if I list out the accounts, I can see, okay, here's a local account. It's a private key that's shared to me for my testing purposes. What I can also do then is I can effectively mint some coins. And let's say I want to add 1,000 coins to this account, and I'm just going to use the primary kind of index identifier 0. Okay, in this case, I actually need to get my currency right, XUS. And it's connecting to a faucet, and it's going to mint that, and it's going to put that into my account. Yeah, let's see if that comes out right. Okay, and it's going to be putting those into my account. So if I list my account now, I can see this account has changed from being a local account into a persisted account. And also, if I then query the balance, let's say query balance on account identifier 0, I've got 1,000 XUSD coins in this wallet. And so I can do that again, right? So I can effectively also create another account and then just create another one. There we go. I might, for instance, in this case, just under the account, add a currency, which is XUSD, XUS, to the second account. So again, I can query that balance and say, query balance of the second account. Oh, that does not exist yet. So that's still seen as a local account. So maybe I just need to mint some coins for that to get it running. Mint ID 0, maybe just 10 tokens, XUS, that one. Again, I'm just going to top up the second account. And what we can now do is move between the accounts. So the chain behind the scene is already running all of this. And if I do, for instance, now a transfer from 0 to ID 1 of just 5 coins, that's been submitted, and I can query that transaction. So here I can just query that transaction. I can see, okay, that was executed. And if I query the balance now of the second account, which was run, I can say, okay, let me see, okay, now the balance is up to 15. So we already have this kind of blockchain node running. It's local, running through this RPC interface. And if I now look at my account identifiers, I can go here and I can pull this out. I can also switch to my node, and I can say, okay, I want to query that on the local network. And I got I didn't get a response on that one. Sorry, let me go back to this method here. I want to query that on my local node. And I get some information back. So the real test here is, there's some code base that's been worked on. It's been supported by the association. It's been making good progress. And we can actually see that these things are coming together between accounts, the network, the transactions, the faucets, and all the rest. Now, what I've done is I've just moved ahead, and I'll to just spinning up a full node. What this means is we're going to subscribe to the public network, we'll call it the test net, as a replica full node, as per this command over here. That's kind of cool. As I mentioned, I just got to reset my waypoint. So if I now head down my local node, I'm just going to remove my waypoint and just pull that from the network. I've now got this waypoint that indicates the current state of that network, the identifier, and I can now start up my local node. And if I start up my local node now with a different configuration pointing to the public network, we can start seeing a fair bit of activity already with it synchronizing. And what you'll see right now is a fair amount of data coming through. Maybe most telling is that if I look at the amount of data I've already replicated here, we're up to 4.8 gigs worth of data in my local data file, and you will see more of the transactions coming through in the background as the network starts synchronizing. You can see these synchronization requests and then various updates confirming that the blocks are being passed around and I'm receiving the state from the main network. Why is this cool? Why is this relevant? Is, well, we're obviously seeing the traffic go through, so this is not simulated. This is real traffic flowing. We can see the amount of data that came through. So last night I was on 1 gig, and now I'm up to 4.5 gigs and running. If we just look at the configuration of the of the full node pointer, we're running a full node. We've set it up to go into a local data directory. For some reason, in the testnet, discovery method is none, so there's no dynamic discovery. If you turn it on, it comes up with a lot of like private kind of host names that are not particularly resolvable at this stage. Yes, it certainly is propagating its peers. And so in this testnet setup, I simply connect to the testnet public endpoint on a certain port, and it handshakes. What's interesting is that the documentation on the GitHubs is not always synced into master, or even in the main branches. So you've got to go into the test branches to find the documentation. If you're in the wrong branch, you pick up some bad configurations, and it'll take you a long time to figure out what's what. So just make sure you're in the right branch if you're going to play with this. Effectively, it is a public network that we're connecting to, so something novel. And as I shared, it connects, it works, and there's lots of data coming through, and it's nicely JSON serialized. It's all written in Rust, so it runs pretty well. And then it'll just keep on collecting all the data and the state from the public network. This is what I highlighted, connected peers. We can see the nodes, we see the synchronization requests, and then after a block of transactions have come down, here it's synchronizing 1,000 transactions, and the sync status is then finished. And there's lots of traffic coming through. So net, it's participating in the main network. Now, why that's interesting is because, again, if I go to my CLI and I change this to join the testnet, effectively, as I've just demonstrated earlier, we can also do the same on the testnet, and I can, for instance, query balances. What I'm going to do is I'm going to recover my seed from a wallet, or wallet from a seed address. And again, I've got these keys here, and if I query that, let's say here I go query the balance of this address, into the public network, well, there's a fairly large amount of coins in this wallet. Just mindful of time, stepping us through. What I can then also do is I can go to the testnet, again, on the same endpoints. I'm just going to use the same address and query that. And again, I can do some transactions between different wallets. So if I were to do a wallet transaction, let's say I do a transfer of, let me just have a look here, transfer from the sender, which is my, let's say, 1 to that one of 10 XUS. Let's see if that works. Oops, easy transfer. Okay, the sending account does not exist, so we'll have to go do something else. What I wanted to show you on further to is we can now look at something very cool, which is the Diem Blockchain Explorer. And so here, for instance, I can put in this, put in my local address, and I'd find that this has done a fair number of transactions on the network. I can drill down into that. I'll be able to see, my private wallet address is here, so that's from my locally generated pair. And if I wanted to transfer to this recipient address, or maybe the other way around, let me just do that from my CLI. I'm going to transfer, say, from my account 0 to this recipient, which I don't own, maybe 7 XUS, just so we can identify that. Okay, and that was submitted. What's interesting now is if we go to the Test Network Explorer, we'll probably see that at the top of the queue. Okay, a lot of transactions going through. So if we have a look at the recipient, here's my 7 that are in flight just within a minute ago. And let's see where they came from. Yes, they indeed came from my originating node. So the network is coming together in terms of having the visibility and having the insight as to what's going on. Lots of different keys and hashes. And what's interesting about the approach here is that the ability to move money between wallets itself is a smart contract programmed move kind of logic. So maybe I'm using that terminology wrong. So move is the smart contract language, and to move money between 2 coins, which in this case are XUSD, there is a smart contract powering that. And so that sets the foundation for a lot more development and innovation to come. But today we're just playing around with these synthetic type nodes. Having said that, the testnet is up, and I think there's some very interesting references and things to play around with. One that I found there, Association Publishing, is the wallet and the merchant. Both are kind of discoverable by just playing around in their documentation in their browser. What that means is if we have a look at kind of the wallet side, let me just find which reference I can use. Yes, here, the Diem wallet. I can now log into this, and it's not quite as live as it looks to be on the front end, so it's going on in the background. What you can see is that here's a wallet, and I've signed up for it. I've just created a balance, and I've sent some transactions through the network. And so here I can see that I've actually transacted in what is effectively these derived identifiers, right? These are the BEH32 kind of encoded identifiers. It's a bit telling, it's a bit of playing around here because you can't actually see the underlying network address. So what I've had to do here is literally just take this identifier and reverse it. So just jumping back to the documentation, there's a CLI where I can use a function like that. So I can say address from BEH32 address, and I'm just going to try decode that. And so it codes that into its underlying address, which is here. And if I were now to take that address back into the Diem Explorer, I can see, okay, this address has done a number of transactions. The reason I'm just calling it out is because wallet, this public key pair that's being used here actually has 4 million USD allocated to it. And I've just transferred those $7 in. Actually, within the wallet front end, there's a bit of I guess, illustration here of how it should work and what a wallet address would look like. But it's kind of cool because you can go and add a balance. I can choose my funding source, which is just simulated. And let's say I want to add 50 USD to this wallet, and I confirm that transaction. That was done. And now that is reflected here. It does actually publish that onto the blockchain network. So if I refresh this page for this wallet, we find that the 50 has been added. So a one-way view, but nonetheless, the network is indeed powering the transactions. Why this is relevant and why this goes back to kind of the Diem association getting involved is because the same thing is now possible on the merchant side, which is not quite clear to me yet how one exactly transacts. So you want to see transactions moving from a wallet into perhaps a merchant side, and you can perhaps choose which currency that is in, scan a QR code, or perhaps use a different type of wallet. And what you'll see in the bottom of the screen is this this Diem identifier, which is that unique address with an amount tied to it. So net, some interesting playing around, worthwhile kind of keeping an eye on it. Very interesting to look at the Move smart contracts. And then there's some add-ins and other developer tools that are emerging. So it's interesting to get behind the project a bit more, as perhaps there's some interest. So just to close out, I think we're just 25 minutes exactly. Exciting new network, open source, a lot of good code out there in the public, and it's backed by the Alliance. There's certainly a look towards the future with regard to regulators, kind of the service providers, and the Move programming language. The technical documentation is maturing, so it is experimental, and you kind of have to get your hands dirty, but it is taking shape. And then the best guidance is GitHub and developer notes. So the media mentions that we'll see more activity in 2021. I hope that was somewhat informative on kind of what's happening in the open source related to the Diem network.
Thank you very much, Thorsten. That was very interesting. Could you do us a favor and copy those links and put it in the shared notes under the topic, and so we could take a look at it. So just a question so far from me. So okay, so just to look at Diem, and before that we looked at Hyperledger. So what are the time being limited? Why would I choose to spend time exploring one project or the other? Can you give us some insights on that?
Right.
How do they differ?
Yeah, very good question. I think very valid question on the basis that the Hyperledger and such projects, of course, are building infrastructure and tech that will be deployed, by corporates and other users for their own purposes of sharing data. I think what we're seeing here is more of a financial infrastructure that is looking to effectively build a centralized platform to which many other ecosystem partners will then join, and that'll take time because unlike something like Hyperledger, which is there for data, perhaps for securing transactions between institutions, this looks more like a financial system, and so you wouldn't be able to just adopt this for your own personal use. But I think where the opportunity is for engineers and developers to look more closely at Move as a programming language, well, for smart contracts. And secondly, then to think about what are potentially the use cases that we can build on top of the Diem network if you were to have marketplaces, if you were to have e-commerce platforms, if you were to have booking sites or lending or remittance or anything else that is perhaps then more financial services orientated, which is transactional, as opposed to perhaps something that is more kind of Corda, Hyperledger, I don't know, Big Chain DB and other blockchains, which is more data orientated.
So would you require, say, a bank to be, I don't know, a host for Libra? Will it be connecting to a bank, to banks?
So from what I've seen and studied on the architecture side is that it's not a public network in the sense that anybody can just come up and be a node that perhaps stake some coins and mince some crypto and then kind of balances like Bitcoin with its 10,000, 12,000 nodes. I think here a bit the opposite is that you can participate in the network as kind of a recipient of the data, and you could initiate transactions, but through intermediaries. It might not be banks, it might be other ecosystem players. But I think the intent here is to have a very clear landscape of who is who and who's participating, as opposed to the crypto world where it's really in the unknown. And I think that's where the regulators are most concerned.
So who determines who can participate in the Diem network?
Okay, so good question. What I think is really coming into shape and is worth looking into is the Diem Association and the way that they are setting themselves up, right? So very public with kind of their model, with their kind of approach in terms of the go-to-market and what they want to address in terms of the challenge that they're taking on. What you'll find is that really just looking at it from what's public and what's on the surface and what's being published is that that the association, as they call it, wants to bring that kind of stability and that control. And that means that you'll have this consortium, you'll have people that get together, very smart people. What's very impressive is their kind of protocol improvements that they publish, their DIPs, in terms of the governance and the kind of the features that they're adding through a kind of formal methodology of accepting and voting on upgrades and protocols, which you might see in some other crypto projects, but probably not to this level of rigor and diligence. So you'll probably find that it'll be a very well-run tech stack together with a kind of very formal methodology on governance and change control, and then open it up for the public to participate. Bit different where a lot of the other projects are trying to bring the governance in as I'd say almost as an optional, while they're more focused on the crypto assets themselves and the use cases. So a bit of a different view and take to blockchain.
Okay, well, very interesting. All this blockchain is quite interesting. We're still unsure, right, whether it will lead to freedom or tyranny. I think the jury is out of that. It can go both ways.
Absolutely.
So just a quick question about the stack. I sort of remember Libra when they started. I think they mentioned that they were writing everything on Elixir. I noticed that you're using Rust. Do you know, like, did the stack change?
Oh, I'm not quite sure on some of the evolution of the stack. What I found is in the GitHub that there's lots of resources coming together. On top of that, what you're finding now is that a lot of different language support. So there's CLIs, SDKs in Python. There's SDKs in Java. What you'll find is that it's quite an active community. Golang, and so on the edge, you'll find that there's a lot of the front ends of the clients being developed in order to support wallets and web portals and interfaces. On the core, the engine is being built out in Rust, and I'm not sure if that's a big part of the kind of 3-year, maybe 2-year history that this initiative has had, and also since kind of the separation from Facebook, where it was, into this kind of separate standalone project called Diem, which means tomorrow in Latin. So it's got a Latin root.
Okay, wonderful. Thank you very much, Thorsten. Just to let you guys know, we are going to be on a 1 hour break. We're going to be back at about 4:30 Singapore time, if I did my conversions correctly. In the meantime, this is a free session, so please switch on your webcams, and we can all chat a bit about open source software in general. And again, thank you very much, Thorsten. And if you're welcome to hang around, and we can ask you some more questions.
Thank you for presenting. Yeah.
Switch on your webcam, guys. Everyone.
Hi, Thorsten.
Hi. Sounds like Hong Fok.
Hey, Eden.
Yes, it's me.
Hong Fok.
Okay. Hi, Mario. Good to see you.
Let us see how
Hello. Hello.
it always takes us a bit of time to switch on the camera.
Yes, but it works well, I must say. Also for presenting, quite a smooth experience using this button from the Eventjay platform.
Cool. Yeah, glad you guys enjoy it. Let's share this with Harish. I think he had some comments.
Yeah, I need to record what Thorsten just said about having a smooth experience with the Eventjay and joining the video and everything. Yeah. This should be our marketing.
Yeah, I'll display him with his picture and, like the comments that customers always have, yeah? It's a smooth experience.
So we got endorsed by the CTO of Standard Chartered for our services. Yes, I think we should make the most of it. That is a good idea for marketing.
Yeah, I mean, I think we got top talent in the community, right? Having put this together. And compared to a lot of the other educational platforms out there, this is really collaborative. So I think it's a good tool.
Nice. Yeah, because a lot of tools exist in free and open source. So yeah, we can try to plug things together. The question is still to have a bit more integrations. Like, for example, if you upload your slides to the system, so then that you also have your slides already here in Big Blue Button and so on, right? But it's about making these links, and we can always quick hack it. But then when you have an upgrade, right, you lose this functionality and so on. So yeah, a lot of questions. So if you guys, I have like here behind a big board where I always write down like, all the issues and all the questions, all the things, so I can post it, because I'm not so fast at posting it on the tracker.
Yeah. You'll have to take a photo at the end, because I'm sure it'll be a beautiful collage of mind maps and questions.
Yeah. Well, I already have a lot of things. So yeah, but I of course, like we should say thank you to Arif Jamal, who's leading the development efforts. Arif is currently working actually on the back end to get some more video features here up and running. And yeah, as we were talking about Harish, there he is.
Hi, I heard my name. and that's not the sneezing, so.
You've been invoked.
I just want to say if Eden and Mintia is here, if they are here, do you want to turn on the camera and say hello quickly? They've been working in the back. Eden been working for the past few days. In the back, maybe it's good to say hello, Eden, from Vietnam. Mintia, if you are here, you can also join us. She's been some in the support channel, I believe. Okay, no problem. Okay, but thank you very much, Eden, for helping out in the support room. Yeah. So I wonder if more people want to join the call here. Perhaps should I show how to turn on the camera?
Yeah, I think you should.
Yeah. Maybe let me share my screen. Yeah. So I think maybe I take this opportunity to share a few things on the website, on the page. So.
Might be doing a stress test and then Hong Fok of how many people can turn on their webcam.
Exactly.
At the same time.
Yeah, this
I'm
is
sure Roland would approve, but
Roland has muted, so hey.
Mario, yeah.
You're muted, by the way.
I would encourage it between sessions. I don't know if I do it live, like I wouldn't do it in the middle of a scheduled session.
I think we achieved like 62 or something like that. There weren't more people in the channel at one point, so we couldn't try more. Yeah. So we only have 32 here, and I think some people are only attendees, like they don't want to switch on.
That's awesome.
If you can see my screen, and then you see here in the center, when I'm speaking, there is that microphone moving. I can. So that is how I mute myself. And then next to it, there is the share webcam option. If you want to show your face, you can just click on it, and then it will show the video here, and click start sharing. And now I'm here. Yeah. So moving on, you see on the chat, and I think everyone knows the chat already. You see the share notes on the top of the user number. You can see the share notes here. You can enter your questions, and this very important, this side panel. So from this side panel, you can actually move to different rooms, and you can also visit the exhibition. We have the chat iterated here as well. So let's say I can move like step by step, so we can all see together. I don't know if the I should have opened another tab. Sorry.
Yeah, you clicked and you brought yourself away. You have to do it in another tab. So this is one thing on the wish list, that the video maybe stays somewhere. So actually, Minja didn't understand. She thought she has to go to the support room.
Yeah. Okay. So here again, so I will open the side panel here, and we'll click now to see what's happening in the Lifelong Learning Institute.
As a suggestion, maybe if there's a possibility of renaming or adding something, it's a shared notes is also to say all Q&A, because people don't necessarily put Q&A in a shared notes. So it's just terminology. So if that's in that shared notes icon, if you have a second one that says Q&A, post your Q&As here, and then there's less confusion.
Yeah. So Harris, that is an excellent idea. I was thinking maybe to have another tab, for example, where people can write in their question, and then others can upvote it or downvote it, even. Yeah. So. Yeah. But the question is here, if we implement it directly into Big Blue Button, or if we make it separate to this, because I don't know, this is in Meteor.js and so on. They're always these technical questions, right? And which component do you implement it? But yes, that's definitely confirmation.
Or at least a minimally rename shared notes to FAQ, or ask questions here, post questions here, or something, just as a start, right? Because it's not immediately obvious that shared notes is where I should ask questions.
Exactly. Yeah. So
hello, friends. Open source.
You can see.
It is all open source.
Thank you again.
Thank you. Thank you, Thorsten.
Harish, bye.
Okay, bye, Thorsten. Great seeing you.
Check in later this evening. Yeah. See you then.
What we're seeing, please explain what we are seeing.
She's looking at the schedule.
You're muted.
No, because Harris took over my speaking time, so I have to stop myself.
I need to.
So basically, you can see here, I visit the exhibition from this side panel. So there is the tab on the top. If you click on the exhibition, it will bring you here to this page. This is the main page of the exhibition. I just look at Red Hat just now. So if you go to one of the exhibitors, right, you can actually go back and forth. So I can move on to see the next exhibition. But the whole idea of this year, we try to for the exhibitors to put a lot of information about their work and what they are doing. So the audience can also go to the website and find out more information. Red Hat also have the jobs offer here. And something that I find really cool, we have all the sessions related to that organization listed also on the exhibition page. So here you can see the talk of Harish and also another colleague of his in Red Hat. Yeah, and Harish will talk more about the booth later on. And another feature, this is really new. Actually, it's just a few days before the event. We have this blue video button connected here, and from here you can go to the GC room. Yeah, and I want to say again, so here, go back to the side panel, then you can go to different room. Let's take a look at the support room. So in the support room, this is the space where a speaker can come in and test their setting, or if the audience want to come in and try out, if you can turn on your camera, you are more than welcome to join to this room. So here you can also see Mintia, Roland, and are there. So this is the support room. And then from the support room, you can go back to the main hall, live stream. So what is it in live stream? So live stream, basically our YouTube streaming service, and workshops. Yeah, so the workshop is also a GC room. I think the Lifelong Learning Institute. I believe the workshop has ended. There are still a few people in that workshop. It should end by now, I believe. Now let us get back to the room, or we can take a quick look at the chat. Yeah, so this is the chat, and so I saw that Robert was say something to. Oh, you've actually been. Let's see. Yeah, so I think that people also joining the chat. Yeah, good. Yeah, let me now go back to the main hall where you are all in. So this is a quick demo about the system. And now let's check if any of you managed to turn on your camera beside us.
Yeah. I want to show I want you to show us this invisible line where you can make the slides bigger or the screen, because a lot of people don't know that. Like, for example, just below the four screens. No. Like in the middle. Yeah, you also don't know. You know which invisible line I mean, Hanfok?
I know what you mean, but it only shows. It only
It's
shows.
large, it's 4 hours.
So, but I think, as Mario said, I think it's more useful to say that you can actually switch off the switch on and off the share screen so you can see the audience, the speakers. I mean the speaker. Yeah.
I didn't know about the invisible line. Thank you.
So you can make it smaller or bigger. You're not stuck to one screen size.
So I don't see on my screen. Why don't you share your screen, Mario?
No, okay, I can share my screen. So I'm.
It is a section that is in just above the bottom one that you see now, and the videos. That black line there, it's not a line. I mean, you move your mouse there, and your arrows, it will point up and down, so you can widen it or narrow it. So just slide over it. Yeah.
Okay, so how can I call it if I don't call it a line? How do I explain this feature to somebody?
Magic.
Yeah. So just below here, if you see my cursor, it's small, just below the screens. If you go up, you see that the cursor type is
changes,
slightly changing.
It's the place where there isn't a line.
Which is
That's why it's called an invisible line.
So you can make this change the size.
Yeah,
I hope it was
that's
visible. So I call it invisible line. I don't find a better term yet. Yeah, because like people always
this is
like
the first
saying
time
it's too
I
small or
see this
something,
as
right?
well. Cool.
Yeah. Yeah, so what are feature requests from you? I want to share quickly. So one thing that I think for the virtual exhibition, of course, it was like the idea to get the basics right, to have some information there and to have a video room. But like people don't always go and say, okay, now I go to the video room because nobody is there maybe, right? If you're in a real exhibition on site, you just see, oh, nobody's at the exhibition, let me go to somebody else. But if you go to a video room and nobody's there, you feel kind of sad and maybe you will not go there again. So one idea that we have is to make a 2D world where you see, for example, all the different booths in one room, and you can just like walk over 2D, and when you go close, a room will open like a screen, for example, Jitsi, or if there are only 2 people, you can try something directly through the browsers. And this is like Gather Town and Work Adventure and others have similar features. So it's not magic. We just need time to implement it, right? But like, do you guys have ideas, or people in the audience, please, you can type in chat. Yeah, what do you think? What would you like to see in the system?
Maybe this is Harish. Maybe a suggestion would be on the left-hand side where you see all the participants in the chat. I mean, the participant in this session. Something just below the shared notes, an entry where exhibition. So a number that goes there. So that means if there's any of the booths are occupied, that means if there is a video that is being presented, so at least you can see it. Or there's somebody there and I can hop over it if I want to. So. It's a low bandwidth, very quick, very simple way of doing it. It's a low bandwidth, no pictures, no fancy graphics, just a number.
So you mean the number of how many people are in which room, for example? Yeah. Yeah,
just below the shared notes, right? It has something. Now it says users 26, right? So maybe just above that, something that says the exhibition. How many of the exhibition have got people there, for example? Maybe the video is on or something. It's just a number, so at least I know, oh, there is something, I can go there now.
Exactly.
Right now, I have to go there to see whether there's anybody, and then finding out nobody there and come back.
Exactly, right? So that's not a good experience.
Yeah.
Yeah. It's also gamification a bit, yeah? So I have a community and I say, oh, we have the most people in the room. We saw it yesterday where people start to do some gamification with the sessions, like Hong Fook announced this contest kind of thing, which one is the most popular session. And then there was a girl who gave a lightning talk and who had like, I think 92 people who liked it already. So yeah, it will increase engagement in the system.
Yeah.
Yeah. Any other ideas? I mean, this is a really nice feature. I mean, the question is really, how will we continue? Will COVID be over in half a year, and then like everywhere in all countries will get vaccinated, and we will really go back to the previous times, and then people will say, oh yeah, I use the video system, but all these features, I don't need them because I just go to on-site events and it's more fun. Yeah, I mean, how much in detail do we go? How much do we want to replicate a little bit of the experience and make it more exciting? Yeah, I don't know. Can we have FOSSASIA 22 in Singapore?
I'm sure we can do it in person by then.
Probably. There's 2 separate questions. One is whether Singapore will be open enough for that to occur, and the other is whether our participants will be allowed to enter Singapore. The world's not going to go from closed to open in one step. It's going to happen in stages, and that might take multiple years, depending upon vaccination rates in developing countries, particularly those from which we invite attendees from Asia. But think India. How long is it going to be before India is clean of COVID? It could be a long, long time.
Yeah. I suspect this will still be doing this virtual hybrid model for the next 2 to 3 years. That's my sense of it. So I think investing in something, not too much of investment in terms of features, it's just easy, simple stuff, sort of fancy stuff, simple stuff, and then I think that should be good enough. I have not tested this, but I'm just and I asked somebody to do it for me. What is the experience of this environment on a tablet? Because I've never used a tablet with this whole thing. So, is it easy to use or not? I don't know.
I think we didn't have so many people who tested it yet. We're testing it on the mobile phone, and yeah, as we are changing still so many things, well, we test it and it works, right? But like one day later, we do something else. So overall, it is working, but like, you know, it's not a perfect experience yet where you like, sometimes you have to scroll or something like that. Yeah, but like we are working continuously on this. Overall, it's working. You can access the channel, you can like get the video and so on. But sometimes you might say, oh yeah, why this is that way and not the other way? Yeah. And so in my view, on a tablet, it should even be better than on the phone. Yeah. I think we really need the community support here to test on many different devices. Yeah. So, yeah. Now Homfuk disappeared. So we have to see, we're actually getting to the next session and should get testing here with a speaker, with the next speaker, that is Wong from Vietnam.
I'm taking a short break, a short bio break. Be back.
Okay, so just checking here with Wong. No, actually, I'm wrong. Actually, we have an hour break. We have so half an hour longer. Am I correct or not? Different time zones. I will check on the schedule myself.
That is correct. Half an hour later, 4:30.
Okay, at 4:30. Yeah. Okay, good.
That being the case, I'm going to go offline for about 30 minutes. I'll be back online and in a silent environment in time for the 1/2 session.
Excellent. Thank you very much, Roland. Then I'll also drop out. Thank you very much, Harish. I see you later.
Hello everyone. I hope you've been having a good break. So up next for us, we have Nguyen Hong Kuan, the CTO of AgriConnect, who will be speaking on the topic of my experience of developing Linux desktop app for scanning QR code. He's having a bit of a technical difficulty as we are live, so please give us a few minutes as we sort him out. Your patience is appreciated. Thank you. Sorry, just a couple more minutes. We should almost be getting it sorted out. Hi, Gwen. Could you please switch on your webcam and start your presentation? Okay, I see you now.
Okay.
I can hear you.
Good.
Now, this is your presentation.
Presentation. How to do it, because I have a link to my presentation, and here in the first button I see an item upload a presentation, so I don't know how to share.
Okay. Can you share your screen?
And I have a question. I have a pre-recorded video, so could you use it only, and then I will join the Q&A session.
Is it on YouTube?
Yes, I already passed it to the event chair. I will take it again.
Okay. Okay. Just a sec. Yeah. Please paste here into the chat. Sorry, Eden. Could I help? Could I ask you to help me with this? But if you can please paste the video link in the chat.
Hello, guys. So I'm helping out here a bit. Wong, just like so you recorded the entire session before, or just like a short part of it? Wong, your microphone is switched off.
Yeah.
Okay, so I leave this to you guys then. Thank you very much.
Hi guys. So yes, so we have everything under control. No problem. What we're gonna do now is we're gonna play the video of Wong. So Michelle already introduced Wong. So he is the CTO of Ari. Connect him into the FOSSASIA Summit for a while already. We knew each other since our time in Vietnam. Wong, so I will move you because you have a little bit of background noise. Before I play the video, I would like everyone to keep yourself on mute so we don't get the echo. Okay, great. So welcome to the FOSSASIA Summit, and here is the video.
Hi, nice to see you in FOSSASIA Summit this year. Today I want to share my experience of developing Linux desktop app from an example with QR scanner. A bit introduction about me. I am Kwon from Vietnam. I have long time contribute to many free and open source software projects. I work in embedded system and in web. In Vietnam, I also have a small startup with my friend to make IoT platform for agriculture. What is the app that I am about to talk? It's Koban, an application for scan QR code with your laptop. So, what it is for? I want it to scan the QR code with my laptop instead of phone, and I want it to not only scan from webcam but also from static image file. And as first, I want it to run natively in Wayland desktop. That is the point that make it different with other application. What are the features? One of the features is that if it see URL in the QR code, it will show a button for you to open the link quickly. And if it see Wi-Fi detail in the QR code, it will show you not only the Wi-Fi name, the password, and also it let you quickly connect to the network. Let's talk about the tech stack. My choice is the GTK for Guide and the Python as programming language. I use GTK because I mainly use Windows desktop environment. So when developing this app, what a good experience I gained. I am very grateful that many libraries support Python and support very good. So all the library with power the design feature I want to have in the app already have Python binding, and it is so good. Also the support from community is warm. Let's talk one by one. The first I want to tell is GTK. It's a guide toolkit for developing app for desktop. One good point I see from GTK is that it helps creating language binding for other language very easy by the introduction of G-object introduction. Thanks to it, it has a official language binding, and even the young language like Rust also has the binding for GTK and also has application in production. To compare, Qt, another guide toolkit, it has only one binding for one language. It's Python. And because of the usefulness of this design, so many other libraries also adopt G-object introduction, like UStreamer, Project Network Manager, and that design also help generate API documentation for other language easier, better, as you can see in the link. The next big player is UStreamer, because my app is need to access the webcam to get the video frame, so I have to use UStreamer, and I find that this is an excellent multimedia framework because it helps you imagine and implement the flow of data quickly. As you can see in the picture, that is what I imagine about the flow of my data in the app, and that diagram can be represented by UStreamer pipeline, and you can try it as the command line to test it before writing code. One big factor is JetBar. I am surprised that JetBar exists because before I create Cobang, there are so few applications to scan QR code, but JetBar as a library already exists and very complete. Without JetBar, I may have to spend a lot of time to research about computer vision. But lucky for me, JetBar exists. Another good thing is GIO, one component in GTK. The good thing is that it provides unified API for reading file, no matter is it on disk or remote file from HTTP or SFTP. As you can see in an example code, you can utilize the same for local file and remote file. Another feature of GIO is that it lets you drag and drop remote file from other application to your application. The next good thing is Network Manager. Network Manager is an application to centralize the network management on your desktop. So when I want my Cobank to be able to save the Wi-Fi detail and let user to quickly connect to the network, I may think that my application have to modify the system configuration. But luckily, I don't need to do that. If I do that, I may cause conflict with other application. But Network Manager let you communicate to it, so you don't have to modify the system yourself, but you just communicate with Network Manager, tell it to do. And Network Manager can be communicated via the bus, but it also provides client library for other applications to use to communicate with it. And it is also based on G-object introspection, so it's easy for Python language to use it. Here is the picture of the operation. So after getting the Wi-Fi detail, my object talk with Network Manager and it immediately appear in GNOME control panel. This is an example code that I use to talk with Network Manager. So those are the good experience. And what is the bad experience? One small bad experience is that the documentation is sometimes outdated and lacking. For example, the code to communicate with Network Manager, there is no tutorial, so I have to try to guess and read the code from other C application to see how to do, to guess how to do. Another big bad experience is the diverse in distribution way. So after you finish your application and you want to deliver to user, you have to package it. The traditional is that you provide it to Package Manager and user just use Package Manager to install your app. Other dependency will be automatically installed by the Package Manager. But recently there is also another way of distribution, that is package as container like Flatpak and Snap. But I personally find the way to build container is troublesome, because for the container way you have to build and include the dependency yourself. So when I build the Flatpak, I often spend so much time, and sometimes I cannot debug, cannot find out why it failed. Okay, so I already share my view, my experience about the Linux desktop application development. Because I want this talk to be short, so I skip some parts. So if you want to know more detail, please read again in FOSSASIA website. And now, do you have any question? Please ask.
You are now.
Hi, thank you very much, Kun. That was very interesting. Could you please come online? To the question, could you show the app live and share more technical details? I'm afraid that there's been he's having issues with screen sharing, so he's unable to show the app live. However, could you please let us know if there's a URL that can be used to go and try the application? Is it up on GitHub? Kun? So can you please open your webcam and your microphone?
Okay, so it's in GitHub. I will pass a link.
Okay, if you can paste your link in the chat, that would be most appreciated. Thank you. Any more questions?
There's one, can one turn on your camera again? I locked the camera earlier for everyone. So if you could turn on your camera again.
Wait for me because my browser now refused to show the webcam. Yeah.
Okay, no problem. So what browser? So just for the future, what is the browser? So we know for the future.
Yeah, I am using Firefox.
On Wayland, is that correct?
No, in H window I already switched off the Wayland and it's in H window now. I can share a screen of the Kobang app, but I don't know if you can see it or not.
It's not up yet. But I'm still not seeing your screen sharing. Oh, something's happening.
Sorry, I will try again.
So we're in 2021. We almost have self-driving cars. We have blockchains. We have amazing AI, but we still can't get screen sharing to work consistently. And the question is, how much do you trust self-driving cars when we cannot really get screen sharing to work?
Well, self-driving cars don't have screensavers.
Good point. But I think, have you read the rant? Everything is broken.
Yeah.
Yeah, this is systems operating always right at their threshold of chaos. It's like just enough things works to sell something and nothing better than that.
No, only my microphone working. the webcam and the screen sharing is not working.
Okay, well, that is a shame. I suppose that we had to figure out. Okay, so I suppose that concludes our session. Thank you very much, Gwen, for your excellent presentation. And so soon we'll be passing it on to our next MC. Thank you very much, everyone. Please hang on a moment.
Yeah, thank you. See you.
Hi. Yes. Hello, everyone. Chun Lei, you are early. Perfect. Now we can also test your audio. Very good. Can we hear you, Chun Lei? So your microphone is on mute. You need to activate the audio.
Hello.
Yes, perfect. Yeah, so we have still 10 minutes. I just want to comment a bit because I was living in Vietnam and I know that it was super challenging. There's a lot of noise in the country and it's difficult to find a space where you can have a quiet environment. So thank you very much, Woon, for taking the effort to join the summit. And here we're preparing for the next session. So Chun Lei, just a quick, we have never met before. We were really excited to learn about you and FreeCAD project. We did not know that we added actually a FreeCAD developer in Singapore. So welcome, excellent. You guys also have the information in the exhibition, the booth, right? So there we can learn more about the project, awesome project. And I would like to introduce you as well. Here I have Min Chia here with me. So she is actually based in Singapore and she will be your supporter, the moderator of the session today. Min Chia, do you want to say hello?
Hello. Hello,
Okay.
thank you.
I think they're all set. Min Chia, do you want to give Chun Lei the presentation, right? So we can...
Sure.
Yeah. Okay, so I leave it to you two now. Have fun. And see you in a bit.
Okay, see you. Can I test the screen sharing first?
Sure, go ahead.
Okay.
Would you have any video you will need to play in between?
It's inside the slides.
Okay, can.
Yeah, I try one of the videos and see if it's working correctly. Did you see the video?
Yes, I do.
Okay, great.
So wait a moment. Does the video have sound?
Sorry?
Does the video come with sound, with audio?
No audio.
Okay.
Audio will be my talking.
Okay, good. So then thanks.
Okay, everything is set. What, because the screen is limited, I can't see on webcam. So if the talk starts, then maybe you can cue me.
Okay.
Translate, you actually can turn off the cam yourself. So if you click on the cam icon, and then you will be up later on when you start to show the video. So just like me, so I can on and off my cam anytime.
What you are saying that I can turn it off? No?
Yeah, not now,
because,
but after, like in a bit, if whenever you want to turn off your cam, you can, and then you can turn on again when you want. So the presenter has all the right. You can share the video, you can on and off your cam, you can mute all the users, everything
okay,
you can do.
Okay, no, I'm because the screen, I'm using a tiny laptop. Using a two Windows, one for the speaker notes, the others for the slides, so I don't have to show the cam. I think it's okay. I just leave it open.
Mr. Zheng, may I remind you, your session is 25 minutes, and which will include your presentation and as well as the Q&A segment. So
Okay.
it's from 5 to 5:25 for you to take note.
Okay.
So for those who are here, we are going to start in 4 minutes. So thank you for joining this session on the FreeCAD of steroids. So continue to hang around until the session starts in 4 minutes time.
Okay, thank you.
So later on, Mr. Zheng, I'll be introducing more about you first, then you can start your presentation.
Okay. So during the presentation, so I can turn off the camera, right?
Yeah, you can.
Is it recommend to leave it on? I'm asking because it seems that my laptop is having hard time to process all this. I'm worrying about whether it will hang or what.
Oh, I think if your laptop lags quite a lot, then you can turn it off lah. But then otherwise, if not, you can leave it on.
Okay, I'll leave it on.
Okay, so I think we can actually start early since I think most people are here already. So hello everyone, I'm Ming Tia, who is the moderator for this session. For joining us. Before we start, I would like to remind all of you to remember to turn off your mics. And if you have any questions in between, you can hop on to the chat notes to type your questions in for Mr. Zheng. So today, Mr. Zheng here, he is known as Real Thunder and is a professional computer software and hardware engineer. He has over 20 years of experience in developing software in various fields, ranging from FPGA programming, embedded system firmware, kernel drivers, and all the way up to writing server programs running on high-end multi-core machines. He's currently working as an embedded system design consultant for his own private company. He's also the founder of FreeCAD, which is an open source parametric CAD software. He has made numerous improvements for FreeCAD, which includes core functionalities, UI, drawing, and modeling. Apart from coding, he also has other hobbies like cooking, studying, playing the piano, and practicing wushu. So now for this session, he'll be sharing with us more about the FreeCAD on steroids. Now let's welcome Mr. Zheng Lei. Mr. Zheng, over to you.
Hello everyone. Today I'm going to talk about FreeCAD. This talk is mostly geared towards potential users that have never used FreeCAD before, but there are also teasers for exciting new features in future release of FreeCAD to entertain the existing user. And this is what the on steroids part referred to in the title. I'll first briefly introduce the history of FreeCAD development. Then I'll give a touring guide for the current version of FreeCAD, which is just released weeks ago, by the way. Finally, I'll present some exciting new features that are expected in future release. My name is Zhen Lei, also known as Real Thunder. I'm one of the FreeCAD core developers. Before everything else, what is FreeCAD? FreeCAD is an open source, general purpose parametric 3D CAD modeling software. It is licensed under LGPL, runs on all 3 major PC platforms. To all the fellow mechanical engineers out there, FreeCAD is similar to commercial CAD software like CATIA or SolidWorks. FreeCAD is created by Jeroen Vigel around 2001. Initially as a private project, the project is made public and open source in the next year. Unfortunately, his last work on FreeCAD for the assembly module was left unfinished in 2015. I've never worked with him, but I say that he is a brilliant software engineer. Judging from his coding and overall design, he existed as documents left on FreeCAD Wiki. The second core developer from the beginning is Werner Meyer. He joined the Jeroen as soon as the project went public. He is, to this day, still the most active developer of FreeCAD. I'm quite amazed as to how he is able to not only maintain but actively develop on such a huge code base in his spare time with a full-time job. The third core developer, Ulrich van Abel, joined around 2008. He is a professional architect. He is the de facto art director, setting the visual style of FreeCAD. He also has exceptional programming skill for an architect. He's the author of the wonderful draft and arc module in FreeCAD, which I will be showing you later with an amazing demo. More and more people join later. As of now, there are more than 300 contributors for the FreeCAD code base. Visit the link here if you want to know more about FreeCAD history. I made my first contribution in early 2017. I was a normal FreeCAD user before that. As a habit of a professional software programmer, I started to fix things and add functionality that I wanted. I consider myself as an adventurer who always eager to try out new ideas. My current passion is to bring FreeCAD to the next level, at a level that can compete with some of the commercial CAD software out there. One thing special about my development, though, is that because of the fast pace of adding new features, the upstream has a hard time swallowing. Therefore, most of the new features I develop still only exist in my own branch, which I made release regularly for the public to try. This year is when the exciting merge is expected to happen, and we'll hopefully soon see some of the next level stuff I mentioned here in the upstream. FreeCAD makes heavy use of various open source libraries. It uses Qt for GUI, Point3D, a clone of Open Inventor for 3D rendering, Open Cascade for its CAD kernel, and many others. Unlike other CAD software, FreeCAD uses one file type to contain all types of objects, and it is possible to create links to reference objects in other files for both data and visual. FreeCAD has a modular system design utilizing Python, which makes it possible to be loaded as loadable library by other software. Almost all functionality of FreeCAD are exposed to Python. And this is the reason for rich external add-ons that are created by other developers or even power users. Each module exposes its functionality to the end user in the form of Workbench. Here, you can see how the user can switch between different workbenches when working in different domains. Next, we'll briefly introduce some built-in workbenches of FreeCAD. The part workbench can be considered as the core component for CAD modeling. Most other models depend on the part module. It serves as a middle layer to provide CAD kernel functionality to other modules. The main modeling paradigm of the part workbench is the constructive solid geometry workflow, where complex shapes are formed by Boolean operations on other simpler primitives. That being said, part workbench also supports using sketches and extrusions. Here's a short demo creating a fusion, i.e., an union of a cube and a cylinder. And then cut the fusion with a sphere. And finally create two edges to fillet. As the nature of parametric modeling, you can easily go back and change one of the model parameters. And finally, we'll create a mirror of the shape. Next is the Sketcher workbench. It is another very important workbench that are depended upon by many others. The Sketcher workbench offers constraint-based 2D geometry sketching. Here's a short demo of creating a sketch using the polyline tool for fast creating lines and arcs. We add a dimension constraint to one of the edge and then fix the other edge by the equal constraint. Finally, we add a circle with a radius constraint. You'll notice that once the constraint is fully constrained, it will turn green. After that, we can extrude the sketch in the part workbench to create a solid. The part design workbench offers a modern workflow for creating solid with the concept called body. This is similar to what is offering in most mainstream commercial CAD software. Here's a brief demo of the workflow. After creating the body, we fast forward to create a similar sketch. After done, we extrude using the pad feature, and then continue to the next step of the modeling by creating a second sketch on the padded face. Here, we also demo how to use the external geometry, the magenta colored edge for positioning and continue modeling. We then use the pocket feature to create the hole. And finally, create the fillets for the edges. These are the basic steps we use to build up the model history and create complex shapes. You can easily go back and forth of the history by toggling their visibilities. Next is the TechDraw workbench for creating technical drawings for 3D models. It has all the usual tools you can think of for creating drawings like dimensions, section view, hatched areas, annotation, and so on. You can export your drawings to various output formats. Now we create a simple drawing for the model we just made in the part design. The workflow is pretty intuitive. You can change different dimension style to suit your needs. It is also straightforward to create a section view and add dimension on that. Finally, we finish with a customized isometric view. The FEM Workbench offers a unified GUI interface for using various open source tools to perform finite element analysis. It supports NetGen or Gmesh for generating meshes for solid model and using Calculix, D88, Elma, and so on as solvers. Because of the time limit, I'm going to skip this demo. For those who are interested, please check out the video in the slide. The Path Workbench is the FreeCAD CAM module that generates G-code for various CNC operations. It also has an amazing simulator to see the motion before actual machining. The Path Workbench is mostly written in Python, but with performance-critical part with C++ or utilizing other open source libraries such as OpenCamLib, Clipper, and LibArea. I was involved in its development when I first started contributing to FreeCAD, but changed my area later on. The Path module has since developed into such a wonderful, feature-rich workbench. To make the simulation a bit more interesting, we create a thick shell based on the model we created in part design. Here we show how easy it is to create the two parts to machine this piece. Simply select the face, click the button, choose the pattern. We use the zigzag offset pattern for combining pocketing and interface profiling operation. Now firing up the simulation. Isn't it joyful to watch? I find it very satisfying. The spreadsheet workbench brings the meaning of parametric modeling to another level. It allows users to easily create new parameters, calculate them using various expressions, and reference them inside the model. Again, because of the time limit, I'm going to skip this demo again. The Draft Workbench is the first workbench in FreeCAD that is purely written in Python by Ulrich. One of the early core members of the development team, is used to create simple 2D drawings without using constraints. One of the biggest users of Draft is the Arc Workbench, also created by Ulrich, for providing the building information management workflow, because, well, Ulrich is an architect. I'm not going to show a demo of how to use the Workbench, because first, I'm not an architect. Second, you can't really show the power of these workbenches by a quick usage tool. Well, that applies to all the other workbenches I've shown here as well, but especially so for the Arc Workbench. For those who are interested, you can visit the website called osarc.org. It is a site promoting doing architect engineering using various open source tools. And there are a few pages about FreeCAD. Here are a few models that recreate some of the famous buildings around the world. This is the Carpenter Center for the Visual Arts, located inside Harvard University. You can find more information about these buildings in the link before, and you can download the full model files too. This is the famous Farnsworth House, the Quinta Monroy housing, the Villa Savoy. Sorry. Let's have a tour of this villa. It is running inside FreeCAD, by the way. Not using the current FreeCAD release, but still doable with a few scripts. The video quality is a bit rough, but the actual rendering is quite smooth. There is no official assembly workbench in FreeCAD yet, but there are a few popular ones exist as external add-on workbenches. They're all unique in their own ways. We can assume that the future official assembly workbench of FreeCAD will be a synergy of the three, inheriting their strengths in different aspects. I'm the author of Assembly 3, by the way. Speaking of external add-ons, this is another distinct feature of FreeCAD, showcasing its great extensibility. I'm showing only a tiny fraction as example here. We have the KeyCAD step up that can import PCB files from KeyCAD. You can place your board and design an enclosure around it using FreeCAD. You can even modify the board shape and component placement and export back to KeyCAD files. You can also build solid models for the tracks and zooms and doing finite element analysis on it. And then there is the sheet metal workbench, allows you to create various types of bands and later on unfold it for cutting. The new MB Diem FreeCAD workbench is currently in development. It is an front-end interface to MB Diem and a multi-physics simulation engine. Look at the simulation result. It is wheel running, dynamics of the wheel running on a computer. I know some audience of this talk are existing FreeCAD users. Hope I didn't bore you with all those oversimplified tools. Let's talk about the future. This is not a roadmap. These are the features that's already being done in my branch of FreeCAD, and most of which are expected to be merged into upstream FreeCAD in the next release or two. Saving all the tedious words, let's first have a tour around the new UI. You can actually have a similar overlay UI with current FreeCAD release using external add-ons. But here, I'm showing that the future FreeCAD will have them built in and with more capabilities. Also notice that the X-ray type of rendering when you select objects, there are big improvements in 3D selection. And of course, the coolest part, visual view. You can expect to have more visual effects. Comparing to everything else, the greatest enhancement that is going to be merged, the solution to the infamous topological naming problem. For those who have never used FreeCAD and are likely spoiled by what nowadays commercial CAD can offer, here's a very brief demo of the problem. Traditionally, FreeCAD uses integer index to name the geometry elements, edge 1, face 2, etc. When the user creates fillet like this, what FreeCAD remembers is the fillet to be performed on edge 3 of the fusion object. But when user modifies the model, like moving the cylinder a bit higher, there is now an extra edge in the fusion. The index got messed up, and the edge 3 now referencing some related edges shown here. This is a fundamental problem that's been troubling FreeCAD users for decades, and apparently it is a difficult problem to solve. The FreeCAD link branch implements a general solution to this problem by internally name each geometry element using their history. In other words, it names that edge through something like an edge originally coming from cube edge 2 and cut by cylinder face 1. So now when you use the cylinder, there is still an edge that fits the description. Well, actually, there may be more than one edge that fits the description. It is a design choice to whether choose or more. Because the user won't face disaster
to show you. Yes, so I actually want to tell the audience about the self-service option from show you. Yes. Yeah, so here you can see if there isn't a video playing on the screen and you see that it's stopped or if frozen, you have the option to play the video for yourself. And you can also control if you want to see this slide in the middle or you only want to see the speaker's face. There is a minus icon on the right hand side of the slide. It shows hide presentation. If you click there, you will only see me on the screen. Yeah, share notes again for Q&A. Yeah. For instance, if you like any of the demo, you can take the screenshot. Please feel free to do so. So I did it with the FreeCAD presentation. If anything that you like on the screen that the speaker share, you can snap some photos and share on social media. That would be great to share information about the event to other people. The event will run the entire week. And yes, so I hope that Raphael will be back soon. Okay, so I think we will take a quick break. We'll be back shortly. So I'm trying out the polling feature of Big Blue button. Do you see my questions? So I have actually not a question, I have two statements sharing with you. I would like to see where we are. Still processing the polling. I see. Okay, I have published the result. Did you see it? Raphael is also here. It should be at the corner right, right corner.
How to join the virtual exhibition of an event, on Eventier. For example, click on the FOSSASIA virtual booth, it will direct you to the FOSSASIA exhibitor page. Here you can see the description, their social media channels and contact form. You can also view all related sessions of the exhibitor. Scroll down a bit further, you see their tweet updates, a featured video that can be played directly. And also a slide deck with more information. Now go back to the top where you find a button to join exhibitor video room. Click on that button to enter a Jitsi room where you can video chat with the exhibitors. Due to different time zones, some exhibitors have indicated their office hours in the description when they will be around to answer your questions. On the side panel you can navigate back to the schedule, exhibition page, or the main video conference room. There is also a new feature that allows you to view one exhibitor after another by clicking the previous or next button like this. Now, have fun exploring the virtual exhibition. Thank you for watching. Please subscribe for more videos and tutorials.
How to update your profile name, select the Account option. Here you can update your name, email or upload a picture. Your profile is private by default. To have your name and picture visible to other event attendees, you need to make your profile public. Here you can see the difference between a private and public profile when you join a session. How to view event schedule and program details on Eventier. From the sidebar, select Schedule. There are various filters that help you explore the schedule, such as date, time zone, popularity, track names, room locations, and session types. Choose your time zone.
So sit back and enjoy. If you look at the side panel on your left, under Video Rooms, you can see that we are now in the Welcome Room. I'm here on the screen the entire time throughout the event. Feel free to drop by if you want to see me or watch this video again. Below the Welcome Room is a list of all conference video rooms. Most sessions will take place in the main hall. Some workshops will be held in the workshops room. Discussion is of course for discussion, continued conversations with speakers and other participants. Support rooms is for technical support and testing. Livestream is our YouTube channel. In case the room is full, you can just follow the event from YouTube and check back in a few minutes later. In the Lifelong Learning Institute room, there are workshops conducted by computer science students in Singapore. They are giving the workshops from a physical room at the Lifelong Learning Institute. Above the video rooms, there is a chat channel where you can chat with other participants or speakers. So this side panel is actually everything you need. From here, you can go to other pages like schedule, exhibition, or the speaker page. Now let's take a quick look at some basic viewer features to make you feel a bit more comfortable with the system.
Use public chat to communicate with other participants. Please be nice and respect one another. All advertisements and spam messages will be removed. Moderators have the right to remove bad actors at any time to keep a friendly environment for everyone. Please use shared notes to ask questions to the speakers. Moderators will take questions from the shared notes, not the public chat. You can set a status for yourself like raising hand, happy, or applaud, etc. by clicking on your name. Click on the small person icon on the top to hide the public chat and the sidebar. Click Minimize to hide the presentation. This is especially useful when you only want to see the speakers, for instance, in a panel discussion. At the bottom right corner, there is a Maximize option to make presentation full screen. Next, let's learn how to update your profile and change your public name. Under your profile name, select the Account option. Here you can update your name, email, or upload a picture. Your profile is private by default. To have your name and picture visible to other event attendees, you need to make your profile public. Here you can see the difference between a private and public profile when you join a session.
So, okay, great. Hong, if you are here, please turn on your camera. And Raphael, we still cannot hear you. I just want to give Raphael a signal that we need to move on. Okay, so I would like to invite Hong. Are you ready? Please turn on your camera. I also see Minh Chia here. Hi, Hong. Yeah, good to see you. Yes, so Hong and we both come from Vietnam, so I just want to step in to say hello with him a bit. Yeah, where are you based, Hong? Are you in Vietnam or where are you at the moment?
I'm in the Bay Area, San Francisco right now. It's like 3:25 in the morning, so it's very early in the morning and it's very quiet. So enjoying it right now.
Appreciate that you got up so early to give the talk. Thank you very much. And I will now hand over to Minh Chia. She will be the moderator for the session today. And I got a message from Mario that your sound is a bit low. Are you very near the laptop? You want to try again?
All right. One second, please. I'm gonna mute myself. I have to move my microphone.
Okay. Good.
Hi Juan, maybe in the meantime, I would like to remind you that your session is 25 minutes and which will include your presentation and the Q&A segments. So would you like to test your slides before the session starts?
Yeah, can I have the presentation rights, please? Can everyone hear me more clearly now?
Yes, I think we can all hear you more clearly than before. That's great.
All right.
So audiences, thank you for joining this session on building an open source webcam with a Raspberry Pi for work, play, and education. So continue on and I'll start in about 3 minutes time.
All right, let's see if the presentation can be uploaded. Oh, here we go. Everyone see my presentation?
Yep, I can see it.
All right, let's wait for 3 minutes then.
Yep. So I will introduce you first, then you can go on with your speech later. And audience, reminder again, if you do have any questions, please type to the shared notes. So the Q&A session can go on later.
I kind of have a microphone right here, so I'm constrained by the microphone, I guess.
Okay, so I think we can start now. Hello everyone, I'm Mingjia, the moderator for this session. Thank you for joining us. Before we start, I would like to give a gentle reminder to mute your mics. And if any of you have any questions throughout the session, please type them in the chat notes. So now we have a very special guest with us today, Mr. Huan Truong. He graduated from Truman State University with a bachelor's degree in computer science in 2011, and he also graduated from the University of Missouri with a doctorate degree in bioinformatics in 2018. Since college, he started to develop a special interest in novel computer architectures, and he hopes that science and technology can reach out to underprivileged people and change lives around the world positively. He has written software and firmware for different devices, including the Texas Instrument Chronos Watch, the Chumby, embedded routers, NVIDIA graphics card, and the Raspberry Pi. So without further ado, he will be sharing with us more about building an open source webcam with a Raspberry Pi for work, play, and education. Welcome, Huan Truong. Mr. Huan, over to you.
All right. All right. Can everyone hear me? All right. So I'm Huan. Today I'm gonna talk about building an open source webcam with a Raspberry Pi. And without further ado, let's get started. Slide 2. All right. So in this talk, I'm mainly gonna talk about what I'm doing, why I'm doing it, and how can we all achieve some results with it. And thank you to all the contributors that I have seamlessly all the pictures here. Thank you. So I'm gonna talk quickly about what I'm doing. I'm building a firmware that transforms your Raspberry Pi Zero or soon to be 4 to a very powerful webcam. What I mean by this is it actually comes with a quite high quality sensor, and you can use a lot of lenses with it, just like you can use with a professional camera. It runs open source software in it, and with a lot of control and fine tuning that you can do. I will explain more later. And it doesn't only stop just at the webcam. You can make it a document camera, a microscope, or a telescope. So why I'm doing it? The reason is there's a pandemic going on, so I work a lot from home. So I have to do a lot of Zooms, and I have lots of free time on my hands. So could as well put it to good use. Sometimes I do host live YouTube meetings, and I kind of research it myself, what kind of like streaming equipment that I should use. So it turns out each kind of streaming solution kind of suck in a different way. We have laptop webcams which are very readily available, but they, you know, have horrible quality, 720p, and it's been that way since like 8 years ago, right? You can buy a very high-end MacBook for $2,000. The camera quality still is potato. So some people have come to different solutions. They use phone cameras as a webcam. It's nice. However, you often have to connect the camera to the computer through a network. So you have to run the software on the camera, on the phone, and you have to run a piece of another software on the host OS. And so with that combination of phone operating system and host OS, you have a lot of architecture to support, and cross OS and cross hardware support is horrible, and they are non plug and play. You are like kind of like depend on the developer to kind of find a solution for you, and no one cares about Linux, right? Some people have pro cameras, so they are very high quality. They often use a DSLR or mirrorless camera to kind of use as a glorified webcam. So they are expensive, bulky, and cumbersome to set up. But that's very nice if you can afford it. USB camera are nice, but they are in short supply, and the quality varies, and the OS support. You often, if you want to fine tune that webcam, you have to use a vendor kind of software in order to tune the webcam. So again, no one really writes software for Linux to tune your webcam camera. So why don't we fix it to a Raspberry Pi, right? It's cheap. It's you can have good quality sensors. You can have good customization. It's light. You can carry it everywhere, and it may have cross-platform support, hopefully, with the right solution. So let's see. Some people may ask, you know, Juan, you are just like writing another kind of solution for Raspberry Pi. And I kind of see that, you know, like in grad school, I used to work on the NVIDIA GPU, and they changed from being a graphic card to a GPU, that's general purpose GPU. I kind of tend to think the same way about the Raspberry Pi as a GP gadget, that is general purpose gadget, because it's so ubiquitous and cheap, got a lot of interfacing IOs, you know, and it's very easy to get anyone started. However, Raspberry Pi projects are kind of like have some gotchas if you think about it. If you want to use it as a dedicated device, you rather not think about it as a Linux computer that can run anything you want. You may want a dedicated firmware for it to do just one purpose and do one purpose well. It's a gadget that happens to run Linux instead of a Linux computer that happens to be a gadget, and that's very important, as I will explain later on. And so how to get started with this? Basically, you only need to start with a sensor. That's a Raspberry Pi camera, and you put it into a Raspberry Pi with a nice case, and just write the Xiaomi webcam firmware on the SD card, and you have a USB webcam. Simple as that. End of story. But the fun really begins when you use the high quality sensor on the right here that the Raspberry Pi Foundation provide with their on their store, and then you can play with it. Now, what I mean by that is that you can put a lot of lenses on it. So here, as you can see, on the left are like some of the lenses that you can use. And with them, you can have vastly different quality and field of view, as you can see on the right. And you can adapt to different purposes. For example, if you want to open your yoga class at home, right, you would want a lens that can give you a full view of the room. Or if you want to do just a talk like me, you might want a closer zoom camera. So that all is possible with the high quality sensor and the lenses that come with it, and you can buy from third party. So what else can you do with it? For education, of course. So here is a picture from Dr. Don Biner from my old college, and he is concocting like a custom setup over here on the left that he used to teach math. And as you can see, it requires a very special setup where you need a fixed focus, because you don't want your webcam to kind of hunt for your guess the focus and zoom on your hands when you are presenting it. You want a very fixed setup that have a crop of just your piece of paper to teach math. So here, as you can see, one of the requirements is that distortion has to be minimal, and we have a lens for that. So that's very nice for teaching in a pandemic. And so what else? You can use it for discovery and sharing as well. As you can see here on the left, they have a Raspberry Pi Zero mounted on top of a microscope. And on the right, you can see a cell that is magnified by the microscope. And what is special about this setup is that it requires a very special kind of tuning to the image. For example, with this microscope setup, you have to rotate the image, and that is done through an interface that we provide for the camera through a serial interface. Just anything that can talk serial can talk to the camera and configure it, and you can see the result on the fly. So, and once you save it, it's saved for everything. So you bring that microscope setup to another computer, it will work as expected. So not only discovery and sharing of science, you can do it for fun as well. Here you can see a lot of 3D cases printed for it. You can use as vanilla of a setup as a normal webcam on the top middle here, or you can make it as fancy as you like. And an user of the software also sent me a picture of him making a case for the camera that looks like an octopus. And the cool thing is the the lights will turn on, and the octopus eyes will show up when it's in use. And so why is it all important? I think it's important for a couple of reasons. You need one firmware for all needs. It works on all OS. It saves its setting on the device. And you don't need a proprietary app that runs on the host OS, which often to be Windows and Mac OS for it to run. Anything talk serial can configure it. And one standardized hardware to rule all needs, it can adapt it to whatever application you want. You can reuse it. Use it for your yoga class, use it for your science class. That's especially, I think, important for developing countries where teachers don't have a lot of resource to spare. It saves money, cost, and training. hardware is cheap and readily available almost anywhere in the world for the Raspberry Pi. So I think that cannot be said for many other software and hardware solution. And you can say, oh yeah, the US, bring it to Asia and it will work the same, right? That's really, really nice property of the Raspberry Pi. For developers, I think there's not much to be said, but to make it happen, there's a USB on the Pi that's unique in red over here. That's called the OTG port. It can be configured either as a host or a device. When it configured as a device, it can act as a USB gadget, and you configure that gadget to a system called config.fs on Linux. It has a C-based core that streams the image from the real camera to the virtual camera. That program is called UVC Gadget, and that's maintained by Peter, who is joining with us today. Thank you, Peter. And we put it all together by a distro based on that's our Xiaomi webcam code. It's only 300 lines of code for the whole repo that we maintain. You take a couple of hours to understand. Boots really fast, 5 seconds. The image is really tiny, 64 megabytes will fit everything. The root FS is read only, so you can disconnect the power to it anytime and it will not corrupt. The serial interface that gives you root and you can change anything. By the way, if you want to learn how to make your own build-root-based firmware that does one thing and one thing only, Xiaomi webcam is a great place to start. So what I learned from this project is it's a project that I do for fun, and I learned that you can have a day job and a hobby. You just have to learn to limit yourself in terms of scope, what you want to do with a hobby. And that didn't work well for me in the last project because I tried to kind of like make an infotainment for the car, and it's like turns out to be too much of too broad of a scope for me to do. And even though people are interested in it, I don't have time to maintain it. The part that I still have to be hands-on is to encourage and review people's contribution to the project. The part that I'm hands-off is the trust and ask for help from great people in the community to help maintaining the project and different parts of it. So how to handle open source firmware project? It has to, I think, it has to scratch a popular itch for a lot of people. It has to have a standard and easy to obtain hardware that everyone can get. It has to be easy for people to understand it, easy to validate, build, and test any build. In fact, you can build the Xiaomi webcam firmware without just actually having a build computer. It will build on GitHub CI. So any commit must work and must pass certain quality test. And in fact, you can download any commit on the GitHub repository of Xiaomi webcam, and it will likely work, right? So the things I have a lot of things that I will I hope get improved over time, and a lot of plan for the future. For example, I really want the camera to just zoom on my face at the same time. If I'm like kind of tilted on the frame, right? But that's for the future. So anyway, that's it. If you want to learn more about the project, just check out the GitHub repository and showmewebcam.org. Sometimes I blog at my blog as well. So that's the place that you can learn about it. So I will turn to the questions to answer, and I will demo a little bit in the meantime, right? So let me try to share a screen, and oh, I cannot share my screen. Oh, here. Let's see. A lot of things will go wrong. Just be ready for it. All right. If you, in the meantime, I'm happy to answer the question from the audience. So here, let's see. I can get to the camera interface from here. So I'm on root over here, and let's see here. I'll have to put the presentation on the other window and camera control, right? And you see my face on the presentation. I'll do a flip. I can change my contrast and saturation. That's standard stuff. But look what happened. Now I'm inverted. So that's the kind of customization that I can do. So from now, I'm just gonna be rotated here, and I can play with this all day long. That's it. That's it for me.
Thank you so much, Mr. Huan, for your insightful presentation. Currently, there aren't any questions, but if any audience would like to voice out their questions, they can do so now. Now you can unmute yourself.
Yes, I want. Could you show that changing again? I want to take a screenshot. I was not fast enough.
Right.
Could you do it again, please?
All right. Let me try. All right. 1 second. Let me share my screen. Do you see my camera screen now?
Yes. Yes.
All right. Let me make myself emboss it, and
then also move around yourself. Yes, this one. So keep it like this. Yeah, awesome. Really cool. I would. Is it easy to install?
It's very easy to install. It's just you just need the sensor and then download the image and flash it as if you do with Raspbian.
Yes. Okay. So I will follow what's written on GitHub and see if I'm able to get it running, because normally every developer said, okay, very easy, just by like one line of code, but it always, different machine, different setting. Let me try it out.
That's the part that I try to solve, because you see the problem with treating the Raspberry Pi as a Raspbian computer is that whenever you have a Raspbian change, right, your script that runs on Raspbian doesn't work anymore and it breaks, and this firmware doesn't have that problem. So it's a firmware, once it works. And most of the people I talk to, they have no problem with this running. In fact, it's already running with on quite a bit of people's computer.
Yeah. So later today, we actually have someone from the Raspberry Pi group in Japan coming to give an update on the development of Raspberry Pi. I see there's another question. So okay, and also change the color. Mincha, do you want to take it?
Sure. Okay, there's a question coming from Kelvin. So actually he has missed the earlier part, and he would like to ask if there's a script running on Python, or is it just a complete image? And do the rest of the Raspbian image works as normal?
No, it's not like a script that runs on Raspbian. That's the beauty of it, because as you can see, if you do it with a Raspbian, then it's gonna take a long time to boot up. And then if you forget to like shut it down properly, then it's gonna corrupt the image, right? That's the kind of issues that we were gonna face if we use it as a kind of a script. Here is a solid image with a root FS that's read only, and it does one job. And the reason for that is you can expect it to work whenever you want it to. It's more involved than just being a one script.
Yeah. Hon, since you are so experienced in firmware development, we actually look into like how you say rewrite the firmware for the Pocket Science Lab. We have a meeting every week. You are more than welcome to join if you want to give us some feedback. I saw that Masafumi is already here. Yeah, so thank you very much. It was a really interesting talk, actually. Yeah, and I said I will send you an invitation in case if you want to check into our like Pocket Science Lab hardware meeting. You are more than welcome to join us. We have a meeting every Saturday. I think Daniel, I don't know, Daniel Orlowski, he's not here yet, but he is currently working on the firmware for the Pocket Science Lab. It would be nice to have an exchange.
Sure. I'm be glad to help.
All right, so I guess we have come to the end of the session. Thank you very much for Mr. Huang for joining us for this session, and thank you all of you for attending this session. So up next, we will have more about Raspberry Pi's latest updates, use cases or trials, and more with the speaker, Mr. Masafumi Ota. Maybe in the meantime, Mr. Masafumi, would you like to enable your camera and your audio, or any slides if you upload any slides if you have? I've made you
hold a moment, and I will use on the recorded video for this session, and just send the link.
Okay.
So I will give all attendees the recorded talk in the 28 minutes. Just after that, I will give some questions to from attendees if you have any questions about that. Okay.
Okay, so your session is at 7. Maybe we can wait for a little while before we start.
Yes.
Meanwhile, the rest of you who are around, thank you so much for joining this session. And yeah, stay on the course.
Mintia, I think that there's some echo like feedback, on your side. Do you have other browser open?
Oh, I think the echo came from Mr. Masafumi.
The audio to prevent the howling tone. And so thank you very much for attending to my session I use it on the recorded video because on the issue in my browser to a live streaming. There is not much to my browser, so I should pre-recorded on my session on 25 minutes videos. After that, I will give some questions from the attendees about many things about Raspberry Pi things.
No problem. It all sounds good. Hi, Masafumi. I just want to say hello.
Say hello, HP.
Yes, it's been a long time.
Yeah, long time no see. And you at the morning for you, and so I can see and sun lighting on the windows.
Yes.
It is a night for me to about 8 p.m. for me.
Yes, I know it's 8 p.m. for you. It's 12 in the morning here. And I just want to say that Mintia will play the video at 12. No, not at 12. So at 7 p.m. Singapore time. And then when she plays the video, please keep yourself muted so we can hear the video. Mintia, I just want to tell you that if you put in the video now, anyone can just hit play. So it's better if we only put the video in when the time has come, in case new participant join us.
Okay.
All right.
Thank you very much. Thank you very much, sorry. And so, after the session, I am planning the online seminar with the Raspberry Pi Foundation and the training and detailed updates and Raspberry Pi things and coming products something and solutions. And I'm planning to understand in summer in the Asian area, and I'm planning in June and in the Chinese areas, and in August in the Taiwanese areas, and for online seminars for that. Okay.
Okay, so now, audience, we are 2 minutes away from the session, so hang on a while. We'll be starting soon. Okay, so hello everyone, I'm Ming Jia, who is the moderator for this session. Thank you so much for joining us. Before we start, I would like to give a gentle reminder to mute your mics. And if any of you have any questions throughout the session, please do type them in the chat notes. So today, our very special guest is Mr. Masafumi Ota, and he has been leading the Raspberry Pi community in Japan and volunteering in the Raspberry Pi Foundation since 2012. On Raspberry Pi's official forum, he's in charge of updating the Japanese language category. Other than that, Mr. Masafumi is also doing IT consulting business worldwide and looking into Asian countries. Audiences, you can also check out more about him on masafumi.me for more information. So for this session, he'll be sharing with us more about the hardware, firmware, and chips about Raspberry Pi. So I will be playing the video he sent us. Audiences, you may watch the video first and do put in any questions you have in the chat notes for Q&A later.
Thanks for watching my
We would move on to Q&A at about 7:30 to 7:35. Mr. Masafumi, they will be able to play the video themselves.
Thanks for watching my session. I will give a talk about latest use case and more. This is me leading Raspberry Pi community in Japan, volunteer since 2012 for a long while, still struggling against COVID-19 things with my business partners and you don't know, I am still support for many more projects for everyone with Raspberry Pi. This is my article on Magpie, official magazine at Raspberry Pi. They kindly take me as a vivid person for Raspberry Pi in the Eastern area. Sorry, and for Raspberry Pi Foundation to give up on this year birthday event because of the COVID-19, and hope to held next year. But we helped on the Pi Day event yesterday. This is a Chinese Pi Day event in Shanghai. I gave this stickers to encourage the event. And happy Pi Days, and thanks and organize the event to Rebecca at Riget Robot. And we will continue to help on many more events and workshops and seminars in Asian areas with Raspberry Pi. And this is agenda today, and latest brief, solution for business, and some information. Latest brief, I will talk on the computer module for Pi 400 and Pi Pico. Since last year, COVID-19 struck me and have spent a difficult time, Raspberry Pi and also has a great effort to meet the demand for you. And Raspberry Pi Picos, Raspberry Pi 400, and Raspberry Pi 4 8GB model computer module for HQ cameras, and the localhost keyboard, and more. By the way, thanks for anyone to help fight COVID-19 project by Barina and Rosetta and with Raspberry Pi. And Raspbian has been changed its name, and Raspberry Pi OS, which has 32 or 64-bit Debian-based OS. Pragos, owner of Raspbian, discussed with an event about its name. Raspbian is a 32 ARM11 based, so Raspberry Pi had to change its OS name. I was interested on the computer module for latest computer module with the latest CPU and more. The factor has been changes with memory write base as computer module 3. It has latest BCM 2711, same as a Raspberry Pi 4 CPU, up to 8GB RAM, eMMC up to 32GB, wireless and gigabit Ethernet port, and overload and extra antenna port. Raspberry Pi has other variations. This is an eMMC model, which combines with some other boot to use on disk and more. This is a wireless type for the factory use to profit Wi-Fi. This is a new I/O card, not compatible with the old I/O card for the computer module 3, and it has many more I/O ports than old one, and real-time o'clock PCI Express as requested. Only regret is they had to use USB 2.0 because of the computer module 4 system resources. You could see this. We used to this folder VL805 chips to use the PCI Express for Raspberry Pi 4. But someone and you and has tried that. This is a use case and by Aki, a community member, to try PCI NVMe as a boot disk. He's also tried to gigabit Ethernet and to recompiling the kernel. And also he tried to 10 gigabit Ethernet recompiling the kernel as well. And small displays with computer module core plus I/O board. For more detail, I am sorry, and it is written only for Japanese, though. But I'm happy to you could check on his website and how to do that. And I say sorry to Peng Chen on our Qt Py. He had to change it on the board layout for computer module. He has quick support on the computer module on his Qt Py. I'm sorry to kick backwards to deliberate. I will introduce a high-quality camera for Raspberry Pi. It is really for under COVID-19 environment, so it delivers relay at fast time. It is based on a Sony IMX 477R 12.3 megapixel image sensors and works fine with Raspberry Pi. You can see the high quality lens for DSLR cameras with C and CS mount. Raspberry Pi, Hole, and etc. I would say the Raspberry Pi 4 gigabyte model. It is not only for DIY use, but also in the server use and in the lightweight Kubernetes like K3s, Micro, K8s, and Minikube. And you can use those container solutions, and it is better to use with Ubuntu OS and now supporting the whole this computer module whole. Official cases are good for using on the Raspberry Pi 4 with the official cases. And if you have many more Pis now, you could check the revision on each UPI. Keyboard now localized for many languages to optimize to use Raspberry Pi OS. And now I will introduce Pi Pico and Pi 400. I saw this project in the middle of this year. I remember I was surprised they joined the microcontroller market. Aki has a great effort to try Pi Pico in this Nokia display to export some. Pi Pico and use original socket and the RP2040 and provide the chips Pimoroni, Adafruit, and Arduino. You can try the Pi Pico with many more brand boards to sample MicroPython in the program, and it is better to use and purchase a board from Pimoroni or any other reseller to Python with it. And you should check also on the Raspberry Pi also GitHub to check some MicroPython samples for Pi Pico. And now and Raspberry Pi 400 kit and mainstream product. Even was inspired by Commodore 64 to make this and now localized for the major edges. Also, effects. Solution for business. Now the Raspberry Pi has been increased in the industrial market, embedded systems, and the IoT product. I will introduce the first point for your business with Raspberry Pi trademark guideline. The guideline illustrates how to use a Raspberry Pi icon for your business. You can use a trademark for selling and providing Raspberry Pi itself and its solution. If you could logo on your website, you must put on a Raspberry Pi Ocean link on your website. It is obvious things, but I will say, and you must not use a trademark and Raspberry Pi its name for your company names and logos. You must not use a Raspberry Pi name itself for your website. You must not use a trademark someone is misunderstanding. Raspberry Pi officially related helps and recommends to your product to someone without permission. You must not make some swags and put on a Raspberry Pi trademark and unless accepted. You must not use a trademark and disgrace Raspberry Pi product and services. You must not use a trademark for any fake product. You must not use a trademark to misunderstand Raspberry Pi compatible product. And you know, Raspberry Pi will not allow any other compatible machines except Pi Pico. You must not use a trademark, names, similar thing for your strong business, and someone will misunderstand and a strong relationship with Raspberry Pi. You must not use a trademark, disgrace, and Raspberry Pi activities. You must accompany the description Raspberry Pi is a trademark of the Raspberry Pi Foundation. You must indicate it, Raspberry Pi inside, Raspberry Pi works on your product. And the trademark must appear less prominently than your product name and your brand, your business name. The Raspberry Pi Foundation would appreciate charity donations and reserve the right to charge for royalty or impose the further condition. Here is an example and misuse case. And the product names and use and Raspberry Pi hat and Raspberry Pi names on your product. And that misleads Raspberry Pi officially related and with this company. And I sometimes find this and similar case, and you should stop and use that, and because you have not related Raspberry Pi Foundation trading itself, and using Raspberry Pi as a domain name, fake selling the Raspberry Pi logo, and it violates the trademark policy. This is a gray zone, and Raspberry Pi and and ordinary use, and you using Raspberry Pi names and on a book, magazine, on your presentation docs like me. And for pictogram and manga use on Raspberry Pi, they are not limited such a use case, and they are not care about that. Here is a case at Dr. Stone, a famous Japanese animation. He said, and he tried to purchase Raspberry Pi. Certification is for business. Someone asked me to about that. Raspberry Pi and official certification program and certification hosting is going on, and future run on a UK and education program website and by Raspberry Pi Foundation fully and will not permit any other Raspberry Pi certification business by other companies. Here's a website for the Raspberry Pi certification program on the Futuron website, powered by Raspberry Pi. And it is a branding program for the makers and the partners to providing another logo, and it will make a good collaboration with the Raspberry Pi STEM business. Here is a logo powered by Raspberry Pi. You can stick on it to your product if permitted by Raspberry Pi. Here is a form to use powered by Raspberry Pi logo, and how to submit the application. Submit the application from the official website. Sorry, it takes a file to reply from Raspberry Pi. And so please wait and bring a coffee. And Raspberry Pi will email you and how to use and powered by Raspberry Pi logo if they accepted your application. And send the sample pics and putting a logo on your product and solutions. Here is the use case and powered by Raspberry Pi. And this is the handmade audio case for Raspberry Pi. And it is first user case in Japan. And Pink10, and I mentioned again and again to succeed and use and powered by Raspberry Pi logo for their business. And Qt Py is a great thing, and happy to support and with this logo. Raspberry Pi Integrator Program. It is for the compliance program for enterprise users to use your country legally, especially technical conformity program and each country. Raspberry Pi engineering team now collaborating with the UL UK, and that makes a shorter time to test the compliance. You need to pay the fee to UL directly, not Raspberry Pi. That means Raspberry Pi will help this program and introduce the UL to you, not to confirm the contract. Please care, it may be far more expensive than expected, depends on the region. In Japanese cases, Giteki makes a noise on this program. It may be about 50 million US dollars. This is a website about integrator program, and please check it carefully to use that. Raspberry Pi approved designers partner program, and it is a new program as a business solutions. Approved designer help your business to design stuff for Raspberry Pi. For example, if you make build Raspberry Pi compute module for IO customized board, and you can ask and approve design partners. And if you want is a Raspberry Pi equipment board for your IoT system, you can also ask approve designer to help your business to design stuff and integrate it to your business. And now Raspberry Pi and calling for approved designer partner. If you're interested applying to become approved design partner, please check the submit application form and their website. They are still an Asian partner though, so I'm happy to submit and Asian partners and submit this program. This is a website approved design partners. You can see the famous vendors like SparkFun and Abnet and Raspberry Pi approved design partners. Use case and business solution. I just talked about that. Japanese IoT companies would love to use a powerful Raspberry Pi and Raspberry Pi integrated program to their solution for their B2B enterprise business. It is fine to get powered by Raspberry Pi from the Raspberry Pi trainings. The logo must be put on the solutions, not only for their solution, but also their website. The cost for innovator program is really expensive than expected. And I discussed the UL, but architect cost really high for them. Peng Chen and the project lead for the QT Pi project asked me to get powered by Raspberry Pi before Kickstarter to succeed. And it takes also 5 to get certificated. So I negotiate for him internally. Fortunately, Peng succeeded in the funding. I'm happy to. And some information. I'm calling for the use case. I would love to introduce a cool use case with the Raspberry Pi all over the world. Magpie, in the official Raspberry Pi magazine, and it's a good way to do that. Please let me know your cool case. I will discuss it on the editors and Magpie. And they are looking for the cool use case in all over the world, not only UK. And here's an example. And by Kishima, and one of the cool use case for Raspberry Pi, measuring the temperature and the humidity with sensors to control and agricultural chemical use for his wine. And more, I mention again and again to Peng Chen or QT Pi in one of the cool use case, and I introduced to a Magpie. And it is a great project to Raspberry Pi compute module for his tablet. And calling for the volunteers. Raspberry Pi Foundation is calling for translation volunteer to translate project. Raspberry Pi Origin discuss now second management level, and there and many more translators, but they need more and more translators to translate many more contents and updated continuously to and many more languages. If you are interested, please check on their website. This is a website on the Raspberry Pi translation community, and you can see the how to join communities. And please check on the website project Raspberry Pi ORG. There are much more content, not only on the Scratch project, but also Python or the JavaScript project. Much more content for the kids. So you should check how to do that. And if interested, please join the translation community, translation your language, and for their content and more. Raspberry Pi and the online seminar on the 21, I will now talking more information and need more and have more time to talk more detail, but now not more time at this moment. I am planning to the Raspberry Pi online seminar in June in the Chinese mainland areas, and August and coming to COSCAP in Taiwan. Please stay tuned on my tweet on the Masafumi Ota, and if you volunteering for my online seminar project, please DM to me and to my tweet or the email to me and if you join my online seminar project. And please ask me using Raspberry Pi for your business, starting a Raspberry Pi startups and starting a use case from the whole world. These are the Raspberry Pi for your business and etc. I will provide many more information, not more like technical things, but also business things. Feel free ping me, Masami Ota, the Raspberry Pi World. Thanks for listening. And many more. And if you have more questions, I much appreciate it. Thank you.
Hello, thank you very much, Mr. Masafumi, for your pre-recorded video. Now, maybe audiences, you would like to type in your questions for Mr. Masafumi.
If you have any question, please on the posted chat feed or talk to me. And so I am planning to online seminars not only in Japan areas. Japan areas will be held in May, but I will also hold the Asian area in June or August for Asian areas. And so I already talked to event and the keynote speaker for that. He will give I'm sure he will give a good talk for you too.
Okay, I think now we have quite some questions coming in. The first one is what is the plan for Raspberry Pi with smaller Raspberry Pi versions like Pico? The person who asked it is not known, but maybe would you like to answer this question?
Okay, so and now as the Raspberry Pi and the Pico is the release is not so much on the time to after release so sorry so I'm I don't have any detailed information about the Raspberry Pi Pico things, and because of the, their main product is the Raspberry Pi Linux-based board, but they are planning to give you more content and to learn to MicroPython things or something, and I'm sure that they will be they will update the Pi Pico and as a mainstream product to mainly to the education and the consumer. So please stay tuned and the Raspberry Pi Pico information and be the GitHub and Raspberry Pi feed and the project Raspberry Pi org to hold the contents for the Raspberry Pi Picos. Is it enough for that?
I guess so. So now we can move on to the next question. So there's a question asked by, and he's not known, but he was asking if
diagram here, in ArduTouch, the digital to analog converter is pulse width modulation. So we have the values in memory that represent the waveform in digital form. We send it through a DDA converter, which in our case is PWM, feed that resulting signal into an amplifier and speaker, and we can get amazing sound. And I happen to have, well, let me talk about this first, and then I'll show you what it actually looks like and sounds like on my ArduTouch. So ArduTouch has a bunch of stuff, a lot of this stuff. I've been working on it for over 5 years, like I said. So there's a lot of code that makes all of this work. With ArduTouch, I've got oscillators, which create those basic waveforms. And then I've got dynamics in order to muck with those waveforms in interesting ways so that we can get some really cool sounds, music, and of course noise. Oscillators, like I said before, even though this is digital, we can get those same waveforms, sine, square, triangle, and many, many other waveforms as basic sounds that we can mix together to get interesting voices, as they're called in music synthesizers. And then once we have those, they're just kind of static. So if we don't vary them over time in some way, they sound kind of boring. So we have various ways of mucking with the sound called dynamics, things that change over time. And I'll go over these quickly. The top one is ADSR, so that's the envelope of the waveform. So if, for instance, if I have a piano with a piano keyboard, this isn't a real piano, this is a MIDI controller for playing synthesizers, but if I press a key on a piano, on a real piano, it doesn't go ah, and then when you let go, it goes off instantly. It's not on instantly and off instantly. When you press a key, it goes through a waveform, an envelope of amplitude, of volume. So when I press this, it gets loud quickly, not instantly, but quickly, and then fades out, and then kind of sustains for a while. And then when you let go of the key, it fades out rather quickly. So it's more like rather than So that's called envelope, and it's attack, decay, sustain, release. And most music synthesizers that are designed for playing music have ADSR. Attack is when you press the key, how fast it gets loud, and then you keep the key pressed, and then it starts decaying on its own. And then as long as you keep the key pressed, the sound kind of stays constant, slowly fading out. And when you release, then it fades out quickly. So that's ADSR, and here's a waveform of that. This is when you press the key, it gets loud quickly, and then gets softer quickly, but stays sustained for a while. And then when you let go of the button, the sound fades out. Tremolo is when you make the volume change quickly. Like if it's just straight, if there's no tremolo, it's if there's tremolo, it's I'm not a great singer, as you can tell, but that gives you an idea. Portamento is when you play two notes, you have a glide in pitch between the two. So not but and then envelope, one form of an envelope is ADSR, like I explained, but you can do some pretty crazy things with envelope and do it really, really quick to mess with the sound in all sorts of crazy ways. And then there's also filters, and there's lots of examples of filters. The ones that most people already know about are bass and treble controls. So with a bass and a treble control, you can increase the low pitches or the high pitches, the high frequencies. But with filters, you can also do some more crazy things or subtle things to make the sounds more interesting. You can also have it vary over time. So to get a phaser kind of effect, you can have where just a band of frequencies are accentuated, and then the band changes over time, and you can get. And then there's all sorts of other kinds of effects for really messing with the sound in not so subtle ways. But you can add like echo, or reverb to have it sound like you're in a huge hall, which makes the sound more expansive, just for examples. There's all sorts of things you can do. So since this code, just to get a feel for how this stuff works, it's not so complicated. Just what I went over is basically, the basics of digital signal processing. But to actually code it takes quite a bit of time. And so the ArduTouch project has an Arduino library, and that library can be used by anyone. It takes care of all of these low-level odds and ends so that anyone can create their own synthesizers just using our library, which is high-level functions. You can just take a few of those functions and string them together, and you get your own synthesizer. And there are many, many examples that come with the library. We also have many, many sketches, which are, in Arduino, they call program sketches rather than programs, which I think is silly, but they designed it for non-geeky artists to not be afraid of it. And since artists, they say sketch rather than program, they call the program sketches. But of course, artists program and programmers do art, so no problem there. But anyways, there are many example sketches that make very, very different sounds from the ArduTouch board. Oh, and by the way, of course, ArduTouch is open source. I didn't mention that. Everything I do is open source. I do all open hardware, and you don't need an ArduTouch board in order to use the ArduTouch library or the ArduTouch synthesizer sketches. They'll work on any Arduino board. It's just my board has the keyboard and all this stuff built in, but you can do that on your own with any Arduino board. And it's all on my GitHub, which I'll have a link shortly. But if you go through the tutorial, go through the first few examples in the Arduino library, that's a great tutorial for how to make sounds with the ArduTouch board, but also just learning how to do digital signal processing. So this is an example of a synthesizer. This is a complete, that's the whole synthesizer right here. And that plays a square wave. You can, and it uses the touch keyboard, and you can change the volume. Yeah, I didn't point that out. The ArduTouch board has a couple of buttons here, and it has a couple of knobs for controlling things. And this synthesizer makes use of all of that. And that's one of the examples that you can learn from in the ArduTouch library. So you can make use of that to make your own synths that do simple things or very, very complicated things and crazy things and noisy things and beautiful things. It's actually really easy to learn. Yep, I already went over that. So once you have the simple synthesizer like on the screen here, I know you can't read that, but it's just a few lines of code. and that's a complete synthesizer with square waves. With that, you can grab functions from the library and add these various dynamics and other stuff. And change screen. Here we go. Of course, it's all open source, like I said, and it's on my GitHub. And my GitHub is Maltman23, maltman23, Mitch Altman 23, because I like the number 23 for some reason. Let's see. So as I go along, please feel free to type questions into the public chat, and I'm looking there to see if you've got any questions as I go along. I'm happy to answer questions as we go along. So that is pretty much what I wanted to talk about how you make sound, music, and noise with microcontrollers, with computers in general. Any questions about that before I get into how to solder? Q. So yeah, normally, of course, I do this workshop in person, and I've got maybe 100 soldering tools all over tables, and I ask people not to bring those home so that other people can use them after the workshop. But I'm going to go through how to solder here, and even though you don't necessarily have something to solder where you are at the moment, what I'm going to go through will show you how you can solder when you do have soldering tools and something cool to solder. I have here a soldering iron, and I've also got some solder on a spool here, and I've got basic tools, really just a wire cutter. And that's really all you need besides a stand for putting the soldering iron on once it's plugged in. This stand is it's hard to get oriented with these cameras when everything's mirror imaged. Let's see. Yeah, you can see this is just made out of a bent wire coat hanger, and that's totally fine for doing this. This soldering iron is €9 at a local store. I live in Berlin. Costs €9. If you want to get it even cheaper and still have good ones, like the one in the picture down below, that is only $3 from AliExpress. And the wire cutter is, I think, about $2 as well. No, about $1. And the solder is a few dollars, and the soldering stand, like I said, you can just use the wire coat hanger. Oh yeah, before I get into that, I wanted to give you a demo of how RG Touch actually works. So let's see, I have my phone here, and over here you can see I have a whole bunch of RG Touch boards, and I feed each one into a mixer here, just a cheap but okay mixer. And then I've got an amplifier here. Let me turn my amplifier on. And then this one right here is, let's see, how can I aim that well? Take off the charger for now. This one here is the one that the RG Touch comes with if you buy the kit. It's called Thick, and it's 4 sawtooth waves. So let me just turn that on. So that's the synthesizer it comes with, and then you can do stuff with the knobs, and you can go up and down octaves with the buttons here. And it has two different kinds of voices. Here's the other voice. This one. And you can do a bunch of cool things with it. There are other synthesizers as well. This one makes drones. And it has presets. You can go up and down octaves. And then this one, let's see, what's another? This one makes arpeggios. If I can get in there. On-off switch is kind of sunken in there. I'm going to turn it on. Sorry about this. Okay, there we go. Let me turn the drone down. And this one up. You can change the attack and decay. And then you can add reverb. And then you can change the rate. Make it go very slow, very fast. And change the pattern. But you can have a mix together. And then I can add some rhythm with this one here, which is a drum machine. And then I can play bass on top of it. And I can add another kind of drone here. And here's one that makes some pretty cool tape loop kind of things called quadrants. Let me turn that one up a bit. And this one, as it goes through the tape loop, you can mess with the sound, so it's way crazy. And this one makes Leslie effects like old Hammond organs. And I can have presets here, like more of a Farfisa organ, which was popular in the 60s and 70s. And this one makes totally crazy noises. Let me turn that one up because this needs loud. Just to give you a little taste that what ArduTouch is capable of doing, these are all the same exact board, just with a different program, a different sketch from Arduino put into it with the free Arduino software, which again works on Windows, Mac OS, or Linux. So I see there's some questions here. Cool. So thanks for the cool comments, Mario. And if anyone has questions as we go along, again, please feel free to type them in the public chat and I'll answer them. So let's learn how to solder. Soldering is way, way fun. All you need is those tools, which I showed you. And come on, advance, there we go. And there's assembly instructions online, which are included here in this workshop, in these workshop slides. And those are free to download from my website, cornfieldelectronics.com. And I wrote, I've taught something like 80,000 or more people how to solder since 2007 at lots and lots of workshops, and conferences and universities and schools and libraries and you name it. So I wrote a comic book with the help of a couple of friends. And it was in English, it's open source, you can download it for free, and since it's open source, people have translated it into lots of different languages. And soldering is easy in all of these languages. So, souder, c'est facile. Soldar ist facile. Looten ist einfach. Das ist wichtig hier in Deutschland. Yeah, so the ArduTouch kit is just one thing that might be cool for you to solder. But if you have an ArduTouch kit, which I'll be using here, where did I put my, here it is. It's a bag with a label and it comes with a board and there's a bunch of parts in it, and all the parts you see in the picture are the parts that it comes with. Those are all the parts you need. And each part gets inserted into the board that it comes with. One part at a time, we'll insert the part. Sometimes you got to bend the wires before you can insert the part. And then you solder all of the parts wires to the board, and these places where you insert the parts, like here's where you put the microcontroller. Actually, we'll put the socket in there, we'll solder the socket in, and then we insert the socket without, the microcontroller without soldering into the socket. Here's for a capacitor, here's some resistors, etc. We'll solder each part's wires to the board, and then that part's done. We might have to cut the wires short after doing that. But yeah, these parts that we solder to, we insert the wires into these areas of the board, and we solder to these same areas. Those are called pads, as in landing pads for parts. And I'll talk more about that in a sec. One slide, advance, there we go. So yeah, we need some good solder when we, if we want to do this well. There's various kinds of solder. I'll mention that more in a bit. What we want to do when we solder is choose our first part. We bend the wires of the part if we need to, and we will with a resistor. And then we insert it where it belongs. In this case, it's R1. R for resistor, it's the first resistor. We put it in the place for R1, and then we solder it in, and we cut the wires short, and then we do the next resistors. And after those, we can do perhaps capacitors. And the order for some kits, order of inserting and soldering matters on some kits. In this kit, it doesn't matter so much. But in general, we want to go from the parts that are lowest lying on the board first, and then get higher and higher and higher parts. So that's the way I'll do it here. And I'm not going to show you every single part on this kit since it would take too long, but I'll show you the things that are things to note while going along with this kit, which are very similar for other kits as well, or just for soldering your own board, own project together for your own enjoyment. because this kid is pretty typical of the kind of things you'll come across. So with electronics, let me go back a few slides here. Here's all the parts. And like I said, the board is where you insert all the parts and solder them one at a time. And you can see these lines on the board. These lines are wires built into the board to connect the parts the way they're supposed to, and of course not the way they're not supposed to. And if you put all the parts in the right place and solder them well, and if you put the parts on the correct side of the board, not the wrong side, and you insert the parts the correct way, because many parts, it matters which way you put them in, then it will work. And if it doesn't work, since it's a kit that's already been debugged before you bought it, it's really easy for you to debug what you may have done wrong. But let me just go over really quickly here these parts, since not everyone knows about electronics. The battery pack provides the power to make the project work. And the battery pack, of course, has batteries in it. In this case, 3 AA batteries. And each AA battery is 1.5 volts. And it says so on the side, 1.5 V. Volts is the amount of push that the power supply that provides the power, that the power supply gives the electrons. And in electronics, named after electrons, that's what it's all about, is pushing electrons around in our circuit. And the circuit is on when you turn this on-off switch on. Is that working? Yeah, there. So this on-off switch, you have to turn it on, and then the power supply is connected to our project and it's pushing electrons around. And kitty cats love this kind of stuff because everything is a cat toy. So yeah, so volts push electrons, and the speed that the electrons flow in our project is called current, measured in amps. And more amps means faster electrons. And some parts, like LEDs, if the electrons are going too fast, too much current, then they can burn out. Or maybe they're too bright for what you want. And to slow them down, we have these parts here, which are resistors, measured in ohms. And the more ohms you have, the more resistance to the flow of the electrons. They slow down the electrons, they reduce the current. These are also resistors, but they're variable resistors. By turning them, they can make their resistance 0 or maximum, 0 to maximum. Resistors have colored bands on them to tell you the value, how many ohms. And resistors, it doesn't matter which way you put them in, they slow down electrons the same either way. LEDs, on the other hand, light emitting diodes, it matters how you put them in. And you can see these have a short wire and a long wire. Here's a long one, and here's a short one. The short one is minus. Diodes, of which this is a kind of diode, a light emitting diode, electrons can only go one way. Current can only go one way through them. So in order to see which way it goes, you have a plus side and a minus side. I'll go over that again as well. These are just push buttons, and push buttons can have a gap, and when you push on the push button, it connects two pieces of metal together to connect the two sides, and then electrons can flow. And when you let go, a spring makes it pop up and they can't flow. So off, on. And these, the black ones here, 4 black ones, and these 4 little yellow ones, these are called capacitors. Capacitors save energy for a little while and let them go in a little while. They're kind of like teeny, teeny little batteries. They charge up and discharge quickly, though, unlike batteries. The little ones, it doesn't matter how you put them in the board, but the big ones, like the LEDs, have a short and a long lead. And the short ones, just like LEDs, are minus. And I'll go over this again because it's important as you're putting it in. And then we got the speaker. This is a socket for the microcontroller. And we could not use a socket. For the microcontroller, we could solder it directly in. But if you make a mistake, it's super difficult to fix it. So with a socket, it's more forgiving. Plus, if you make the microcontroller too hot, it's possible to burn it out. It's difficult, but you can do it. So we have a socket. And then you can, after this is soldered in, then you can just push the microcontroller into the socket. This chip here to the right is a audio amplifier chip. And for that one, I don't use a socket because with audio, it's nicer to have no socket in between to get better sound. With this one, it doesn't matter so much, but there's no socket. And that's really all the parts, and that's what makes the hardware of the R2 Touch synthesizer work. And let's go back to the resistors. Maybe. Yeah, so here's the board, the tools. So there's where R1 goes. Out of all of those resistors, which one is R1? Well, it's to know that you need to you need to have documentation, and these slides here are documentation, or if you know how to read a schematic, that can be documentation. But brown, black, orange is the color bands on a resistor. And the dyes that the manufacturers use on resistors can be not so great. So sometimes orange isn't all that different from red. So you have to be careful when you choose your resistors. But in this kit, there's only one brown, black, orange, and there's 3 brown, black, red. So you should be able to see the difference. So here's my kit. I'm going to open it up. And I've got the board. I'm going to plug in my soldering iron so it'll start heating up. Okay, so you can see here that it's in the stand where it won't melt anything or roll into my lap. Here's the board. Let's see, let's aim that camera a little better. Okay. Here is a bag of parts, including the resistors. Here are the, maybe this is better. Here's the 3 brown, black, red. Does this one work better maybe? It's hard to see with, these cameras don't focus really close very easily. But those are the 3 brown, black, red. And then I've got, I'm just empty these out. Somewhere in here is a brown, black, orange. There it is. Brown, black, orange. And then I've got my speaker. Set that aside. And inside of the battery pack are some more parts. And do it here. So we'll use those later as well. Room in my desktop. Okay, so the brown, black, orange So again, that's going to go right there on the board, and then in my actual board, it's right here. And back to the resistor. Resistors, again, it does not matter which way you put them in, but the colored bands are very important. If you slow down the electrons too much or too little, there's not enough or too much energy in that part of the project. So what we need to do first is bend the wires so that the resistor fits in the board. And wires on parts are not called wires in electronics, even though they are wires. Electrical engineers call them leads. They lead to the part. So each lead, there's two here, each lead goes into its own pad on the board. And here's our one, and there's a pad here and a pad here. And to bend leads, just do it like this. And then when you're done, it's sort of like the shape of a staple. I have a picture here as well. And then we can insert it into the board. The kit in the picture is not the ArduTouch, but it's the same for all of them. So here is me putting the resistor into the pads for R1. I'll push it down all the way till the part touches the board, like that. And now while I'm putting my finger on it, I'll turn the board upside down. And then I'm going to bend the wires out halfway. And this picture might be easier to see if it advances. There it goes. And that's the way it looks. You can see that here. You don't want to push them all the way, because then after we solder, it's going to be hard to cut the excess wire off. Just do it halfway. And the reason why we want to do that at all is because we're going to put the board, leave the board upside down, and we're going to solder the parts on the bottom. On this kit, it's not true for all kits, but on this kit, every single part gets inserted on this side of the board. And you can see the markings, the white print on this kit, on the blue background. All the white outlines show the shape of the part that we're going to put there. And on this kit, all of the parts go on this side of the board with those shapes and the markings. On the other side of the board, we're going to solder all the parts one at a time. Okay, so there the part is in the board, and it's pushed in all the way, and now it's ready to solder. So you need to know how to hold a soldering iron. This has now been plugged in for more than 2 minutes, which means that this is 350 degrees. 350 degrees is a lot of degrees Celsius. It's hot enough to melt this solder wire. Here's some solder wire that's on the spool. This is an alloy of metal that melts at 185 degrees C. So you can see that, let's see here, if I melt this, see the smoke coming up. Maybe you can see it better here. It melts that. And in order to use this well, you should have a cat who's curious about it. and not go into it and start playing with the parts. Okay, so you hold it like a pencil, but you want to hold it only on the plastic, of course, because if you touch any of the metal, you know what happens. And you want to hold it underneath like a pencil. When you use a pencil or a brush or a pen, you want to be able to control where the tip will go. And if you hold it like this, then you can perfectly aim the tip wherever you want. And use your right or your left hand, whichever is your main hand for holding the soldering iron. And then you want to hold the solder with your other hand. But let me talk about solder now. Put this back in the stand where it won't roll over on my lap, which no one seems to like. And solder comes in many, many forms depending on what you want to do. With electronics, the perfect solder is either 60-40, like it says here, or 63-37. And that means the amount, 63-37 is also good. That means the amount of tin versus the percentage of lead. So this is 60% tin and 40% lead. And the one I have in my hand is 60-40. So, but 63-37 is also good. And they make solder of various different metals. They have stuff with silver, which is good for making jewelry. They have stuff without lead because lead's poisonous for mass production. And they have various chemicals inside of the core of this wire. The chemical inside is called flux, no matter what kind of solder it is. But the flux can be various different kinds of chemicals. In this case, it's mostly sap from a pine tree. And that smoke that you saw was the vaporizing sap from the pine tree, and that's called rosin. Very similar also to what's used for making violin and cello bows sticky to vibrate strings, except this is a paste and that stuff is a solid. This comes in various diameters. I like using 0.031 inches or 0.7 millimeters or thinner. And this is 0.5 millimeters, which is really nice. But it's really important to use solder with lead for do-it-yourself electronics. Even though lead is poisonous, we don't use very much of it, unlike mass production. And lead washes off your hands very easily, and I'll show you that slide soon. But the flux for lead-free solder is really noxious. When I use that, sometimes I don't really have much choice. My lungs hurt. So your mileage may vary, but that's my super strong recommendation. Avoid lead-free solder for do-it-yourself. It doesn't flow well, it corrodes the tip, it hurts your lungs, and all sorts of nasty stuff. Next slide. So there's 3 safety tips for keeping soldering safe as well as easy and fun and useful. The first one you already know, the tip is hot. Every time you touch the tip, here, you will let go very quickly. I guarantee it. That's because pain tells you it's a bummer, so you will let go quickly. And every time you do it, you will. And you will. It just comes along with soldering. You make mistakes. And but this sponge here, is just a regular kitchen sponge, cut a little small, but the cellulose sponge, not the plastic kind. The plastic kind melts. So this is cellulose made out of plants, and it's just got regular water on it from your faucet. That's kind of cold, so when you burn yourself, touch as soon as you can, quickly touch your burn to the sponge, and it will heal quicker. That's part of the bummer. So lead rubs off very easily on your fingers when you use when you solder. So we have the solder. I'm touching the roll now. There's now lead on my fingertips because it rubbed off from here onto my fingertips. It does it very easily. And then if you touch food, it's on your food and you eat it, it's in your body. Once it's in your body, it's a heavy metal. All heavy metals go through your blood-brain barrier into your brain and stay there. And you can never, ever, ever get rid of it. And it accumulates. And if you get enough of it, then your brain chemistry stops working and you get very aggressive, and that's called lead poisoning. And nobody likes you when you're very aggressive, so you lose all your friends. But if you want to keep your friends, all you have to do is wash your hands after soldering and before you eat, because it rubs off super easily, just as easily. It rubs off under soap and water. It's very easy to keep your hands clean. The hardest part of soldering is remembering to wash your hands after you solder, because it's easy to forget. You're all excited that you got your thing working, and then you forget to wash your hands, and then you eat a little bit more
Hello, Mitch. Can you hear me?
Sorry about that. My Wi-Fi glitched out. I'm getting video back. Okay. So that should get me back. My phone's been on this whole time, but hope I gotta allow one more time. There we go. Joys of remote conferences. So sorry about that again. Yeah. Anyways, again, just wash your hands before you, after soldering and before you eat, and it's always going to be safe. And let's see. Oop, I don't have the. Are the slides showing? Let's see, I don't have the. Oh, I need to be made presenter again. Can someone make me presenter? Yeah, the phone's going to be dark until I make use of it, but someone has to make me presenter so I can control the slides. There we go. Maybe. Okay, thank you. Yeah, so the third safety tip, you got it right. I'm cool. The phone is the other Mitch, and yeah. So there are 3 safety tips. The first one is the tip is hot. The second one is lead is poisonous. Wash your hands. And the third one is when we use the wire cutters. Where'd my wire cutters go? too much stuff on my desktop, including a cat. Anyways, the wire cutters are here somewhere. That's the third step, which is coming up really soon now, and we'll get soldering momentarily here. There's also 2 secrets for good soldering, which I'll show you the first one now, and the second one when we get to it when we solder. The first one is keep the tip clean. So to keep the tip clean is sort of a 2-step process. So here's the soldering iron, and here is the tip of the plastic. I'm going to bang here 3 times so that any excess solder that collected on the tip gets sent to the table. So like this, and we get that here. Okay, so I'm going to bang here 3 times. Okay, and then you can see right here the excess solder that hit the table. And on the table, it's totally fine. It hardens, and then you can move it away. If that landed on the board accidentally, it could make a connection between 2 pads, and that's a connection we don't want, and then the project won't work. So we want to bang the excess solder off first, then go to the sponge, and here we go. Push down hard and scrape. Rotate the soldering iron to the other side. Push down and scrape. And now the tip is nice and shiny silver. Where's the camera? Here. Out of focus, but shiny and silver. If it's shiny and silver, then the heat will flow well from the soldering iron to the solder wire and the parts you're soldering to. So if the heat flows well, we solder well. If the heat doesn't flow well, we don't solder well. So keeping the tip clean is super important. I gotta plug my phone back in. Cool. So it's bang, 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 swipe, rotate, swipe. That we need to do before every solder connection, because the soldering iron tip is at 350 degrees and the oxides, the metals on the tip oxidize quickly. So we want to be sure to clean the tip before every solder connection. And later on, I'll show you one exception to that. Oh yeah, so this is the speed of it too, when you do it for real. We're going to be doing it a lot, so get used to doing it quickly. Let me push the sponge in a better place and get some wires out of the way. So it's like this. That's how fast it goes. All right. And it's okay if you do it a little slower. It just saves time. Okay, so now to solder, let me go through the pictures first, and then I'll show you on my actual board. So I lay the soldering iron down almost horizontal, and you can see here it's just the tip of the soldering iron touching the pad and the lead. And I'm going to feed solder in here. Is that, yeah, I'm going to feed solder in there, and it will melt. And it's really important that the solder melts on the underside of the tip. If it melts on the side of the tip or the top of the tip, it doesn't do any good. We want to melt on the underside of the tip. Back to the picture, where the solder will melt on the pad, and on its own, it will slowly flow. The melted metal will slowly flow around the lead and make a good connection between the pad and the lead. Okay, so the next picture shows the solder being fed in. In order to be sure that the solder is melting on the underside of the tip, I'm scraping the solder along the board so that it aims right here. It's going to touch just to the right of the lead to touch the hot tip. If the tip is clean, then the solder will melt instantly when it goes in there. And then I'm going to push in about 2, 3, 4 millimeters of solder. Depending on the size of the pad, you can put in more or less. And don't worry about how much really, just, like 3, 4 millimeters is fine. We push the solder in, keep the tip down, pull the solder away, and then keep the tip down another second to let the solder flow and then lift. Okay, so the next one slide shows the solder being melted, and you can see some of the smoke coming up here above the soldering iron tip. And then I push in, like I said, about 3, 4, maybe 5 millimeters, it doesn't really matter. And then if the slide changes, there it goes. Pull the solder away. Keep the tip down though, because if you lift the tip up, the solder doesn't have time to flow. Keep the tip down for about a second more. Then you can lift the tip. This is the second secret of good soldering. Keep that tip down for a second after you take the solder away. And I'm going to go over that again with the camera. Then you lift the soldering iron and you have a perfect connection. So here's the thing. You have to get this rhythm down. Let me show you this one other thing too. I have a solder on a roll here. It's easier, I find, if I take the solder and then take 3 fingers, wrap it around 1, 2, 3, 4, 5 times or so, and then I can just break the solder off. And now the solder is in my hand like this. I can actually hold it better like this. Just hold it this way. And now I can aim this, just like the soldering iron, I can aim this to wherever I want. Aim the tip of the solder iron wire wherever I want. So I have this in my left hand since I'm right-handed, holding the soldering iron in my right hand. The first step of soldering is clean the tip. So I'm going to do bang, 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 swipe, rotate, swipe, shiny tip. So here's the rhythm. Put the tip down where you want to solder. Push solder in, melting under the tip. Pull away, keep the tip down, then lift. So here's the rhythm. Clean, down, push, pull, wait, lift. Oops, I accidentally changed slides. So again, clean the tip, down, in, out, wait, lift. Clean the tip, down, in, out, wait, lift. And that's the actual speed right there. Clean the tip, bang, 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 swipe, swipe, down, in, out, wait, lift. Got that? That's the rhythm. If you got that rhythm down, your solder connections will be perfect every time. Okay, so if you did that right, then there will be solder totally covering the pad, just like in this circled outline here. And if you look on the side, it will be a teeny little mountain. If it's flat, you didn't put enough solder in. If you can see any of the pad, also you didn't put enough solder in. If you have too much solder, let me go back one slide. Then there might be a blob of solder that connects two pads together. If two pads are connected together, that's a connection we don't want and it won't work. So if that happens, it's really easy to fix. Clean the tip and then just swipe it across where you don't want the solder. The solder usually sticks to the tip and then you can clean the tip and it's all fine. You might have to do that 2 or 3 times, but that clears it. If you have not enough solder, like you can see some of the pad or you can see it's not a little teeny mountain, then you just add more solder. Just do it all again as if you're starting from 0. You don't have to take the old solder away, just add more. Clean the tip, put the tip down, add solder in, pull it away, wait a second, and then lift, and then it should be fine. Okay, so, and then if you have 2 perfect solder connections like here, then you need to cut the wires short if they're long enough that they can bend over and make a connection to something that you don't want. And if they make a connection you don't want, of course, then the project won't work. So what we want to do is cut the wires so that there's no leads sticking up from the board. And that's the next one. And so you use the flat part of the wire cutter down. Where's my wire cutter? Here. Wire cutter has 2 sides. So you can see the wire cutter here, and this side is flat. This side has a deep groove. We want the flat side down, and we also want to cut with the tip of our wire cutter, where we have the most control. But, and you don't have to be really careful with this, just put it down to the bottom and then cut. But notice that I'm holding the lead with my fingers. If you don't do that, when you squeeze the wire cutters, they snap shut, and then this lead turns into a missile and goes right in your eye. They like doing that. So please don't do that. Your eyeballs don't like that, and it would be nice to keep your eyeballs. So yeah, if you hold it, it's always safe. And if it's too short to hold, just cover the little teeny piece of wire with your finger and then cut. And then the little piece of wire won't go flying in your eye or someone else's eye. Okay, so that's how to solder. And so we do that one part at a time. And oh, and that's the third safety tip, by the way. We do that one part at a time until we're done. Here's a part that's finished. I think the next slide is actually the RDTouch board with R1 done. Yeah, you can see the two leads are soldered, they're cut short, and those are two perfect solder connections, little teeny mountains that cover up the pad. So let me do this now. And when you solder, you can rotate the board whichever way is good for soldering. Here's the, so I've got the soldering iron and I've got the solder, but the first thing I have to do is clean the tip. So I'll bang, 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 swipe, rotate, swipe. So now the tip is shiny silver, ready to solder. And then let's see, let's get that in a place where can you even see that? I don't know. Let's try it this way. Yeah, that works better. I'll put that down. I'm going to rotate the board though, so that my soldering iron is only touching one pad. So I put the tip down on the pad, and in my case, just to the right of the lead. Hold it there 1 second. I can't do both, so I'm going to feed solder in here. Pull away. Remember, hold 1 second and now lift. Okay, and now here's the solder connection. And this part has two leads, each going through its own pad, two pads. And I'm going to do the other one. I'll clean the tip and now do the other. Hold a second, feed some solder in, let it flow, lift. Okay, now I'll put that down. Now you can see two good solder connections. And once the part's finished soldering, now I'm going to cut the lead. Let's see. What I'm going to change cameras here because I think the one on my phone works better than that. Let's make that one dark. That work? Yeah. So I'm going to hold this wire. Normally you just keep it on the desk. That's way easier. But since my camera won't let you see it too well, now I'm holding the wire with my fingers. And I, I'll cut that. And just push the wire to the side where it won't be in the way. And I'll do the other one. Let's see. Do it so you can see. Oops. Okay, yeah, there we go. You can see it. Normally, like I said, you just leave it on the table, so you can do it much easier. So I'll do it like this. Hold the wire. Get this way where there will be a shadow. Yeah, it's hard to see, but anyways, I'm holding the wire, now I cut it, and now the wire's in my hand, and I'll just set it out of the way. And now here is the board with the 2 solder bumps, little teeny mountains, and that part is done. R1 is done. So that was a lot of talking for something that's actually very simple. So it actually goes very quick. I'm going to do the next part in real time, and you won't be able to see the details, but you'll be able to see that it's actually really quick. So we do one part at a time until we're all done. And when it's all done, it looks like that, and then you can turn it on and it works. And if it doesn't, you get to learn to debug. But it should work. If it doesn't work, it probably means you put a part in the wrong place or the wrong direction or a bad solder connection or combinations. Okay, so let me do the next resistor, and then I'm just going to go through the parts and show you things that are important to know that might not be obvious as you go along. So let me do R2, which is 22 mega ohms, which is 22 million ohms. So the first thing that I do is bend the leads for a resistor and make it look the right shape like that. And now that goes into R2. Okay, push that all the way down. Hold that while I turn it upside down, and then I'll make the wires into a V so it won't fall out while I solder it upside down here. Now I'm going to clean the tip. And then I'll solder this one down, in, out, wait, lift. Clean the tip. Rotate the board so it's nice there. And now down, in, oops, in, wait, out, wait, lift. Okay, and now those 2 leads are soldered. And now I'll cut the leads. And that's it. So R2 is now soldered and leads are cut short. So I won't do all of the resistors now, but those are the color codes for the various ones. And this picture down below shows where all of the resistors go once they're soldered in. Ugh. It looks like I went away and maybe came back again. I don't know. Okay, yeah, so I've got to start my video again. The phone video is working. For some reason, my laptop's disconnecting and connecting. Okay, start sharing. There we go. Allow. You heard me, good. So anyways, you can see that's the speed that things go. Yeah, so it doesn't take all that long. Like I've been soldering almost every day since I was 6, so I can go probably faster than you'll go if you're a total beginner. but there's no need to go fast. What's better is to go to do it well. So you have all good solder connections, make sure all the parts are in the right place. All of them are on the top of the board in this kit, the right side of the board, the right direction, good solder connections, and then it'll work. And you don't have to worry about, oh, I need to be made presenter again so I can go to the next slide. It's the one that's not the listen only, one with the microphone. Thank you. Yeah, and then the microcontroller socket, there's some things on there that aren't totally obvious. You can look at the picture, that's easier than with the camera. You can see this side of the socket is flat on the right. On the left, there's where it's circled in blue, there's a little half circle sort of cut into the side. That's the top. And on the board, if you look down below where it's circled in blue here, is that same shape. And what you got to be careful of with the, here, let's go here. These pins sometimes are bent, or on this side. If they're bent, they won't very easily slide into the board. If you have to force it, then a pin might bend, one pin might bend over and not go through the hole, and then it's really hard to fix that. If you solder all the others in and this one's bent over, there's no connection between it and the pad, and so it's not connected to the circuit. So make sure you don't, when you insert the pad, or if it's a chip, that they slide super easily into the holes and the pins aren't bent over. Then you can turn it upside down, and there's 28 pins here, or leads, and you just bend two opposite corners out. You can use your fingernail, or you can use your wire cutter carefully. And all you have to do is two opposite corners. You can bend more if you want to, but then it won't while you solder. And I have a picture for that too. Yeah, this one shows you that the shapes are lined up on the left side of the board. And here you can see two opposite corners are bent over. And then we need to solder all 28 of these. But since these are all in a row, then we don't have to, oh, my video stopped again. Let me reset the video. So since those are all in a row, you don't have to clean the tip between every connection. Just keep an eye on your tip, and if it starts looking dirty, like darker gray or brown or blue or any other colors besides shiny silver, then it's time to clean the tip. But usually you can do maybe a whole row before you need to clean the tip. It depends on your soldering iron. Really inexpensive soldering irons, you need to clean the tip more frequently. And super fancy soldering stations, usually you can do it less frequently. But it's good to be in the habit of cleaning the tip frequently. And so since they're all in a row, it goes quickly. Even though there are 28 connections here, you can do all of that definitely in less than a minute. Okay, so that's the things I wanted to say about that. And then the capacitors, the little ones, I have them going in next. And you do one at a time though, that's better. And then you won't miss a connection, which makes it not work. And then those My video is still off. I see it on my end, on my phone, so yeah, my video's working. Okay, yeah. So these small ones, it doesn't matter which way you put them in. They can go in this way or this way. But then when you go to the next ones, the big black ones with the long and the short lead, it does matter. The short lead is minus, the long one is plus. Also, these look kind of similar. Here's the two different parts. I chose ones, sometimes they'll look exactly the same, but I chose some that are bigger and smaller just to make it easier for beginners. But the main thing is to look on the side, like in the picture, where it says the value. Here it says 100 UF. So, and that's for C3 and C8 is 100 UF. So these, and there's two of those. Where are they? Here. These two are the 100 UF ones. And then these two actually say 1 UF. And those are for C6 and C7. It's got, you got to be careful with that. And also we have a long and a short lead. So make sure that the long lead is plus. And on this board, not all boards, but on this kit, the capacitors, all four of the big capacitors, the long goes into the square pad. And you can you can see that in the picture here. Okay, so other than that, it's the same as before when you solder it. So there it shows the first two capacitors in, and now do the 1 microfarads. Again, the long lead is in the plus. Oh yeah, there's a little plus sign also next to the square pad. Other kits though, again, I'll stress, it might not be a square pad for the plus. It might be a square pad for the minus, or they might be both squares or both circles. But in this kit, it just happens to be square. But the long lead is marked with a plus and a short with a minus. Okay, so now we've got most of the parts in. And the LEDs come next. They're very much like the big capacitors with a long and a short lead. And again, like the capacitors, the long lead is plus. But when you do the first LED, and I'll do the LED now. So here's a blue LED. And it's got a long and a short lead. Oops. You can see a long and a short lead on the real part. I'm going to put that in. The long lead is plus. In this case, they're both circles, but the long lead is marked with a plus. Oops. You actually see, not really, but anyways, you can see in the picture on the slide. I'll put that in all the way. Put that, yeah, so I'm holding it in place so it's all the way down. Now I'm going to make this into a V, the leads into a V so it won't fall out while I solder them. And clean the tip. And I'm going to solder one of them down, in, out, wait, lift. I'll rotate the board so I can get the other side, clean the tip. Down, in, out, wait, lift. Okay, so now I've got two good connections. I'll cut the leads. And for this one, I'm going to save these leads. I've got those leads saved right here. And I'm going to use those for connecting my speaker in a later step. And I'll show you that. Because the speaker doesn't have any leads. So I'm going to add leads to the speaker so I can solder it to the board. And that comes up pretty soon. Do all the LEDs next. In this kit, we use, where's that connector? Here. This is easy to mess up, so I'll show you this as well. Here's the part. You can see at the top towards this finger, the leads are short, and then towards this finger, the leads are longer. We want to make sure that the long leads are away from the board and the short leads go into the board. Because this is how we connect the ArduTouch board to our computer when we want to program it. So make sure when you put that in, the short leads go in the board. And you want them facing away from the board so that you can connect the programming cable, communications cable to it. And you can see up here, these sort of go zigzag. That's to keep these pins, these leads are very, very stiff. So you can't bend them. Oh yeah, one thing I forgot to say, this part as well as the microcontroller socket, after you solder this socket in, do not cut the leads short. They're already short enough that there's no way they can bend and make a connection you don't want. And since they're already fine, no need to cut them. So don't cut them, because that just means you have an opportunity to hurt the board. So don't cut those. Same with these. Once these are soldered in, they're not long enough to make a connection, so don't cut them short. They're very stiff though, so that once it's in the board, you can't bend two of them out like a V. So I have these pads zigzagged so that it will be held in place. So you can turn it upside down. Oops, so you can turn it upside down without it falling out. But sometimes it'll fall out anyways. And if that's the case, then take your wire cutters and just gently, without cutting, take two of the leads, it doesn't matter which two, and then squeeze them together a little bit. And then those will, with friction, bite into the pads a little more, and then it won't fall out while you solder it. Okay, so I won't do that because soldering those is the same. No need to cut them short afterwards. And then next slide. Yeah, so that shows it's soldered in. And the push buttons, I've got 3 push buttons. One's black and 2 are red. The colors are totally unimportant, but I use the black one for the reset. On my board it's here, and then the 2 red ones for the right and the left buttons. And these, the leads are already bent the right way, but you might have to push in kind of hard to make them stick. And then when you turn it upside down, they won't fall out, and you can solder all 4 of those. And then you can do the 2 red ones. And then this part looks kind of like a capacitor, except that it has 3 leads. This is called a ceramic resonator, and it tells the microcontroller exactly how fast to go. And we need it to have fairly accurate timing for making music, because just a little bit too fast or too slow means that it'll sound sharp or flat, and that sounds nasty. So this makes sure the microcontroller goes 16 million times a second. And if you look on the part, it actually says 16.000, but it can't get it focused, so you can't see, but it does. And it doesn't matter which way you put that one in. Once you put it in the board, there are 3 leads, bend the 2 outside ones out, and then it won't fall out while you solder it. And then there's the audio chip, which is here. When chips are brand new, the leads aren't straight like this. They're usually like this. We need to make sure that they're straight and all parallel before we can put them in the board. And make sure that they're not kind of crooked either. They got to be straight and parallel. But notice here, this chip has a half circle indented into it. It also has a little black dot. Some chips, like this one, do not have the half circle, but all the chips have the black dot. And I don't know if you can see it, but the black indented dot is here. And either way, so the black indented dot says which is pin 1, and the half circle indented shows you the top of the chip. In this case, the top is to the left, and pin 1 is always to the left of that. And then pins on microcontrollers go counterclockwise, the numbering 1, 2, 3, 4, and then around the other side, 5, 6, 7, 8. The main thing is to know where pin 1 is, and that's the top of the chip. And if you look on the board, it shows there's a 1 right above my finger there. But the picture on the slide shows it easier. Whatever comes up on the computer. There it is. Oh yeah, so this just shows bending the leads. You can do it on the table, or you can use your fingers for this one. But doing it on the table makes sure that they're all straight. And now you can see they're all straight and parallel. And then here on the board, we have that half circle marking to show you the top of the chip. But the main thing is not all chips have that mark on it like this one, but they all have pin 1 indented dot next to it. So pin 1 is going to go here. The black indented dot is going to go here. And you can, it says 1 right here, but it's hard to see because the blue circle obliterates it. So anyways, you put that in. Again, make sure that it easily slides into, let me bend those in a little better. Make sure the chips, all the leads easily slide into the holes. And none of the pins bend under. And then with this one, you can, again, bend 2 of the leads out. And I just use my fingernails, but you can also use the wire cutter to do it. And then solder all 8 of those. And I have pictures for that as well, of course. The next one is this variable resistor. It's got 3 leads. It only fits in one way. It will only go into the board part way. But in order to put it in the board, you've got to bend the leads out a bit, and I have a picture for that. Oops, wrong. There we go. Yeah, so you got to bend the leads out a bit. So if I do that here. Okay, and then it'll fit into the board, the 3 pads there. Hold it and turn it upside down, and then you can solder all 3 of these. So I'm going to do that though for time. This is the volume control for the speaker. There is an audio output jack here. You can use it for headphones, but it won't be very loud. This is meant to be going into an amplifier. This volume control does not affect what comes out of here. It only affects the speaker, which will go here. Here it says speaker. Don't change that though. It's set right to the middle, which is where you want it. But you can, if you want to, with a small screwdriver, change it if you ever need to or want to. But I recommend just leaving that alone. And then next comes the audio output jack, which looks like a headphone jack, but it's really audio out, meant to be used with a regular headphone jack kind of connector. Okay, and that one, where's my connector? Here it is. It might not be blue, it might be other colors depending on which vendor I used. So that can only fit in one way into its holes. But this one, you can't bend these to keep it from falling out. So just rest it carefully on the table, and then you can solder it. But again, I won't do that for time. Oops. Yeah, so the microcontroller also has its pins. It's brand new. It's programmed, pre-programmed, but the pins, are not straight and parallel. So they're kind of like this. So this time you really do need to use the table in order to straighten them. Don't use your fingers, because then they'll definitely all be kind of wonky. If you use a table, then when you push it against the table, they can all be bent at once. And using 2 hands is way easier. So do it a little bit on that side, a little bit on that side, and then all the pins are straight and parallel. And I have a picture for that. And if you bent them correctly, then it will fit, each pin will fit nicely in its hole in the socket. But this chip does have the half circle here and not here, just like it shows in the picture down below here. It's really important that you put the chip in the socket the correct way, just like you put the socket in correctly with the black, the half circle in the socket is here. You can't see it anymore, but the half circle marking underneath it is underneath it there. And then the chip half circle has to match in there. So when you put it in here, just rest it. And if you can see, oh yeah, and then check this out. This pin is bent out too much. So I've got to bend that in just a little bit. Okay, so now if I rest this in the socket in the right correct orientation, each pin goes in its hole nicely. If it doesn't, you might need to bend the wire, the pins, the leads out, or bend them in, make sure they're all straight and parallel. And then with 2 thumbs, just push down and it slides into place. And you can see they're all slid into place on both sides. And it feels really nice as it slides in. So I have pictures for that too. Yeah, so when I did my pictures, I was holding the camera in one hand and trying to push with the other, but use 2 thumbs is definitely better than just using one. Okay, so it tells you to inspect all the pins, make sure none of them are going to bend under before you push it in. And then the 2 knobs, the variable resistors. There's 3 leads, they only fit in one way. When you put them in, there's 3 leads, bend them out so they won't fall out while you solder, and then cut them short. And that's, I think, all the parts now. So now we've got to, except for the speaker, so we've got to put the leads on the speaker. And that's where my 2 extra leads come in that I set aside from the LEDs. And the LEDs are good for these because they're stiffer than the leads from the other parts. So you can see I've got a lead here and a lead here. And I need to solder them in to my speaker. And notice here on the speaker, let my little red dots catch up with me. There's a hole, and here is a solder blob. And here is a hole and a solder blob. We want to connect those leads to the solder blob, not to the hole. And the picture makes that clearer. Some speakers look a little bit differently. So there's the 2 leads. This lead is going to go into this solder blob. This lead goes into this solder blob, and this lead goes into this solder blob. In order to do that, we have to melt the solder blob with our soldering iron, and then push the lead into the melted blob, and then let the blob cool down and harden, and then there's a lead there. You've got to do that somewhat quickly so that you don't burn yourself, and I'll show you how to do that. But to make it easier, it's nice to tin those leads first. And tinning just means adding a thin layer of solder on it. And to do that, clean the tip, just like normal. And then add a little bit of solder on the tip. Okay, I'll do that here. Okay, it was probably hard to see, but you can see it better maybe in this the picture on the slide.